Hello everyone. Hope you all are having an amazing day. To make your day even more interesting, we at Intellipaat have brought a latest video on PySpark.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
PySpark is an amazing language which helps in performing exploratory data analysis, in building machine learning pipelines, and also in creating ETLs for the data platforms. All the companies who deal with huge data use Apache Spark as their part of their solution strategy. Therefore, the demand for big data and PySpark is booming every year. So now it's the perfect time to learn about PySpark. After watching this video, you will become familiar with Apache Spark, big data, and Python concepts. So without any further ado, let's see the agenda of the day.
What is big data and why it came into picture. So as the name itself says, right, big data, it is something, a problem that is related to data growing huge, right? So that is exactly what happened. So earlier on, we used to have standalone servers, right? Like we used to have a MySQL server or Microsoft SQL, MS SQL server, or Postgres, or any database server, or any data warehousing server, right? They would all be single node, meaning they're not parallelly distributed or they're not parallelly processed. It's a single machine. So single machine is taking the data and pushing it into the database, right? And the database is held in some hard disk or some part in the hard disk. So this is our earlier process. But what happened as the data kept growing, the database or the table kept growing. It was difficult for people to process. Even a simple select star command, it would take hours to give the data. Right? So and at the same time, the memory wouldn't be enough, right? Because what happens when you do select star, the data is fetched from the table which is on the hard disk, and that is put onto the RAM, and from there you see it on your console, right? So that is how it works. So now, while the data has to be transferred from the hard disk to the RAM may run out of memory, or the data is so huge that the transfer itself will take a lot of time, right? So these are the problems that came into picture for people who are working with data warehousing solutions, right? So data warehousing is basically for what? Analytics. So they want to have historical data, they want to have current data, and based on the historical and current data, they want to build a pattern, and they want to do some analysis, they want to predict the price of a stock in future, and so on and so forth. So for that kind of analytics, they need a lot of data, and that's why they had built this data warehousing solution. Right? But they're all on single machines, right? That was the biggest problem. The data kept growing, and they could not support the infrastructure. The data would go beyond the hardware storage, right? The storage would be hard disk, and if, let's say, if it is of 1 terabyte, or let's say even if they had a very customized hard disk of 1 petabyte, or 10 petabyte, or 1024 petabytes, something like zettabytes, whatever it is, at some point of time they would run out of that hard disk storage, right? At the same time, for processing, the data has to come to RAM. RAM may have been for 32 GB or 64 GB. It is still running out of that memory. Right? So every time that happens, what the infra team would do, they would buy a new hard disk or a new RAM and augment it with to this server, and so on and so forth, right? Or they would customize it, which is much more like a costly affair. So that single server system or the single machine system was proving to be costly for people handling big data, huge amounts of data, right? And at the same time, data kept coming in different formats. Some would come in a text file, some would come in a JSON file, some would come in a CSV file, some would come in a XML file, and so on and so forth, different formats. And at the same time, some of them may come in a structured format, some may not come in a structured format at all, right? So these kind of complexity started coming into picture, and people decided the current tools that we have, current infrastructure we have, it is not suitable. So let's go into distributed processing. At the same time, we also want distributed storage, right? So everything should be parallel. Okay, parallel storage, parallel processing, right? So that is why they built a framework called as Hadoop. It was done at Google Labs, right? I mean, it was a combined effort, a lot of people working parallel, but Google's NDFS was the key point, right? And later on, it became an Apache top project. But that you have to see where the problem came in. The problem was with the existing single machine or single server system, right? So what is big data analytics? That is nothing but what we were doing earlier. Only thing is now the data has grown so huge, you're not able to analyze the pattern and everything using the single server system. So we have moved into a multi-node system when which all the data storage is parallel, data processing is parallel. So we can process the stored data and find out the existing pattern, and try to predict what the future would look like, right? So basically data, whatever data analysis you've been doing, that's the same thing, only thing it's done in a parallel environment. Okay. Some of the examples, huge amount of data. I mean, the reasons why big data came into picture, right? Facebook was the earlier company or pioneers in big data technologies. Facebook, LinkedIn, Twitter, right? So you'll normally hear these kinds of companies because they were genuinely dealing with big data, right? Every year they used to add millions of users, and millions of users would add photos, posts, and everything, right? So their data would grow every day. For every day, they would consume around 4 TB of data, right? So they had huge amount of data, and the data were also in heterogeneous format, right? Meaning some of them were unstructured, as I told you, some of them semi-structured, and some structured. At the same time, they are coming in different formats, right? And then accessing and processing speed, like if you have a 100 Mbps IO channel, you can only process 2 TB of data. So it will take around nearly 6 hours to just process a 2 TB of data. So they had all these problems. So they had to find out a way to move out of this. So that is why these companies, Google, Facebook, LinkedIn, they all came to picture, and they started building something that would solve their problem. Right? For example, Facebook had 2.3 billion monthly active users, right? And they had 250 billion photos uploaded to Facebook, right? 350 million photos per day, right? That would be 4 PB of data. So this is what I was talking about. Every day they were generating 4 PB of data. So now just imagine you had a single machine server with 8 PB of data, hard disk space. Facebook would run out of space within 2 days. Every 2 days, they have to keep on adding hard disk, and they have to find a way how they can keep on, increasing the storage, right? It's not like you have a 8 PB, 100 PB hard disk available on the market. You'll have to build something on your own, right? So that is again a problem. Okay, so that all these problems were existing with the single server. So people decided we'll move into a parallel environment, parallelism, where we can use parallelism for processing and storage. So who all are using every firm in today's time is using big data for their analytics. Okay, they've moved on from this single server data warehousing solutions, right? And they're also moving on to cloud. So cloud big data solution is now a big market. 80% of the digital how do you say domain is conquered by big data analytics on cloud. Okay, there's a huge market, huge demand. You can ask for 200 300% salary hike, right? I'm not joking, because when I jumped from Cognizant to the current company, I got around 120% hike, and now it's just been 6 months. Even if I jump now, I'll still get 100% hike. So that's the kind of market that is available for big data. I'm not saying that because you're doing the course, you can check it out. People within digital domain, they're doing really well. And it's not just big data on cloud. There are others like React JS developers and front end like UI UX developers. They are all heavy demand, right? You must have heard Cognizant lost 200 million worth of client because they do not have big data developers. Right? So that is the kind of market, especially in these 3 months. There's a huge demand. People are taking lateral hires left and right. They're not looking into. I mean, they are looking into freshers who can learn big data, but at the same time, they're hiring lateral people. In my company, a lot of people from data warehousing background have switched on to big data. Right? So that is the kind of market. So everyone today is using big data. There's no doubt about it. I don't see any company that says, okay, we are going to sit with the existing legacy server that is on our on-premises. Even if there is coronavirus, we'll still be able to function without any problem. I don't see any company saying that. Right? So what are the 5 V's of big data? So we have velocity, the high speed at which the data comes in. As I was talking about live streaming, right? In today's time, IoT, Internet of Things, is a big thing, meaning there are a lot of hundreds of thousands of IoT devices that are generating data per second, right? And you want to make sense out of it, right? And for example, let's not go into IoT. Let's not invest IoT. Let's go into whatever we are doing earlier. So we have a company of 1,000 employees, and all the thousands employees laptops logs are being stored in a central system, right? So previously people were not bothered because the logs that are being generated, they were in huge demand. I mean, they were huge, right, in terms of size, and processing them was difficult task. So people never used to bother about reading those logs or trying to create a script that would do it and try to do some analytics over it. They would only look at it when someone would do something mischievous, or someone's laptop has been destroyed, or something has happened, right? So that is the only reason why they used to store logs. But now with the help of big data, they can store it, they can process it parallelly. So with that kind of power, they decided, okay, fine, we will analyze each and every user's log every second that it is generated, and find out, okay, if this guy is doing some copy paste from Stack Overflow, or he's copying from client VDI to his own personal laptop, and all those things we can do analytics. If he's using YouTube or Facebook, how many hours he has logged in, all this kind of analytics is happening in today's time because of big data, right? So the velocity of data, the speed at which the data is coming in is humongous. I mean, it's very fast, and the big data infrastructure can handle it. Okay? Earlier systems were not able to handle it. Then we have volume, of course, as I talked about, huge amount of data being generated. There's a saying that in the last 3 years, the amount of data that we have generated is almost 97% of the entire data, right? So if we had generated millions of zettabyte of data, 97 million, I mean, 97 million zettabytes of data were generated in the last 3 years alone. Okay. So data is growing exponentially. So today you might be getting a file of 100 MB. By next year, that 100 MB file would be 1 terabyte. Okay. So that's the kind of volume that you'd be seeing, right? So that is why people cannot use the existing single machine servers. So that is where big data solves the problem. Then variety of data. This is what I was talking about. Different kinds of data. It can be semi-structured, it can be structured, it can be unstructured, it can be, as I told you, log file. It's a completely unstructured data. When I say unstructured, there is no structure. It's just basically plain English sentence, right? Whereas when you say structured data, it comes in a table-like structure, right? So it has a structure, it has fields, it has columns, it has rows, so you know it's a structured data. Semi-structured, on the other hand, it is very similar to structured data, but like it may have rows where there are only 3 columns. It may have rows where there may be 5 columns. We call it NoSQL, right? So that is semi-structured data. So we have that kind of data as well. And at the same time, various different sources of data, right? You may be generating data from a CSV file. I mean, the data may be coming in a CSV format. It can be coming in JSON. Today's time, we have a couple of formats that reduces compression, like Parquet, Avro, and other kinds of ORC, right? And all of them can be, analyzed and can be processed using our big data infrastructure. And the next part where the big data solves the next problem is veracity. So veracity is the inconsistency in the data. So we were talking about live data, right? So there's a chance that someone is talking about Modi on Twitter at 8:31, right? And we are just streaming the data. Okay, we got around 10 people who are talking about Modi, and we want to do our end goal is to find out how many people from different parts of India are talking about Modi, right? So we got someone from Karnataka, we got someone from Madhya Pradesh, we got someone from Delhi at 8:32. Okay, but the same data may not come at 8:33. Nobody may be tweeting about Modi at 8:33, right? So there is an inconsistency of data that is coming in, right? So that is what we call it veracity. So for that also, big data solves it. Big data has inbuilt functions and inbuilt functionality that will help you to resolve this problem. Okay, and the last part is the value. Okay, so let's go back to the previous example, the log example that I was talking about, right? So we added value there. Earlier, in a single system, in a single server system, you were just dumping the data. You were not doing anything unless there was a ticket from the what do you say, the employee, or from the employer saying that look into this guy's laptop activities, right? Until there was a ticket, nobody was bothered about looking into the log files, right? So but now we have automated a process which is extracting the live data of the logs from every a single employee, and we are doing 100 different analytics on each employee. We are trying to find out if this employee's productivity is good or bad, if he's copying data from some place to other, or is he creating fraud. All this are nothing but value, right? So there were billions of petabytes of data that were being generated earlier on, but almost nearly 90% of them were useless. It was just a data dump. But now with help of big data, we are able to add value to it because we are bringing in parallel distribution, parallel processing, right? So this enables us to process and store big data in parallel devices, at the same time process them parallelly so that the amount of time taken is not huge, right? So entire at the end of the day, all this five V's is basically because big data is able to solve this problem. Parallel, it is able to store, so the storage copying a file won't take hours together. It is being copied to a different parallel. It's being stored in different machines, right? So the storage is not being run out of. I mean, you're not running out of storage. At the same time, while processing, five different machines are processing different data of the same file. I mean, different blocks of data from the same file in five different machines, right? So if a single machine was taking 5 hours, five machine is taking only 1 hour, right? Together. So that's how parallelism works, right? So that's the basic concept of parallelism. So because of that, you can solve all of these problems. You can solve the problem of velocity, the speed at which the data is coming in. You can solve the exponential growth of data that is coming in. You can also solve the different formats of data that is coming in. You can also solve the problem of inconsistency in data that is coming in. And you can also solve the problem of not having any value for existing data. Right? So this is the five E's of big data, and generally this is one of the questions being asked in interview. I mean, it was being asked 4 years back. I'm not sure whether that is the case now. Okay. So what is Hadoop, right? So I was talking about people not developing a framework because they had all these problems, Facebook, Google, and everybody, right? So Google decided, okay, boss, single server system is useless. You can build your own mega server, and still you will run. Someday you will run out of RAM. Someday you'll run out of hard disk, right? So that was very clear to them. So they started working on the parallelism concept, right? So where the storage where a file can be broken into different blocks, and each block can be stored in a different machine, but for the user, whenever he wants to read into the file or write into the file, it should look to him that as though he's writing into a single file, right? Even though the single file has been cut into different blocks, and each block is stored in a different machine in a cluster, right? So we have to create such kind of framework that enables the user to do that, right? At the same time, if the user wants to process this file, each of the five blocks that are there in those five machines should be processed individually, and the result have to be collected and sorted out, or done some aggregation should happen on it, and the final result should be equivalent to what you would have achieved when you are doing it in a single server. Only thing, it should be faster, and at the same time the RAM and everything should be supported, right? So that is the kind of framework Hadoop is. So Hadoop has three different components. Okay, one is called as HDFS, Hadoop Distributed File System. Okay, then we have a processing sub framework. Okay, so Hadoop has three components. One is the storage part, okay, storage layer. The other is the processing layer, and the third is a resource manager. Okay, so MapReduce is the processing layer of Hadoop, and Yarn is the resource negotiator. Okay, it's called as yet another resource negotiator. So let me go one by one what each of the components are. So HDFS, by the name itself, it says Hadoop Distributed File System. It is nothing but when you have three machines. Let's go with the example, right? So you don't think of them as virtual machines, think of them as three physical machines. Okay. So you have a Hadoop cluster with three machines. One is the master, two is the slave, right? You put a file, you put a CSV file into this 200 MB file, let's say 228, let's say 228 MB file. So what happens? Hadoop splits it into two blocks. Okay. So it will say, boss, block 0, you write it in the slave 1 hard disk, and block 1, you write it into slave 2 hard disk. Okay. And then that data, that where each block for that particular file is kept, is stored in the master. Okay. So master will maintain a table where in which it will say, okay, for students performance CSV file, we have split into two blocks. First block is in slave 1, second block is in slave 2. Okay. So this is all about Hadoop's distributed file system. So tomorrow when someone wants to read it, for him it will look like it's a one big file, okay, but in the backend it will be split into two, right? So you can imagine if you have a cluster of 10 nodes, the file will be split into 10 different blocks, and each block may reside on each machine's hard disk, right? So that way tomorrow, even if the data keeps growing, you have 10 different machines, right? So, and at the same time, parallelly you can scale the cluster itself. You have 10 node cluster today, you can make it 11 node cluster tomorrow. And they're not some special machines. They don't need special hardware or special software. You can buy it from the market. You can just go to Amazon, click on a laptop, buy it, connect it to your existing cluster, done. Your cluster now has 11 nodes. Tomorrow, you again on this 11 node cluster, you're running out of disk space. Again, go to Amazon, buy a laptop, connect it to the cluster, done. Okay, so that's how you can keep on scaling horizontally, right? With the single system, the problem was every time you have to build a hard disk, right? You cannot have a 4 terabyte hard disk, you cannot have a 16 terabyte hard disk at a go. You have to buy it from somewhere, then you have to customize it, then only you have to connect it back to the server so that that particular hard disk is having 16 terabyte or 32 terabytes worth of memory, right? So all those circus you don't need to do here. With HDFS, you just keep on adding machines with Hadoop. You can keep on adding machines, and your cluster will keep on growing, right? So yeah, coming back to HDFS. So this is how HDFS works. So this is parallel storage. This layer is parallel storage layer. Then we come to MapReduce. So MapReduce is the parallel processing framework within Hadoop. Okay. So when I talk about framework, Hadoop itself is a framework. Okay. Framework means what? It gives you functions to achieve a goal, right? So Hadoop is a framework that helps you achieve parallel processing and parallel storage, right? So parallel storage is done by HDFS. Parallel processing is done by MapReduce. So now HDFS has stored that student performance.csv in these two machines. So when MapReduce is asked, let's say your the client's goal is to read the number of give me the number of students who are male, right? So you do a count on male. So you write a MapReduce program in such a way that you read the CSV file and you only count the number of rows where the gender is male, right? You can write some function like that. Unfortunately, it is not done in Python, so I cannot show you. Okay, MapReduce is generally written in Java. Entire Hadoop, the entire framework is written in Java, so MapReduce only supports Java. But now they say even it supports Python, but I've not worked on that. Right? But I'm just giving an example. So it will read each line of the CSV file from both the blocks on two different machines. So block 0 was in slave 1, block 1 was in slave 2, right? So processing also happens on these two machines only. So MapReduce will run on this machine. At the same time, MapReduce will run on this machine as well. Okay, MapReduce will make sure. So you will submit that MapReduce job to this master. Master will say, okay, boss, there are two blocks for this particular CSV file. So on both the blocks where the block is stored, on both those machines, you run your MapReduce program. So it will send the MapReduce program, and the MapReduce program will start executing on that particular machine, right? So slave 1 will be running MapReduce program for block 0. Slave 2 will be running MapReduce program for block 1. At the end, once the result is generated by both of these slaves, it will be combined and some aggregation. For example, in this case, it will do a sum, right? So there may be 20 rows in this particular block 0 where the gender is male, right? Here there may be 30 rows. So that is what the output is of each of the MapReduce program. But while submitting it back to the master, it will again do an aggregation, because it says total number of male candidates in the CSV file, right? So it's not asking per block. So it will add it 20 plus 30, 50, and that is what the result will be passed to the master, and then master will pass it to the user, right? So that is what MapReduce is, and that's how it works. Okay. Then we have yarn. So what is yarn here? This is a very important component that goes beyond Hadoop. Okay. So resource negotiator, why do we need it? So I was talking about master sending the MapReduce to both these slave machines, or master splitting the CSV file into two blocks and storing it in slave 1 and slave 2, right? So how does it come to know that there is enough space in slave 1 and slave 2? Does it know that is it keeping any track saying that okay, slave 1 has 20 GB free, so I can store this block here, or slave 2 has 10 GB free, so I can store this block here? So it doesn't have those information. So for that we need a third component called as yarn. Okay, so that is the resource negotiator. So in between the slaves and the master, there's a resource negotiator who will come, who will take the request from the master. Master will say, boss, I have a CSV file worth of 200 MB. Okay, I am going to divide it into two blocks. Okay, give me two different machines in this 10 node cluster which has enough space to store these two blocks of 100 MB each, right? Then yarn, the cluster manager, will traverse through all the machines in the all the slave machines in the cluster, and it will come back and say, boss, I checked all the machines. Slave 1 and slave 2 are ideal for your requirements. You can send those two blocks into those particular machines. Then master will send each of the blocks to these two machines, right? So that is the role of your resource negotiator. Okay, and at the same time, one more important functionality I forgot. So the most important functionality of yarn is yarn will keep on tracking each of the slaves. Okay, so there may be a time where slave 2 some short circuit happens within the particular data storage place, right? These servers are basically stored in what do you call it, in a rack. Okay, we call them as rack in data centers, right? So there are data centers, within that there are racks, within that racks there are servers, right? So one of the rack may have a short circuit, right? So slave 2 may be in one of the racks, slave 1 may be in a different rack, right? So slave 2 falls down. Okay, so the cluster needs to know, right, that slave 2 has gone down. So who informs that? Yarn does it. Yarn keeps on doing a heartbeat check. Okay, every 2 seconds it will just say hello boss, hello boss, hello boss, and if it gets a reply, it knows that this particular slave machine is up and running, right? So that kind of functionality is also important, because again, there's one component that I didn't tell you within HDFS, right? We have something called as replication factor. So if you see here, see the report here, under replicated blocks, over replicated blocks. So what do you mean by replicated blocks? So I told you that the students performance.csv was split into two blocks, right? But even after it was split into two blocks, there were three copies made for each block. So block 0 was three copies were created for block 0, three copies were created for block 1, right? And the reason behind this replication is simple. So let's say block 0 original copy was in slave 2. Okay. The replica may be in slave 3, replica 1, replica 2 may be in slave 4, right? So now slave 2 had some short circuit, it fell down. So a yarn comes to know about it. It informs the master. Master goes back to the table and checks, okay, boss, the original block was in slave 2. It's okay, I understand, it is gone. But there are replica blocks in slave 3 and slave 4, right? So I will make slave 3's replica block as the original block now. For block 0, now that is the original place for you to search. Okay, so that is what the update will happen on that particular table, right? So now even though slave 2 fell, there was no data loss, right? So resilience is built in, fault tolerance is built in the big data framework, right? Within the Hadoop framework. So this is what we call as fault tolerance. Even if a slave machine fell down, you can be assured that all the data that it was having in its hard disk, it is replicated in some other machine. So even if it has fallen down, you still have all the data. Okay, so that is another big advantage that you will have in parallel storage, parallel storage and parallel processing, right? Same thing you will see in Spark with parallel processing, how resilience is built in, how fault tolerance is built in, right? So that you will see in Spark. Spark at the processing level it provides you, whereas MapReduce doesn't. So let's say MapReduce was running on slave 2 at that point in time, right? And slave 2 machine falls down, your entire MapReduce program will generate an error saying that the particular machine is not available, right? So that again is one of the disadvantages of MapReduce. And I will also speak about more disadvantages why MapReduce is being replaced by Spark. Okay, so in an ideal environment, you will see the storage layer will have HDFS only. Only the processing layer is being replaced by Spark. Spark doesn't have a storage layer of its own. Okay, so it will either use a distributed file system like HDFS or S3, Amazon's S3, or ADLS, Azure's ADLS, right? So those are the distributed file systems, or else it can also use your local file system like Windows FAT system, FAT32, or Linux ext3, right? So Spark is very flexible in that manner. But generally, in an ideal big data environment, you will see the processing layer being used by Spark. Storage layer, it will be some kind of a distributed file system, either HDFS, or if it's on cloud, it will be something like S3 or ADLS, right? And the third part, which is a resource manager, will most likely be Yarn. Yarn is a widely used resource manager, but that is not the only resource manager. We have 100 different resource managers. You will see that when we are looking into Spark. Okay, Spark itself has its own default cluster manager, but Yarn is one of the best. So that is why you'll see that setup. Okay, storage layer, either HDFS or some distributed file system. Processing layer will be Spark, and cluster manager will most likely be Yarn. Okay, so I'll tell you now why MapReduce is not being used. Okay, so the problem with MapReduce was first and foremost, the biggest problem was every problem in MapReduce had to be broken down into key value pairs. Okay, so if your problem was to get a word count, it is easy, right? Because here the key is the word and the count is the value, right? So you can break that problem into key value pairs easily. But what if your problem is to let's say just read a file? That is also processing, right? So that again you have to imagine your solution into key value pairs again, right? Or else let's say let's be more general, right? Even this student count is easy, right? Oh no, no, not student count. Yeah, student count again is a problem that you cannot break it into key value pairs, right? So you have to imagine. I mean, it's not easily breakable, but again, it has to be in a key value pair. So that is one big disadvantage with MapReduce. So every solution you have to imagine it in a key value pair. Why? Because
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
the first part is so the MapReduce is first broken into two parts. One is mapper function and the next is reducer function. So mapper function will map your will do some sort of a mapping. I'll tell you. Let me go with an example. So let's say I'll do with the word count problem, right? So let's say my file has this, right? For configuring PyCharm to run on Windows, either something, okay? So this is my input file, right? So now my mapper functions, I have to create two functions for MapReduce. One is called as mapper and the other is called as reducer, right? So my mapper, what it is doing is it is reading the line. I mean, it is getting the line. Okay, Hadoop will pass each line in the file to this particular map function, right? And then I'm doing a Python split. Okay, so what Python split does is it will split on the default split is basically on the white space, right? So with on this particular white space, it will split the entire line into different words, right? And it will put it in a tuple or a list basically, right? So words is now a list. Anyway, don't get confused too much. When we do Python, you'll understand what is a list and what is a tuple and so on and so forth, right? So now for each of the words, I'm going to map it to a constant called as 1, right? So my intermediate output, that is the output of mapper function is basically like this, okay? For configuration, I'm mapping it to constant value 1. PyCharm, I'm mapping it to 1. HTTPS, I'm mapping it to 1. Kaizen 1. HTTPS, again, I'm mapping it to 1. Medium, I'm mapping it to 1, right? So this is my output of mapper file. Input is this, okay? So input for the mapper function is this, output for mapper function is this. So this is what we call as intermediate output. Why? Because this output is not the final output. Our goal is the word count, right? How many times HTTPS is present? It is present 2 times, right? So for that, this particular intermediate output has to be read by reducer. So that is the second part of the problem, reducer function. So reducer function will take the mapper output and it will do some sort of an aggregation. So here, what kind of aggregation it will do? It will group by the key, which is nothing but the word, right? And it will perform a sum operation, right? So when it does group by for a particular key, HTTPS is present twice, right? So for this, when it does group by and it sums the value, it will be 1 plus 1, which will be 2, right? So for others, they're all only present only one time. So basically, they'll be the same. But for HTTPS, it will be 2, right? So that is basically the output of the a reducer function. So that is how you'll be able to see HTTPS is twice. Okay, why is PyCharm 3? I think here PyCharm is available 3 times or something like that. Yeah, PyCharm is available 3 times. Okay, even in the second line it is available. So PyCharm will be 3, HTTPS will be 2, others all others will be 1. Right. So when it did the aggregation, that is how the output came in. Right. So here, what is the problem here with MapReduce? First thing is everything has to be broken down into key value pairs. Every problem that you see, you have to imagine it in a key value pair. Then only you will be able to use MapReduce. Second thing is the intermediate result that mapper generated, it goes back to the hard disk, HDFS. Okay, sorry, storage layer. It goes back to the HDFS. So from HDFS again, the reducer has to read it and then finally it has to write it back. Now think of a very complex problem. Okay, where you have to use multiple MapReduce. Okay, meaning this MapReduce, whatever output was there, whatever the output of this reducer, it goes into a new MapReduce. Okay, there it may be filtering out words that have been repeated more than 2 times, something like that. So you have to create another new MapReduce for that, right? So that MapReduce, that mapper function will take the output of reducer as input, right? And then that particular reducer will take the output of that particular mapper as input, right? So on and so forth. So if there is a line or a chain of MapReduce, it will keep on, all the intermediate results will keep on writing to the HDFS and come back from HDFS, right? So that creates a problem. That IO overhead, right? That itself will make this entire framework slow, entire processing slow, right? So that is why Spark came into picture. Spark does all the intermediate calculations, everything on the RAM of that particular machine. Okay, so you don't have to go to the hard disk, you just have to go to the RAM and fetch it. So RAM to CPU is faster compared to hard disk to CPU. Okay, always remember that. So that is why PySpark is more used. I mean, Spark is being more used for parallel processing. But another thing, you don't have to imagine every problem into key value pairs. Spark has 80 different functionalities that will allow you to imagine a problem beyond a particular beyond key value pairs. Okay, it even Spark has map and reducer. Okay, but apart from that, it has 78 other functionalities. Also, other than that, it also has SQL. It allows you to do SQL like kind of programming. You don't need to be a Python developer. You just need to be a good SQL developer. Then also you will be able to run it. Okay, you will be able to do PySpark coding, right? So that is another advantage. So that is the reason why MapReduce is no longer used. Hope you guys were clear. So I will now show you an example on how MapReduce works. So I have a cluster. So this is my three node cluster where I have two slaves and one master. Okay. So each Hadoop has a UI. So I have to give the IP address of the master and the port number 5070070. You will see the Hadoop UI. Ignore this. So this is my Hadoop UI. Okay. So you can see the total storage capacity. Okay. The configured capacity is 24.97 GB. Out of that, I've used only 324 MB, right? And rest are still not yet used. Okay. And other than that, you can see the number of slave nodes, right? Two nodes are there. Okay, how many are decommissioned? Zero. So if you want to see the data nodes, let me come back to what a data node is. Okay, let me come back here. Okay, so Hadoop has certain daemons. Okay, so Hadoop has couple of daemons. Daemons are nothing but the threads that run on the backend, right? So for master, you will see three daemons. One is name node, secondary name node, and resource manager. So you already know what resource manager is. That is basically yarn. So that also runs on the master, but it's a separate process altogether. Then I told you master will keep track of the no data. I mean data, right? How many? I mean the file was divided into two blocks. Each file is in this particular location. The replica of that particular block is in this location, and so on and so forth, right? So that information is captured by name node. So name node does that job. Secondary name node is backup. Since if a master falls down, there must be some other node that should be able to do the job, right? So in this case, I have configured both of them in the same machine, but generally there'll be two different machines, right? I told you slave nodes falling down, there's a solution. But what if master falls down? You need a backup, right? So that is why we need to configure secondary name node. So that is a daemon that will run in a different backup machine. Okay, but in this case I have done it in the same machine, so don't get confused. Okay, it keeps on getting update from name node every certain minutes, like 20 minutes or 30 minutes, something like that. And it will what update it is giving, it will give the information about the file, the number of blocks it is divided into, where each block is, and where each block's replica is, and so on and so forth. Yeah, coming back to the Hadoop master. So these are the three daemons, right, or three backend processes that are running on the master. So now let's go to the slave. The slave also runs a couple of daemons. Okay, so if you see slave has node manager and data node. So data node is the place where the actual storage is happening. The data node is what is taking care of that storage part. Okay, like this particular block it has received for a particular file. Data node will take it and store it in its hard disk. Okay, in this particular slave to hard disk. Right? So that job is taken care by data node. Right? Node manager, on the other hand, is the daemon that reports to the yarn. Okay, it will keep on reporting to yarn about the health of that particular node, this particular slave machine, right? how much RAM is available in this particular slave machine, how much hard disk is available in the slave machine to the yarn. At the same time, when yarn does a heartbeat check, node manager is going to reply to it. And also when master sends a map produce function, node manager is the one that schedules it on this particular slave machine. Okay, so that is the job of the node manager. Data node, on the other hand, is the one that is responsible for storing the data of a particular block of a particular file in a particular machine. Okay, so now let's go back to the UI. This is what I was talking about. Data nodes are basically the ones where the hard disk, the data is stored, right? So you see that there are two nodes, one is slave 1 and slave 2. So this is the place where we can store the data parallelly, right? And it has the capacity of 2.4 GB each of them. Okay, out of that only I've used 162 MB. Okay, so now data node volume failures, basically there can be a particular block that can go corrupt, right? So all this information you can see here. And then the main thing is utility. So this is your HDFS. So for the client or for the third person, third party guy, he looks at this, he sees, okay, boss, there's only one block, student performance, I can see it's one big file, right? But it is not. If you click on that, you'll see it is divided into two blocks. Okay, and it is available in slave 1 and slave 2. So this is what I was talking about. Okay, and if you want to further be sure that it is existing in slave 1 and slave 2, you can run this command, Hadoop command, and it will say where each block is, right? So if you see here, block 0 is, it has two replicas. Okay, two replica means there are, for block 0 there are two blocks. One will be the original, one will be the replica, right? And if you see, okay, let me zoom it. So now if you see, for block 0 there are two replicas, right? And the first replica is in the original block is in 192.168.0.136, whereas the replicated block is in 1.142. Okay, for block 1 the original again is in 136 only and replica is in 142. So in this case both the original blocks are in the same machine, but that can also happen. But there can also be a scenario where one block may be in one original block may be in one machine, the other original block may be in another machine. Okay, since I have only two node machines, two node cluster, this can happen. Okay, if you have a bigger cluster, you will be able to see, okay, fine, the original block of block 0 was in one machine, original block 1 was in different machine. Okay, and the replica may be distributed among them, right? But in this case, original are in one machine, same machine. For block 0 and block 1 they're in same machine, replica is in same machine. So here if 136 falls down, anyway, replica is there in yeah, so even if 136 falls down, both the nodes are available anyway. Yeah, so it's still fault tolerance is still there. Okay, Hadoop has made sure. So again, the question you may ask, how is it that who decides where each block goes? We don't decide, we don't have any control. That is why it's called as a framework. There are a lot of inbuilt functionalities that exist within Hadoop that will take care of it. A file is being split into two blocks, and each block is being put into a different machine or in the same machine. The replica may be in a different machine. All this calculation is not done by the user and cannot be set by the user. What the user can set, however, there are minimal settings that you can do. Like you can tell Hadoop if a particular file is 200 MB, then you can define a default block size. Okay, so let's say if you define a default block size of 128 MB, then if any file is coming more than 128 MB, then it will be split into two blocks. Otherwise, it will be in a single block. Okay, for example, we will see the student's performance file, right? I am referring to the Hadoop UI. Okay, so that is a Hadoop UI that you're seeing, and within the Hadoop UI, I am showing you the HDFS. Okay, so this is my distributed file system, right? So if you see here, block size has been defined as 128 MB. This again, I didn't set it, but you can set it up. Okay, this is the only setting that you can do. I mean, one of the few settings that you can do. So what this tells is, if any files that come above 128 MB, then only it will be split into multiple blocks. Otherwise, it will be in a single block. Student performance total size is 161 MB, right? So that's why it is in two blocks. Whereas now, if you see this file, right, ftp recon m.csv, it is only 1.9 KB. So it is only block 0. There is no other block. Okay, and its availability is not showing, that means it is corrupted. Okay, so I think this is already corrupted, so don't look into that. And let's look into this one, output. Okay, there's no output also. The thing is corrupted. Anyway, that's what it suggests. So what you can change is the block size. So if you make the block size as 64 MB, then there'll be 4 blocks for student performance rather than 2. Okay, so those are minimal settings you can do, but you cannot control like where each block goes, okay, where each replica of a particular block goes. Those kind of control you do not have. Hadoop does it on its own. Okay, that is why it's a framework, right? If you have to do it on your own, then you don't need a framework, right? Again, who decides on which machine? There's a chance. Okay, I forgot to tell you another scenario. So I told you that these two have 1 block each, right? And MapReduce will run on these machines only. But there's a chance where MapReduce may not run on these two machines. Okay, Yarn may report that even though slave 1 and slave 2 have block 0 and block 1 of that particular file, it cannot process because the RAM is full or the CPU is busy. Some other process is running, right? So in that case, what master does is it will ask Yarn, okay, boss, then that is the case. Then find me 2 other machines that can do the MapReduce.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
That can do the parallel processing, right? Then Yarn will search other 2 machines where CPU, RAM, everything is free, and it informs the master. Master will then send the MapReduce function, MapReduce script to those 2 machines and inform them, boss. Let's say slave 3 and slave 4 were selected. It will tell slave 4, boss, your slave 4, I'm sending you the MapReduce program that has been written by the user. You run this, and the data for you, input data for you, is block 0, which is available in slave 1. Okay, and for slave 3, it goes, master goes and says, boss, I'm sending you the what is it, MapReduce function. For you, your input is block 1 of that particular file, and that is available in slave 2, right? So then they will take the data from these 2 slave machines hard disk and do the processing. Okay, but the thumb rule is, it Hadoop tries to maximize the data nearness, meaning it will try to make sure that MapReduce runs on the same machine where the block of data exists. Okay, but if that is not going to happen, then there's always a backup. Okay, so that scenarios can also exist. So there are no hard and fast rules. There is always plan B, plan C, plan D when it comes to big data frameworks. This is not the only rule for Hadoop. It's also the same for Spark also. Spark, Flume, Splunk, all of them, they have all these automated functionalities, and in a generic scenario it behaves in that way. If that generic scenario is not possible, they have a backup plan for that, right? So it is foolproof. You don't have to worry about it. That is why it is a framework, and that is why you are using the framework. Okay, it's not like you guys cannot build a parallel what do you say, application yourself. We can build it, but it's already available for us, and it will do everything for us. Why we should worry about it? So that is what HDFS and MapReduce is, and Yarn is, right? Cutting was the guy who actually found wrote Hadoop, right? He named it after his son's toy, which was an elephant, right? That's why you see the elephant in Hadoop. So that's what his son's toy. So in 2002, the development started, and then the nudge file system was developed, and MapReduce parallel processing was developed, right? And then NFDS and MapReduce was taken by Google, and paper was published on that, right? In 2006. Then in 2011, on top of MapReduce, Hive and HBase were built, right? Those projects started, right? And Hortonworks, there's one distributor or vendor for Hadoop that was created, right? And Yarn was found in 2011. And then the new version of Hadoop was released 2.0 in 2013, I guess. Before that, Hadoop 1 did not have Yarn as a resource manager. It had something else. I don't know which one. In 2014, Matai Zaharia invented Apache Spark, and Spark started quickly replacing the MapReduce framework within Hadoop, right? So that is the timeline, right? And I'll tell you what Hortonworks is, what Cloudera is. Basically, what happened is, here this is an open source Hadoop cluster, meaning I downloaded it from Apache and installed it. But on top of an open source Hadoop cluster, we have certain vendors like Hortonworks, Mapr, and Cloudera who have created their own wrappers. Meaning, here I have to run a lot of commands to start a particular service, right? To start a Hadoop service, I have to do start all sh, and I don't have any UI to do all those start and stop, right? But in Hortonworks and Cloudera, you have a Cloudera manager which will allow you to start Hadoop, start Spark with just one click, and so on. Some functionalities like that. Other than that, they have their own implementations of Hive. I'll tell you what Hive is. Hive is nothing but a distributed data warehousing solution. It, however, started as an SQL interface for Hadoop, but late in today's time, it's a distributed data warehousing solution. Okay, so in the backend, it uses MapReduce. It used to. Now it is using Tez for processing. Earlier, it was MapReduce, and so that is Hive, right? So for Cloudera, they have their own implementation of Hive. They call it Impala, right? And Hortonworks also has its own. MapReduce also has its own. So there are different tools created by these vendors as well. At the same time, they have created a wrapper on top of the original Hadoop. So those are what we call as distributors of Hadoop. Just like Linux, right? Linux, we have we have Red Hat, we have what is this? CentOS, we have what is that? There are so many distributor vendors, right? Same thing for Hadoop also. So what have they? What is Debian Linux? It's a Linux only built on top of Linux or built on top of original Unix. They have built in some GUI, some manager, some tool that they have built in, right? So that became their own version of Linux, and that's why we call it Debian. Same thing, Ubuntu. They have also done some UI and stuff, something they've built on top of the original Unix. Red Hat also has done that, and so on and so forth. So that is exactly how you what you see in Linux distributors for Hadoop also. Now out of them, Hortonworks and Cloudera have merged. Okay, they were under loss because people have moved on to cloud platforms, right? So these guys are on the on-premises platforms. So big time they lost a lot of money, a lot of clients. So they ultimately merged. Even after that, they're facing a lot of difficulty surviving. Whereas Mapr, which was bought by HP, went into complete loss and it was closed. The entire project was closed, right? So now we have only Cloudera, which has absorbed Hortonworks. It was not a merger; it was an acquisition. Okay, Cloudera acquired Hortonworks and consumed it. But even then, Cloudera was also not in a good shape. Today's time, the one big platform that is captured most of the market is Databricks. The guy who found out Spark. Okay, so he started a company called as Databricks, and they are responsible for releasing the newer version of Spark. Right. At the same time, they have their own cloud platform called as Databricks platform, which has tie-up with all the cloud service providers like Amazon, AWS, Google's GCP, Microsoft's Azure, right? So all these three major cloud service providers, they have tie-up. So you can see Databricks platform being used in all three of them, right? So what do you mean by platform? A platform is nothing but wherein Hadoop, Spark, everything comes pre-installed. You don't have to do much anything. Okay, when we do the cluster installation, you will see that there are 100 different steps you have to do. But with Databricks platform, it's all one single page where you have to mention the requirements. I need Hive 2.0, I need Spark 2.0, I need Hadoop 2.0, something like that. Automatically, it will install the number of nodes you want. You want to create a cluster of 9 nodes, click on 9 nodes. It will create a 9-node cluster and you will have access to Spark, Hadoop, everything. So that is your Databricks platform. And that is what in today's that is the biggest scope in today's market. I mean, that is the biggest player in today's market. So yeah, so this is your Hadoop ecosystem. As I told you, storage layer will be taken care by HDFS, which is the distributed file system. Your resource manager or resource negotiator is Yarn, right? Then we have processing framework, Hadoop's MapReduce and Spark. So if you see here, this is on disk processing, whereas it is in memory processing, right? So these two are basically same. They're doing the parallel processing only, but this is slower. Hadoop MapReduce is slower because it is on disk processing, whereas Spark is faster because all the intermediate results stay in the RAM itself. Okay. Then we have SQL-like tools like Apache Hive and Apache Drill, right? But it started as an interface. Now it's a full-fledged distributed data warehousing solution, right? Then for streaming, we have Kafka and Storm. Someone was asking which other framework. We have Storm, right? Then we have machine learning. We have Mahout, okay, and Spark MLlib, right? We used to have scripting language Pig, which is decommissioned in the latest, I think, January 2021. It was decommissioned. Okay. And for searching and indexing, we have Solar and Lucene, right? NoSQL, we have HBase. So HBase is the NoSQL interface, meaning if you have any unstructured data, it is a document-based NoSQL, just like MongoDB. This is key value paired NoSQL. So NoSQL comes in different structures. One is called as key value pair. One is called as document-based, other is graph based, and so on and so forth. So MongoDB you must have heard. So it is a document based, meaning instead of table we call them documents, and in documents each row is called a line, and a line can have n number of fields. One line can have 3 fields, The other line can have 10 fields and so on and so forth. So that is your MongoDB. Whereas your HBase is a key value paired, right? So each all the data in a particular table is in a key value pair. So if you have let's say six keys, right, and we have six values, you have to put it in your NoSQL database. Okay, I mean, I know it's hard to explain what it is, but basically the entries are in key value kind of structure. Then we have schedulers, we have Uzi, we have Airflow, we have a lot of different schedulers. There's a big market for scheduling itself, right? Then we have, yeah, this is what I was talking about, Zookeeper, which is nothing but the infra manager, right? And coordination, we have Apache Spark. And this is your Hadoop ecosystem, right? And you can connect with any kind of data from the outside world. It can be your structured database like RDBMS, like MS SQL, MySQL, Postgres, and something like that. You can push it to your Hadoop ecosystem, or you can push it to your HDFS basically, right? Or you can take it from some different formats like text file, JSON file, and everything. You can push it into HDFS. So here you see Flume and Scoop coming into picture, but you don't need that in today's time. Spark can take care of that on its own. Okay, so that's why even Flume is almost on the verge of decommissioning. Same thing with Scoop. Since Spark came into picture, you don't need these two tools. Earlier for MapReduce, you definitely needed it. First, you would use Scoop to take the data from a particular database, push it to HDFS. Then you have to run the MapReduce program, right? Or you have to use Flume to get the data of get aggregated data from a particular place, push it to HDFS, and then run MapReduce. Today's time it is not needed since MapReduce is not being used much. Spark is able to take care of all these requirements on its own. Okay. Components of Hadoop, as I said, we have name node and data node. Name node runs on the master. It keeps track of the blocks, where each block is, right? Data node is where the actual data is stored, right? Then MapReduce, it has two parts. One is the map function and the reduce function. It converts each particular line into key value pairs, and it will assign some constant value or something like that. That particular constant value is then taken care by the reducer function, which will, for each key, it will group it and do some sort of an aggregation. Okay, aggregates and summarizes the result produced by the map function. Right. MapReduce acts as a core component as it facilitates the parallel processing. Okay, it is a software framework which enables us to, as in writing application that processes large data sets using distributed and parallel algorithms in Hadoop environment. But this no longer is true. Spark has replaced it. Okay, parallel processing feature of MapReduce plays a crucial role in Hadoop ecosystem. Used to. Okay, not anymore. Yarn supports a variety of processing engines and application. As I said, even for Spark you can use Yarn. Even in Hadoop you use Yarn. Even a lot of other big data processing frameworks, you use Yarn itself as a resource manager, right? It dynamically allocates pools of resources to other application on the go. So this is what I was talking about. Master will contact the Yarn, name node will contact the resource manager and say, boss, I have this requirement. So I need minimum two nodes to save the data because I'm going to split the file into two blocks. So then resource manager will traverse through the cluster and give you that, right? Key characteristics of Hadoop: flexibility. Major challenges for any company or organization would be on how to handle the structured and unstructured data that is available within big data. Right? So Hadoop is very flexible as it has multiple tools and frameworks to work with, right? Some can, like if you have a structured data, you can directly push it into Hive. If you have unstructured data, you can use MapReduce and create a structure or at least a semi-structured data and push it into HBase, right? So Hadoop can do all those things. Scalability, this is what I was talking about. If a particular cluster has reached maximum storage, then you just go to Amazon, buy a laptop, insert it, done. You now have new storage. Same thing for RAM. If your RAM space, the combined RAM space of your cluster is full, go to Amazon, buy a laptop, insert it, that's it. It will use that particular laptop's RAM, right? So it is scalable. You can horizontally scale it as much as possible. Okay. Fault tolerance, this is what I was talking about. By building in replicated blocks, you can be rest assured that even if there is a failure in a particular machine, you'll still have the data somewhere else, and Hadoop will quickly make those changes and update those changes and keep it with itself so that any processing that needs to happen will move on to the new machine. Rapid data processing and low cost. This is true only when you don't consider Spark. Okay. Hadoop generally works on the concept of parallel processing. So definitely, if a particular single machine, as I said, is taking 5 hours for a particular file, Here, if you have 5 machines, then it is taking 1 hour. If you have 10 machines, parallel is being processed, it's taking 30 minutes, so on and so forth, right? So they are of low cost. When to use Hadoop? When you have large amount of data, right? When handling different, when you are having different type of data, like as I said, structured, unstructured, different formats of data, right? Or when you're processing big logs, right? Or when you're processing heterogeneous graphics like video processing, audio processing, and so on and so forth, right? So at that point of time, you need to use Hadoop or you need to use big data.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. D stream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
When not to use big data or Hadoop, the file should be big enough. Biggest drawback is I see a lot of people who are using Hadoop for small files. I'll tell you why small files is not recommended. Okay, so if in a single server you can process a 10 KB file in 10 seconds, because what, it has to go to the RAM, from RAM to CPU. But when you're doing it in Hadoop, right, there are backend processes that I was talking about, right? First the file is split into blocks, then the blocks are pushed into, I mean, the yarn the resource manager takes that information, gets the particular nodes, and then those nodes store those particular blocks in their hard disk, and then the next part of the processing starts, right? So that itself is a processing overhead when you look at the small files, because these small files only take 1 or 2 seconds in your single machine, but in your big data environment, that itself will become a process overhead. So do not use small files. Always Hadoop will only work well when you have 1 terabyte of data, 2 terabytes of data, something like that, where your single machine will take 6 hours or 7 hours just to read the file, right? So in such kind of scenarios, you can use Hadoop. If not, then you shouldn't use Hadoop. Okay. Low latency data when you need quick access to your data. So this is what I was talking about. Reading the file, right? It may be split into different blocks. If it is a small file, again, it has to go to those two blocks, combine the data, and then give it to you. Whereas in a single machine, it will be done in 1 second, right? And other thing, when you cannot break your program into a key value pair structure, right? Spark, however, this is not true for Spark. Okay, so let's not say when not to use big data. We can say when not to use Hadoop. This is correct. Okay, I made it into big. I said big data. For big data, these two are true, right? For Hadoop, this is also true. For Spark, however, this is not true. Hadoop cannot handle data modification efficiently, but Spark can. Okay. Introduction to Apache Spark. Spark was introduced by ASF. Basically, Matej Zaharia was a USB student, Berkeley, UCSB, sorry, UCSB, right? And in AMP Lab, he created the software framework, right? So Spark uses Hadoop in two ways. One is storage and another is processing. This not true, not processing. Other is cluster manager. Okay, so it uses Hadoop's two components. One is the storage and cluster manager, right? Even though it comes with its own cluster manager and it also supports other storage layers also, right? You can also install Spark on your Windows machine. It will still work. It will use your Windows file system, right? It doesn't need a distributed file system. It's a lightning fast computing technology designed for fast computation. It is based on Hadoop MapReduce. That is what I was talking about. It does have the MapReduce functionalities, but other than that, it has 70 other functions. Okay, so it is more efficient. You can do more efficient modification of data in Spark, and main thing is it runs in memory. All the data will stay in that particular machine's intermediate data will stay in that particular machine's RAM, not on disk. Okay, so it was a sub project, Hadoop sub project in 2009 in UC Berkeley's AMP lab by Matej Zaharia. He's also the CEO of Databricks. Okay, and if you want to learn in depth about Spark, meaning the inner functionalities of each and every aspect of Spark, you can read his book, Matej Zaharia's book, which is Definitive Guide for Spark. So this is a book by the original founder of Spark. You can definitely read this if you want to know core part of it. I mean, like what is happening at the operating system level and what is actual algorithms being used, right? So that, and that again, there's not something that everyone knows it, but if you want to know, you can feel free to refer that particular book. Okay, it was started in 2009. It was open sourced in 2010. And by 2013 it became a top level project, and by 2014 people had started using it, and within 7 years it is now the top processing framework being used, right? And maybe in a different form, but still the top framework. Okay, speed, it is 100 times faster than Hadoop because of its in-memory computations, right? All the intermediate results, what you saw in MapReduce being written into HDFS will be written in the particular machine's RAM itself. It supports multiple languages. Hadoop only used to support Java. After Spark came in, I think they built in support for Python as well. But Spark program can be written in Java, Scala, Python, as well as R. Okay, and I think now it is supporting Google's Go also, Golang, right? Therefore, you can write application in different languages. It provides 80 different functions. This is what I was talking about. Map and reduce are not the only functions. It has 78 other functions as well, right? And you can do advanced analytics apart from Spark. Not only supports map and reduce, but also support SQL queries, streaming data, machine learning, and there are other functions as well, right? It is in-memory computation. No need to fetch the data from disk every single time. All the data will exist in your RAM itself. Fault tolerance, Spark has inbuilt fault tolerance. Okay, MapReduce on the other hand doesn't. So here what happened is, what I told you, fault tolerance, that was for HDFS, right? So that is why that combo is used, HDFS and Spark. So what happens, fault tolerance is built in the storage layer at the same time on the processing layer. HDFS is built in by putting in replicas. Spark, what it does, it also does the same thing. It takes the data, right? Okay, and it splits the particular data into partitions. Each partition may be working on a different machine, right? And the master will keep track. In that we don't have master, we call it as driver program. So driver program will keep track of where each particular partition is being computed. If that particular partition fails, or if that particular machine fails, driver will immediately ask the resource manager to bring up a new slave machine, and it will pass on that particular partition to the slave machine and start the processing. So that way it builds in fault tolerance in the processing layer as well. So MapReduce doesn't have that. Spark has it, right? So Spark and HDFS is a very good combination. Dual fault tolerance is there. But what happens is, what I can say is, in Spark, as soon as you submit the code, the execution doesn't start, right? Execution will start only after a particular point of time, right? And it brings in efficiency. Why? We'll see that when we read Spark, okay? When we do the Spark module. So basically, this is your Spark structure. So you have different storages. We have different types of files. It can be structured, semi-structured, different formats. They all go into your HDFS. That's what I said. Dual fault tolerance, right? So by using HDFS as the storage layer and Spark as your processing layer, you're building in dual fault tolerance, right? So all the files are stored in HDFS. Spark connects to the HDFS, reads the file, manipulates it, writes the final output to HDFS. All the intermediate results are stored in each machine's RAM itself. So those intermediate results are not written on the HDFS, only the final result. Okay. And again, it uses the Hadoop's resource manager for same thing what Hadoop was doing, right? Get me nodes that satisfy a particular requirement. Same thing Spark also does. I have a user requirement which needs 2 nodes. Find me these 2 nodes that have this much of RAM, this much of hard disk, so on and so forth, right? So that is why you need yarn as well, right? And MapReduce is used because Spark also has inbuilt mapper function and reducer function. So there's a chance that you may need mapper and reducer function as well. And Spark can also take in live data. MapReduce cannot. That's why we have Spark streaming. Okay, Spark streaming is nothing but reading live data, manipulating the live data, writing it somewhere, right? Hadoop MapReduce doesn't have that capability. Who uses Spark? Again, people who are using Hadoop earlier, they're using Hadoop only for storage layer. For processing layer, they've removed the MapReduce and pushed in Spark, right? So same companies are doing the same thing. In 2008, they were immediately working on Hadoop and MapReduce, but by the time 2014-15, they moved on to Spark, right? So as I said, Spark has couple of modules. The top or the base layer is the Spark core, right? Each layer has its own data structure. Okay, so for Spark core, we have a data structure or a storage object called as RDD, resilient distributed data set. Okay, so what is an RDD? If you guys know what a Python list looks like, list of or list of tuples look like, So RDD is similar to that. Only thing is this list of tuples, it's on a single machine, whereas the RDD resilient distributed data set is distributed across the cluster. Okay, it is partitioned and distributed across the cluster. Right? So that is the basic data structure in Spark core. So everything that you write, right, should go into the read or write. It should go into an RDD. Okay, and then on that RDD you can use any sort of functionality and create new RDDs. Then we have another layer, data frames and SQL, right? Spark SQL. So this basically was copy pasted from Pandas data frame. So if you have worked with Python, you would have heard about Pandas data frame. So that is nothing but a virtual table like data structure or a storage variable you can call, right? So where in which you can store the data in a table like structure, right? The same thing was copied to Spark. Only thing is here it is distributed. In Python, it is in a single machine, right? And then we have MLlib, we have GraphX, then we have Spark streaming, right? So they are all the different modules that exist in Spark. We will be only focusing on data frames, Spark streaming, Spark SQL, and Spark Core. And to the outside world, it can connect to a whole number of, hundreds and thousands of different sources. It can connect to Hadoop, HDFS, Cassandra, Hive, HBase, NoSQL, any different kinds of files like CSV, JSON, everything. It can also directly connect to RDBMS like MySQL. It can also connect and fetch data from Elasticsearch and so on and so forth. Okay, that's why so many different Hadoop tools are no longer required because of Spark. So Spark Core is the underlying general execution engine or the base layer of Spark. Okay, it provides in-memory computing and referencing data sets in external storage. Okay, so that external storage, as I said, it can be your distributed file system like HDFS, or it can be your non-distributed file system like Windows FAT or Linux ext3. Right. So as I said, Spark has one of the important components with is Spark, SQL, and data frames, right? So this was basically built for SQL developers who are developers who are coming from SQL background, right? So there is very little coding for them to do, but more or less they can use SQL. Okay, they have to do a bit of coding. Doesn't mean that you can directly use Spark SQL. You have to do some coding, but less number of PySpark code is required. More of your SQL kind of query, right? And the queries are very similar to how you do it in your MySQL. Okay, so basically Spark SQL, Hive query language, which is your HQL, and the query language that you use in MySQL, they're all very similar syntax wise. Like you do limit 1 or limit 10. Same thing is there in Spark as well as Hive, right? Whereas in MS SQL you have top, something like that, right? So those kind of syntax I'm talking about. So they are very similar to MySQL. Okay. Then you have Spark streaming. As I said, this is the live streaming component of Spark, right? If there is any requirement where you want to do real-time analytics, you want to consume real-time data, you have to work with Spark streaming, right? The Spark streaming in turn can get data from different sources like Kafka, Flume, Kinesis, or any TCP socket, right? And then it can write it into a file system or databases or some live dashboards, right? So in this, what happens is it may not be 100% real-time analytics. I mean, it's real time, near real-time analytics. Okay, so if you get the data at 10 o'clock, it may be processed at 10 o'clock 0.1 second, meaning microsecond, 1 microsecond. Right? So there can be that kind of delay because what happens is it divides the live data into batch data, micro batches. Okay, not exactly batch data. We'll see that in Spark streaming at this point. You don't have to get confused with it, right? But yeah, you need to know that there are two kinds of processing. One is live data processing, that is streaming, and other is batch data processing. So there are two different mechanisms altogether when you are ingesting live data and when you're ingesting batch data. Right? For batch data, the entire data is already available somewhere. It may be in your HDFS, or it may be in your file system, or it may be in your database, right? But we know that the entire data exists there, and on top of that data, we have to do this modification, right? But for live data, we don't know. First of all, we don't know if we'll get the data or not at this particular point, right? 9 o'clock you may get the data, 9:05 you may not get, 9:10 you may get the data, 9:11 you may not get. So there is a lot of inconsistency. At the same time, we don't know when the data will appear. But as soon as the data appears, we have to do some modification. Here in batch data, we have to consume the entire data and then do the modification. But in live data, as soon as you get the data, you start doing the modification. So there are two different kind of approaches. So that's why there's a separate module for live data, that is Spark streaming, right? Then we have machine learning library. Okay, so let me tell you one thing about Spark. As I said, Spark is a copy paste of a lot of different components from single machines, what we were using in single machine server. Only different is that particular concept was used on single machines, but when it was brought into Spark and copy pasted it became more of a distributed or parallel processing, right? For example, I talked about data frames. That was a copy paste of pandas, Python pandas data frame, right? So that concept in pandas is heavily used, but it's running on a single machine system, single server system, or single machine. It cannot be processed using parallel processing systems, right? But when it was brought into Spark, automatically it became parallel processing. So same thing, machine learning also, it is a copy of a lot of different other machine learning libraries like Python skitlearn or TensorFlow. A lot of functions from these machine learning libraries have been copy pasted into MLlib. Okay, so the reason is there has to be some sort of familiarity. Okay, even the Spark was written in Scala. The reason why many concepts have come from Python is because Python has a wide array of libraries, right? So Scala doesn't have much scope beyond Spark. Okay, even though it's a native language, you may see Scala developers, Scala Spark developers, but for them, they don't have much scope as a pure Scala developer. Other than being a Spark developer, they don't have much scope. PySpark is heavily used, so Python developers are in much demand, right? So major reason is Python has a huge library set. You can do embedded level programming using Python. You can do machine learning programming. Python. You can do socket programming using Python. You can do anything with Python. Web programming we're using Python, right? So that vast library exists only in Python. Even Java cannot beat it. Know this. Python has the biggest libraries. What do you mean by libraries? You have some frameworks or some modules that has been built by others. You can use it to accomplish some goal, right? So you have Java, you do import IO dot something something. So what are they? They are nothing but libraries, right? So in Python also we have libraries, but the library market here is huge compared to Java or Scala or any other programming language. Okay, even most of the libraries that are developed in C, they are converted into Python, and then that particular Python library becomes famous. TensorFlow initially was developed in C. Pandas initially was developed in C++. But it became famous in Python. There was a large user community for Python, right? And then it became a pure Pythonic library only. Current enhancements are all directly pushed from Python. People are not using them in C++ or C, right? So that kind of stuff exists in Python. That is why most of the components or some concepts have been copy pasted from there. Okay, the only disadvantage there was it was all have to be run on single machines. Here parallel processing comes in, so it makes it even more efficient. Hadoop versus Spark, right? Real-time processing doesn't appear in Hadoop, whereas it is there in Spark, right? So this is one big difference, right? You see a lot of other differences as well, right? We have basic data processing engine. Here it is data analytics engine, meaning you can do data analysis, you can break down the data into tabular form and do some sort of analytics, whereas in Hadoop you cannot. You have to break it into key value pair and all those stuff, right? So it's a basic data processing engine. Then we have usage. Hadoop basically used to do batch processing, right? Spark does both batch processing and real-time processing. Hadoop doesn't have real-time processing capability. Latency. Hadoop has high latency, as I said, because MapReduce writes all intermediate data into the HDFS. So if you want to get the data again, I mean, when you're processing the data, every time it is written into HDFS, then again read back from HDFS, right? So this to and fro causes a high latency in computing, right? Whereas Spark, it's all in memory, so data is always available in RAM, so the processing is faster. Data processing done only in batch mode, meaning you have to run a command like this. Where was that? So every time you have to do some sort of a command. You have to run some command like this: Hadoop jar, then the name of the jar file and input file. I mean, mapper file location, reducer file location, and so on and so forth, right? So that kind of thing is called as a batch mode. So everything has to be written in a particular script or a project, and then that has to be submitted. Spark also has that facility. You can write it in you can write a PySpark code in a Python project and submit it using Spark submit. But at the same time, it can also be done interactively. Okay, meaning that REPL shell. So immediately you type a code, you'll get an output for that. That kind of shell exists with Spark. So it's called as an interactive shell. If you work with Python, Python also has an interactive shell. We call it REPL, read, execute, and load, something like that, right? So immediately you write a command, it will execute it immediately, right? So that kind of interactive shell exists. MapReduce is complex, as I said, it has to be broken down into key value pairs, but Spark is easier to use. It has 80 different functions that makes your life easier. It has no in-memory computation, external job scheduler is required. It supports Spark, on the other hand, supports in-memory computation. That means everything is on the RAM, and it doesn't need an external scheduler. Using Apache Spark with Apache Hadoop, what are the advantages? This is what I said. Main advantage is dual fault tolerance. You use Spark for processing, you use Hadoop for storage. Then on storage layer you have fault tolerance, and on processing layer also you have fault tolerance, right? So that is where Hadoop is adding value to Spark. Hadoop includes HDFS, which allows you to distribute data across nodes. First thing is the data at the storage level is distributed, right? So it eliminates the need for custom hardware. Then Hadoop provides enhanced data security, which is critical for production workloads. At the same time, it provides fault tolerance, right? How is Spark adding value to Hadoop? It brings in Spark streaming. You can produce, manipulate live data. It brings in machine learning. You can do some sort of prediction on existing data, right? So these kind of additional, this is what Spark brings in when you're using Spark with Hadoop. Apache Spark fits into the Hadoop open source community, building on top of the storage system, right? Spark is not tied to two-stage MapReduce program. This is what I was talking about. It has 80 different functional functions that you can use, and it is 100 times faster than Hadoop's MapReduce. There's kind of a benchmark being set. Okay, every few years, Google or some all this Apache folks, they do some benchmark testing where they'll run Hadoop's latest version, Hadoop's MapReduce latest version, Hadoop Spark latest version, and they'll tell you how much faster each of them is, right? So, and they do it with 100 different nodes, like they'll do it on a 100 node cluster or something like that. The last one was in 2018 or something like that. So I mean, it's always had, this is the kind of, output that they have received, that Spark is always 100 times faster. Right? So Apache Spark is also compatible with other tools, Hadoop tools like HBase, Yarn, Hive, and everything, right? Same goes for Hadoop components. In return, Yarn, HBase, Hive, they're also compatible with Spark. Okay, it's all again the same thing. It runs 100 times faster because it's in memory computation, whereas MapReduce is on disk. Again, MapReduce is slow because it executes in batch mode, which means real-time analysis, and it also executes it on. All the intermediate results are on disk, right? The same thing again and again they're trying to tell you. Alternative to MapReduce, Spark is an alternative, as I told you, right? And it provides more stability than real-time stream-oriented Hadoop frameworks like Storm, right? Someone was talking about streaming frameworks, like, so that's what I told you. Storm exists, but it has its own disadvantages, right? It is Spark is more stable than Storm, and at the same time, even Storm is not in memory processing. It's also on disk, right? And it doesn't have the fault tolerance capability. So while streaming, something happens in Storm, the data is gone, right? So it's not very stable. Spark can be used for a variety of jobs such as live data analysis, more computational in-depth jobs involving machine learning, graph processing. All this you can do with Spark. Biggest advantage of Spark is it supports multiple languages. Hadoop did not have that. That was its biggest drawback. Everyone had to learn Java if they had to work with Hadoop MapReduce. With Spark, they can use Python, they can use Scala, they can use Java, they can use R, Golang. So many languages have come up. Even I think Node.js also supports it. I'm not sure. You can check it out. But Java, Scala, Python, and R, they're there from the beginning. Beginning in the sense, Scala was there first, but after a few months or few iterations, Python, Java, and R were added. Library support, as I said, Scala, the original native language, doesn't have much support, but it has good integration. For example, when we are doing Spark streaming, if you're using Scala language, you can directly connect to Twitter and start your streaming. But with PySpark, you don't have that facility. So there are some disadvantages of not using the native language, right? But at the same time, Scala doesn't have big library market, whereas PySpark has a big library market. So you can do any kind of processing using that, right? Stable API version is with version 1.0, Spark offers a stable API. Okay, and developers use it with Spark through their own application. This helps in using Storm more easily in Hadoop-based environment, right? Spark SQL component, as again, if you're doing want to manipulate structured data, and if you're coming from a database background, you do not know much about PySpark programming, then this is the right place to start with. But in today's time, everyone is using it. It's not just Spark SQL. Uh, it is Spark SQL and data frames, right? So the concept of data frames also comes in here. So a lot of Python developers are using this particular module itself. So it allows SQL-like querying to be run against data stored in Apache Hive or any other place. It doesn't have to be Apache Hive, any other place. And it integrates with Hive very well, right? There's no errors, or there's no extra stuff that you need to do. Okay, simply you just have to configure where Hive tables are being stored, and Spark will directly connect with it and read it. Okay. Spark GraphX library is used for manipulating graph data, right? And it comes with variety of graph algorithms and graph computations, right? And it also implements the data structure used for GraphX is something similar to what we have seen in Spark core, which is nothing but the Spark RDD. Okay, that is resilient distributed data set that I was talking about, right? So that is the data structure of Spark core. Spark SQL and data frame is data frame, and Spark streaming is discretized stream. Okay, and GraphX is Spark RDD. ML is also Spark RDD. Applications, as I said, there are a lot of different applications, a lot of different domain. Healthcare, demographic data, patient data, CRM, fitness tracker, purchase data, research data, transaction data. Okay, so I'll tell you in healthcare, one of the clients that I've worked with, right? So they're called as HCSC. I think last time also I talked about this, right? So they were working with pharmaceutical data. So HCSC is an insurance provider in US, and their clients are like Infosys and Accenture, 7-Eleven, Target, who are then providing insurances to their employees, right? So within that pharmaceutical insurance they are providing. So anytime an employee of Infosys go to a medical store in US, he fills out the prescription. I mean, he shows the prescription, and he claims the money via insurance, right? So then it goes to HCA, I mean, it goes to Infosys first. Infosys combines all the employee pharmacy insurance claims, all employees. Maybe there may be 1,000 employees for that particular day who have applied for insurance. All of those claims are compiled and sent it to HCSC, right? So HCSC takes the data from different clients. So Infosys sends it in a different format, meaning that it may have 12 columns instead of 10, okay, or 13 or 14, something like that. They'll be fixed width files. It's not columns basically, like from 0 to 1, one field, okay, and from 10 to 20 another field, something like that, right? So they have a fixed width where in which you will get the data. So such kind of fixed widths are coming from Infosys and Accenture and all their clients. Okay? But all these clients may be adding their own data to it for their own analysis. There's no common format. So HCSC is using Spark first to push the data from raw layer, meaning the data lake where all the client files are coming in. So it's reading the raw layer from the raw layer data and putting it in a common structure, right? So all Infosys data, Accenture data, they're combined, and only required information are taken in and return it into a JSON file using Spark, right? From that JSON file is stored in a gold layer. From the gold layer, downstream applications will take it using Kafka or some messaging services, right, and consume that data and do further analytics, right? Like let's say Praveen was working in Infosys, he's been applying for pharmaceutical insurance for claiming sugar, I mean all the diabetic medicines, right? So that means there are 100 employees within Infosys who are diabetic, and they all reside in Washington DC area, right? So they may relay this information or analytical output to their pharmaceutical client. Let's say some Pfizer is producing the diabetic medicine, right? So they are selling this analytical data to them. Then Pfizer will use this data and improve their supply chain into Washington DC because they're seeing a surge in diabetic patients there, right? So that kind of analytics is done in healthcare. One of the examples. There are 100 different examples. Demographic data is the same thing. Pharmaceutical companies will look into what people are purchasing in the pharmacies, right? And based on that, they'll try to improve their supply chain, right? And then fitness tracker. This is to see how each person is, and the kind of analysis they may do. Okay, a particularly fit person may be running for this amount of time, particularly unfit person or who has some health problems, they may be running at this for this particular time, right? His speed may be this, something like that. So all those kind of analysis are being done in healthcare, right? Then the next domain is manufacturing, and they do testing and simulation of new manufacturing process, customizing mass production requirement, defect tracking, supply chain analysis. So here I'll give you one client. We had developed a dashboard on AWS. Okay, so it was called as Organization Capability Dashboard. Okay, so this client is North America's biggest electrical generation company. Okay, they're called as FPL. You can look it up, Florida Power and Light or something like that. So they have an OCD dashboard.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
Where they're consuming data from 100 different sources, right? And we have to develop KPIs for each of these sources. So one of the sources was the electrical generation plant, right? So within so they, for each of these KPIs, we had to show them analytical data on three levels. One is at the plant level, one is at the site level, then plant level, then sub plant level. So site level may be like an area. Within that area, they may have two or three plants. Like in Bangalore, they may have two plants.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
One in North Bangalore, another in South Bangalore, and within each plant there may be sub plants, right? So that kind of hierarchy existed, and for us we had to show them 48 KPIs on these three levels, right? And one of the KPIs was electrical generation, right? So there are machines there, they are sending the electrical generation generating machines. They're basically are IoT devices that they are sending input to to us. It is going to basically a Postgres database. From Postgres we are reading it, and live data basically, right? Live data, and we are matching it with a certain threshold that the client has set, right? So if it is above the threshold, then again it's a problem. If it's below the threshold also, it's a problem. So these two kind of uh, data is pushed in, right? So if it's above threshold, it's marked as red. If it is below threshold, it is marked as a dark red or something like that. And if it's within the threshold value, it is marked as green, right? So looking at the dashboard, every now and then client can come to know, okay, Washington DC plant site area, they're performing perfectly well. Mm, Colombia, within the particular site, one plant is not doing well, other is doing correctly, right? Something like that. Based on that, they take immediate actions. They will call the site engineer and they say, boss, why is it overproducing or why is it underproducing, right? So that such kind of KPIs are built. There are 49 different KPIs, right? They're also doing on batch processing. Like they had a KPI for each employee's skills, right? Learning skills. So they have set some goals for each employees. Like a site engineer, he has to do black belt certification, red belt certification, something like that, right? For that, he has to do these many courses. So every now and then they check. Okay, every quarter they check. Okay, boss, for this particular site, there are two site engineers, three site reliability engineers who have not completed this particular certification, something like that, right? So that organization capability dashboard told them how capable their organization is, right? And some were real-time analytics, some were batch processing. They're all combined into one particular dashboard, and frequently the CEOs and VPs would look into it. And there are other examples like defect tracking, supply chain analysis. This is what I was talking about. A lot of people do this. They look at the demographic data, and let's say if you're, if you're a Kellogg's company, right, and if you see from you're getting data from Big Bazaar or DMart, where in which you're studying how many people are purchasing in Bangalore, right? So South Bangalore, Big Bazaar may be selling more chocos compared to North Bangalore, right? So then they will push more chocos to South Bangalore. They'll push less chocos to North Bangalore. So that such kind of supply chain analysis is very common. They're doing it before also. These are not something that is new. Okay, let me tell you one thing. With Spark, nothing, none of the products that are being built is not new. Only thing is the product that they had built long ago, it is now inefficient because of the single machine system. The data has grown big, so you're not able to query the database. The processing is slow because and it is the data is huge, right? We are getting data now in different formats, something like that. So all these problems have occurred. That's why they have moved from the legacy system to the new big data system, right? So most of your projects is basically a migration from single server to uh, a cluster. Media, you have distribution, you have publishing, you have learning, you have conversions. So here I'll give you another example of a client. uh, they were doing, I mean, it's not a client. I worked in Cognizant before. I mean, even though I was employed with Cognizant, so their client was Aruba Networks. So if you look at Aruba Networks, you will understand what they do. So they are a startup, Bangalore-based startup. They're working with, they're an RTB, real-time brokers. So what do they do as a real-time broker? So they have installed cookies on various different thousands of people. You may have visited some site, they would have installed the cookie on your laptop, right? So they monitor your browsing history every now and every second. Whatever you do on your browser, if you are searching for cat food, they will immediately capture that data, and as a real-time broker, they will send you back that cat. Any client who's a cat food manufacturer, they will send it to you. So if you are visiting Facebook, you will get that ad in your sidebar, right? So that kind of analytics was being done. Aruba Networks is the company. You can check it out. So they are real-time brokers. They are called as real-time brokers, and now that is a big market. Okay, and there too, big data is being used because the data is humongous. You are monitoring 1 billion people, right? 1 billion people's browser. Just imagine the amount of data that you are collecting, right? And on top of that, you have to do analysis. So all those is a problem. So that's why they're using big data environment there. Then Internet of Things, as I said, this is a newer what do you say, technologies that have come up since 2010, right? IoTs are nothing but devices that are what do you say, can be controlled remotely and digitally, and there are some devices that are generating data digitally, right? So that can be processed by other devices. For example, your fitness tracker is an IoT device. It is sending some data to your mobile, right? So, or you have IoT fridges today, right? If some of the components in your fridges become empty, it will immediately send you a notification. Such kind of stuff. So those kind of devices are called as IoT. We can control them via the Internet of Things. Today we have IoT bulbs, IoT fans, even IoT plug points, right? So internet IoT is a big thing, and it is very much closely working with big data. How? Because these IoT devices are constantly generating data. So the companies who are manufacturing these devices want to make sure that each device is working properly. One example, right? So one of the examples may be to, okay, fine, I want to monitor if the tracking devices that all my customers are wearing is working fine, fine or not. Right? So each time a particular person is wearing starts the particular fitness tracker, the fitness tracker starts sending the data via the internet, right? And the company keeps getting, okay, the device is working fine, RAM is free, that is free, all this cache file are cleared, operating system is not corrupted, all this kind of analysis they do, right? Other thing is, I was talking about in the manufacturing sector, right? Electrical generation company, that particular site has an IoT device that reads how much electricity is being generated real time and is sending across to the AWS cloud environment that we have set up. So that is what IoT is about. Then government is using it in various domain: weather forecasting, cybersecurity, traffic optimization. All the things you will see is in for Obama, right? When he was working on, so he spent billions of dollars on, you know, understanding how people are perceiving about him and making a customized message, right? So that he was using big data and MLlib, Spark MLlib, right? So he would read into the browser history and go through each American's browser history and find out what kind of things he likes, what he dislikes, and based on that, he would send a custom message. Like if a person was looking for guns, he would send a message saying that he would support guns. So someone is looking at pets, he would send a message saying he would support pets, something like that. So customized. He spent almost $1 billion, and not just him, even his rivals used the same thing. 2008 or not 2008? No, not Obama, someone else. Okay, I don't remember. Somewhere someone else used it. It was almost billions of dollars. Okay. Cybersecurity today is most of the ideas are all big data supported. Okay. Ideas are nothing but intrusion detection system. So earlier a single machine used to monitor the entire internet traffic to judge whether this particular uh, TCP packet is a fraudulent packet intended to hack the network or it's a genuine packet, right? So that is what an IDS does, intrusion detection system. But now we have multiple servers that are working in parallel, processing each of the traffic data and doing it. So it is much faster. What is PySpark? Basically, it's an API written in Python that supports Apache Spark, right? And the Spark, as I said, is a distributed processing framework. And what is the prerequisite? You need to have knowledge on Python. Okay, you need to understand what Spark is, right? And who wants to work on big data, the most suitable candidate is, I mean, needs to know PySpark. Okay, it has a huge market. I'll tell you why it has a huge market. Who uses PySpark? Everybody in today's time. Most of them they use PySpark only. They don't use Scala Spark much, even though that is the native language in which Spark is written in. So why do they prefer PySpark, right? The question is why, and the reason is one of them is Python is easy to learn. Okay, so you can have a developer learn Python within a week or so, right? And then the next point is it's a dynamically typed language. You do not in other languages you define a particular type, like if it's a integer you say int a equal to 0, something like that. You have to define a variable like that, right? You have to define the type of a variable, but in Python it's not. It is all done at the runtime, right? So interpreter, when it reads that particular line, it assumes that okay, if this is having an integer value, then this variable is an integer, right? So that is one more advantage, right? The other advantage is it has a huge library set, right? So there are a lot of libraries. As I said yesterday, you can do any kind of programming using Python. You can do web programming, you can do programming on IoT devices, you can do embedded programming, right? So that you can even do assembly level programming as well. So there are n number of tools in n number of tools and libraries available in Python. The same cannot be said about Scala, right? Even Java doesn't come close to Python libraries, right? So that is another advantage, right? And the development time taken for a good readability. One more thing is good readability. If you look at the Python code and if you look at other programming languages, one thing you'll notice that in other programming languages you will be running behind the flower braces. You'll have to find out okay where the flower braces starts, where the flower braces ends, so that you know which block of code belongs where, right? But in Python it's only indentations, so it looks good, easy to read. You can easily identify which block belongs to what, right? So that is one another advantage about Python, right? Finally, one more thing is development time. Okay, something is not available in the slides. Development time is faster. Okay, in Scala, you may, if your goal, if you have some goal and you are using Scala programming language to achieve it, you may end up writing 100 lines. But the same thing you want to achieve using Python, it may end up being written in 10 lines, right? So in Scala 100 lines and Python 10 lines. So just imagine your entire project, right? You're writing 2-3 lakhs of codes for Scala, so the time taken would be more. It may be 1 year or 2 year, right? The same thing, 2 year project that took for Scala, you can finish it in 6 months using Python. So delivery time is less. So that is another advantage with Python. Okay, so that's why people are going for PySpark. And another thing, it has a huge community. Over Stack Overflow. Sorry, if you look at Stack Overflow's results, the most number of questions asked for is for Python. Okay, so there are a lot of users who are using Python. There are a lot of developers who are taking up Python, and so there's a huge community there. Right? So there won't be any error that has not been experienced by any, I mean, other developers. There'll be at least one guy who would have got the same error as you have. So who found out? I mean, who invented Python? It was Van Rossum. Okay, and it is based on Monty's Python Flying Circus. It's a comedy show. It's available in Netflix. You can see it. It's pretty old. I think it's 1970s or 1960s show. So based on that, it was named. people have this misconception that it is named on the snake, but it is not. It is named on that particular shop, right? So why should you learn Python? As I said, it is simpler to learn. It has a huge market, right? It's not just people are not just looking for PySpark developer. The Python has a huge market for other stuff also. For web developers also, they may be looking for Django developers, right? So Django is again Python, and they may be looking for people with CGI knowledge. That is also again in Python, right? Or in data science like pandas, numpy, people who know that, right? So huge market available outside of big data as well, right? And as I said, large open source community. There are a lot of people who have faced the same issue that you have. You'll always get an answer, right? It is efficient. Coding is efficient. It's easy to read, and it has an extensive library set. You can connect to any machine, any source. I'm pretty sure there'll at least be one library available for you to do that. Popularity of Python was because big companies started choosing it. Google, Facebook, 80% of their code, they're all written in Python. Okay. And React.js. Facebook has React.js also. That is also one of the main programming languages. But next to that, Python. Okay. Google also around 50-60% they're using Python itself. Dropbox was developed entirely on Python. Now they've changed it, I guess. I'm not sure. And then you have Raspberry Pi. It is like a mini computer, right? And which is built, I mean, the operating system Raspbian OS is written on Python, right? Built on top of Linux but written in Python. Okay. It's a mini computer, so you can check it out. You can do a lot of good projects using Raspberry Pi, right? And then a lot of other organizations use it. So that is the reason why Python is popular today. It started as a functional programming language in 1991. It was just pure functional programming, right? Meaning that there's no concept of classes and everything, right? But later on, since Java was popular at that point of time, people believed that if we bring the concept of oops into Python, then it will become as famous as Java. And that is why later on in Python 1.8 and 2.0, they started bringing in OOPS concept. So, but Python started as a pure functional programming language. Even today, it is still a pure functional programming language, but it has support for OOPS as well. So I'm telling you, this is a very simple topic. If you have knowledge about Python and its data structures, then feel free to drop off. There's no issue with it. Okay, so we'll start with Python variables, how we assign it, right? So generally, simple way of assigning it is just the name of the variable, right, and the value. No comma, nothing. You can do s equal to 20, a equal to 10, b equal to 30, and so on and so forth, or 30.00. C equal to hello. So the interpreter automatically defines the type. So it looks when it comes to this line. Okay, yeah. So Python is an interpreter based language. It's not a compiler based language like Java or Scala. So it is slower. Okay, and it's also dynamically typed. So the interpreter itself has to understand what kind of type or what kind of data type the particular variable is, right? So that calculation makes it slower compared to compiled based language, compiler based language like Java and Scala, right? I told you it's maybe if Java is taking 1 minute, this may take 1.5 minutes. So it's like half a minute slower. But this slowness is negated when you're working in big data environment because it is all parallel processing. So even though Scala Spark may be a bit faster, but it is all in milliseconds, not more than 5 or 6 minutes. So the difference is minuscule, so it can be ignored. That's why people go for PySpark rather than Scala Spark. Development time is also less. Code is also easier to read. A lot of libraries apart from PySpark, you can also bring in AI using TensorFlow or something like that you may need in your PySpark code. So all those are available, and that is the reason why they go for PySpark. So this is basically how you define a variable in Python. No data type should be mentioned like we do int s in Java, or we do string c in Java, right? You don't have to define types. It is dynamically typed, automatically detected during runtime. So this is one way of assigning it. Let's say you have multiple variables that is having the same value. Then you can just do s equal to w x or x equal to y equal to 20, something like this. Or if say you have different values for different variables, but you want to do it in a single line, then you can use comma. So z equal to 10, uh, u equal to 20, and so on and so forth. So this is just making it in a single line. So we'll go to the next one. There are certain reserved keywords. Okay, let me 20, comma b, comma x, comma x, y, oh, int, remove c and b. Okay. You may have seen system out println in Java or in Scala, right? So in Python we have print. This will print the value to the console, that is the user's console, right? And it will take, you can print it like this, or if you have different data types, like you have a integer, you have a string, and so on and so forth, and you want to print it in a single print statement, what you can do is you can put placeholders, okay, and convert all of them into string, comma, comma, okay, 1 2 3 4. Then have to do format. So this is another way of doing it. String attribute format MIT. So you can put placeholders here. Other types also can be joined. I didn't mention the placeholder, sorry, my bad. Okay. But if I just directly do print, it will give me an error saying that they're of different data type. Let's see if it gives me an error. Okay, it did print it. Earlier versions they used to print error because this was string and this is float, whereas this is integer. So in a single print statement, it wouldn't take. Another way is to do string concatenation. Like if you have hello, then you can do plus, then you can do world, right? So we can concatenate within a print statement, and you can print different string variables, right? Or you can convert an integer variable into string and do it. That's also not a problem. So for example, we convert a into string and do it, it will print. But if I do this, it will give me an error because it's of two different data types. So unsupported operand, int and string, right? So the errors are also very clear within Python. You can just read the error and understand. Even if it is complex, as I said, Stack Overflow, there will be definitely one guy who would have faced it. So in fact, in Colab, you automatically get a button that will say that search this particular error in Stack Overflow. Right? So click on that, it will take you. And it's not just Stack Overflow. Stack Overflow is the common, troubleshooting website. I'm just saying that. Otherwise, there are a lot of other websites also where you can find the solution. So this is how you assign multiple values to multiple variables, same value to multiple variables, right? And then you want to print the value of a particular variable, you can use print statement. Okay. So we have, go to the reserved keywords. Okay. So just like in every programming language, even for Python, we have reserved keywords. So these are the keywords available, okay, and each has its own purpose and function. For example, assert, it's not assert, it is assert. Assert will take two values and compare whether they're equal to each other or they're not equal to each other, right? Then we have def, okay. So def is used for defining a function, okay. So when you want to create a function, first you have to give def and then you have to give the function name, right? Then we have class that will define a class. So if you want to define a class, you have to give a class, then you have to give the class name, okay. Then continue and break statements, they are similar to what you have in other programming languages. This is to either skip an iteration or break out of the current iteration, right? So that is the use of continue and break. We'll anyway see continue and break when we look into loops, right? Then we have else loop. So we, for that we use else. Then we have elif loop. So in other programming languages, there's one difference. We have else if, right? So you may have something like this: if loop, then you have else if loop, and then you have else, right? So in else if, okay. So in other programming language, this is the structure, but in Python, only difference is instead of else if, it is elif. Okay. if elif else, and we don't have flower braces, we have semicolon and indentation. Okay, and we'll come back to the indentation part of it, and just remember this is the structure for if else. We'll anyway go through that again. Then we have finally block. This again you must have read it while you are doing exception handling, right? In every programming languages, at least in Java or Scala, you have final block. That is, even if an exception occurs, you have to do some manipulation even if there's an exception, right? So those kind of code goes into the finally block, and for that the keyword is finally. Then we have delete command. If you want to delete a data, we can do del, right? Then you have except for exception, right? Try and except block, right? So you have try, you have except. So try will try a particular code. If there is an exception, it will go to the except block, right? And after that finally block. So that is how it works. Then we can declare a variable as global. Okay, what happens in each inner block? If any variable that you have defined, it is only limited to that particular inner block itself. It is not available throughout the entire program, right? So in case that is such a requirement comes, then you have to define a variable as global. So you have to use the keyword global. Then we have a for keyword for loop, then if for if loop, then from and import. So these two are used to import a particular library or module from external sources or your own third-party modules, or the modules that you have developed, right? So you want to import them, you can use from and import. Okay. So import will import a particular module, right? But within that module, you only want to import a particular class or a particular function. Then what you can do is you can use from, you can give the module name, and within that module, you can import the particular class or particular function by giving it after import. So it will look something like this. From OS library or OS module, import only ls-dir function. Ls, what is the function? ls list directory. Okay, so you can do import list directory. So this is a function within the OS module, right? So I just want to import only this. I don't want to import the entire library. So when you import a particular library, the entire code gets attached to your current code. So let's say when I do import OS, let me do OS and remove this. So what happens? It reads the entire OS library and appends it to this particular code, okay, at the beginning. So in case you want your code to perform well, do not do a star. It is like, in Java you may be doing something like this: import os dot star, right? So this is equivalent to that. So this will import all the functions. Same like that. If you want to do, you can do import os, and then for each function you have to do os dot function name. So that is one more thing that you have to do. You have to use the name of the library and then dot operator and then call for the function. Okay. And the other thing is all the functions get copied to this particular your script that you're developing, right? So that becomes a disadvantage. Disadvantage how? Let's say library is very big, the imported library. It may be like 2 lakh, 3 lakh code. Then it will hit your performance because that entire code is added or appended to your current code and then it executes, right? So, I mean, it's not a huge performance issue, but a minor performance issue. Okay. So that is one of the reasons. Anyway, we'll look at that at the end of the next session. What is import, what is from? I'm just giving you an idea. If you want to raise an exception, you can use the raise command. Again, you will see when we are doing exception handling. Then we have or and. Where is and does not yeah and or. This is the same conditional operators. Like if there are two operands, if both of them are true, then the entire statement becomes true in and. In or, only one of them have to be true, right? Something like that. Then we have return. So this is a return statement that you write at the end of every function. It will return the variable. So every time you call a function, that particular variable value will be returned back to the caller. Then we have a special keyword called as pass. You have, suppose you have a function, you have defined a function, but you are not going to at this point you are not going to define anything. Let's say you have a function called as a, right? And you have kept it for future enhancement. So you are just at this point you don't want to write any code. So you can just do pass. It means this function is not doing anything. Okay, that is one of the reasons why pass is used. Okay. Then non-local, if a particular basically global and non-local, these keywords are not used, because if at the outer layer or if at the root level you're defining any variable, that is by default global. Okay, that can be accessed throughout the script. So basically people don't use global. Same goes for non-local. Anything you don't want to define it as a local variable, you can give it as non-local, but these are not used. Okay, as I said, if you are declaring it at the root level, you don't need any of that, right? Then in is a identifier operator, is a membership operator. So we will see what are they're a bit different. So this is something new to Python. Okay, not, you have anyway seen, it's negate operator, right? Anything true, it will make it false. Anything false, it will make it true, right? Then lambda is a keyword used for creating lambda functions. Okay, then other than that, we have special variable called as none. Okay, in other programming languages you have null. Okay, always be careful, we do not have null variable in Python. We have none variable. Okay, that means empty, that variable has nothing. Then true and false, they are boolean values, and as is for aliasing. Okay, so these are the special keywords that you cannot use. Okay, so now different types of literals. What are literals? Basically it's a kind of constants, basically data types that you use, right? The variables that you use. So we have string literals, we have numeric, we have boolean, and we have special literals. Special literals are nothing but none, what we saw, none literal, and we'll anyway see it one by one.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. dstream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So within string literal, you can define a string literal using single quote, okay? Or you can use triple single quotes, and you can make it a multi-line string, right? So you don't have, let's say you have a big paragraph and you want to put it as is, but if you put it in a single quote like this, the line becomes too big, right? You want to break it up, so you can use multi-line string. For that you have to give triple quotes. At the same time, you can also use double quotes as well. So you can use name3 equal to double quotes hello world, and at the same time you can also use multi-line in double quotes, multi-line2 equal to triple double quotes. Okay, hi, this is to check multi-line. So that is about string literal. So I'll go to the next one. So within numeric literals, we have different data types. One is int, other is long, then we have float, then we have complex type. Okay. So int, if you have between 2 to the power minus 32 to 2 to the power plus 32. Okay. So if you have such big numbers, you can use int. If you have bigger than that, you have to use long. Okay. Then if you have floating numbers, you can use float. If you have an imaginary part in your value, then you can use complex, right? So this, I think, complex type you don't have in other languages, but we do have in Python. Okay, so we will see the complex type example. So this is one of the example for complex type. So I've created a variable called a C, which has complex type a plus bi, right? So 5 is the real part, 3j is the imaginary part. So when I do C plus 3, it will add it to the real part. If I do C plus 3j, it will add it to the imaginary part. Okay, so let me print it out. Okay, so it becomes 6j because it added it to the imaginary part. Okay, so that is a complex type that you do not see in other languages. Other than that, float, integer, they're all same. If you want to, if you have a floating number, you can define a floating type, right? If it's an integer, it will be without the floating point. And if you want to find out a particular type of a particular variable, you can use the keyword type. I don't know why it did not come in reserved keyword. Oh, no, it's a function, correct. It's a function, inbuilt function. So you can give type, and within that type, you can pass the variable. It will give you an output saying that it belongs to class integer or class float, meaning that particular variable is of integer type or float type. So, or you can use, let's say you want to put it in a condition, you want to check if a is integer, then only go to the next block of code, right? So you can use if instance a integer, then print a is integer. Okay, argument must be of type tuple. This instance. And while doing the if loop, I'll show you why it is taking this instance x and a, maybe a given target check against is equivalent to xa or x is instance b. Okay. Oh, this has a tuple. Okay. This instance of instance object class of tuple. Oh, sorry, it's instance class integer support. Okay, so we print it out. Okay, wait. Okay, I'll anyway show it on the when we do it loop. Okay, so we can use this instance to compare it. Oh yeah, yeah. Sorry, I've done it here itself. So this if its instance is a comma integer, is an integer. So you can use it like in a if loop to find out, or within a print statement I've done it just to check if C is a complex type or not. So it has given me true Boolean value. Okay. Okay. Yeah. Before going, I forgot to tell you how indentation work. Okay. So if you see here, this is at 0 level indentation. That means there is no indentation. This entire thing is one block, right? So now if you want to change it into a different block, I mean, you want to put a code in a different block of code. Let's say you have an if loop or a for loop. So that particular for loop or an if loop is a different block altogether, right? So we have to give if x or if a is greater than 10, something like that. And then we have to give a indentation. So that would mean that this is a separate different block from here. So here, whatever I type, print a is greater than 10. And let's say I'm doing b equal to 20. Okay. Print b. Right now I come out of this block by just removing the indentation and I try to print b. Okay. So what happens here is within this block I created a variable called as b, right? And I'm printing it out within the same block. But then I came outside that particular block and went back to 0 level indentation, and there I'm trying to print b. It will give me an error saying that this particular variable is not defined because the scope of this variable is only limited to this block itself. Sorry, it's limited to this block itself. Okay, so outside this block it goes into garbage collection and you don't have b, right? So that's why it will give you an error. Basically it's a local b is 30 or defined b here. Sorry, defined b here, so it is taking from there. Sorry, my bad. Let me say l like that. 4 4. Okay, so how was it printing l? This should have been a local block. Just saying f and calling it's still giving me error. Cell is defined anywhere else. X, Y, Z, assets. Okay. Okay. Anyway, I'll let you know why. How come even a local object is being printed outside, accessible outside. But anyway, this becomes one particular block. When you give an indentation, it becomes a different block altogether. For example, within this particular block, again there's another block being created. You are using for loop or something, right? For in 1 to 100, you create another block, right? So this becomes a new block. So this is another new block, okay? And this is the outer block for it. And for this, the outer block is the main zero level block, right? So each indentation defines a block. This is similar to your flower braces. So you may have flower braces like this in Java, right? That may end somewhere here, right? And within this, you may have another flower braces. It starts there and ends here, right? But instead of flower braces, we have indentation. That's why the code looks much easier, because I don't have to go every time here and okay, find this flower braces ends here and it starts here. I don't have to find that. I just have to look at the indentation and understand where each block of code is. Right? And other than that, there are certain rules, standards, programming standards in Python. It is called as PEP8 rules. Okay, and these are the standards that you need to follow while you are doing the Python program. For example, when you are using any operators, you have to always make sure that both the operands on both sides have a space between them. I mean, it works. So even if you do c equal to 5 plus j, okay, but it's against the PEP8 rules. If you have a good interpreter, it will actually, I mean, if you have a good IDE, it will actually give you a warning saying that this is against the PEP8 rules. For example, I use PyCharm. Okay, so PyCharm is a good IDE. So if I do, let's say, let's not take a new. So let's say it's already giving me an error. What is it? Separate rule. Expected two blanks, found one. So after every function, the next function should have a gap of two lines. So that's what it's saying. Here, what is it? Expected two blanks. Even while calling the function, it expected two lines. So that is one error. Now, if you see here, on both sides, there is no space, missing white space after this. For a comma, that is the rule. Here, what is the error? Missing white space after this. Here, also error. Here, what is it? No new line at the end of the file, right? So these are all PEP8 rules. And if you do C plus equal to 10 plus 20. So if you see, it will allow, okay, there's no error per se. I do print C, it will run. The code will run.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
The code will run and it will print the result properly. But it is a warning. Okay, so if you have a good IDE, you'll get a warning and you will know what PEP8 standard you are missing. It's saying E225 missing white spaces around the operator. Okay, so around the operator it has to be there. For comma, only the next what do you say? Next variable or whatever key that you are using, that has to have white space. Same goes for colon. For all other operators, you have to use white space around the operator. That means on both sides. So this is the PEP8 standard. Okay. This is something that you have to follow. You will see it in your client environment, coding standards and all. They're all developed based on PEP8 itself. Okay. Everyone is expecting that. It's something common knowledge among Python developers. If you're going to tell yourself in an interview that you're a Python developer and then you don't follow these standards, they'll ask you how come and all those things. Okay. So be careful with that. Having said that, next is complex types. Then we have Boolean type. Okay, so Boolean type is of two types, true and false values, right? A variable can be true or it can be false. Just like in other programming languages, there's no special stuff here. So the next thing we have is special literals. So this is what I was talking about. In other languages, you have null type variables. Here we don't have null type. If you define null, it will take it as a variable. So if you say d equal to null, it will look for a variable named null. Okay, so it is looking for something like this, null equal to 10, right? Now it is correct. So null is not the null type that you see in your Java. Okay, here it is a variable, so that's why it worked. If I do remove it, I'll get an error saying that unresolved reference to null, meaning there's no variable name called as null. So that's why it is an error. Okay. So instead of, if you want to make a variable empty, you have to use none. So instead of null, you have to use none. And now if you print d, it will say none, meaning it is empty. Okay. So this is a special literal in Python. So we have same operators, still bitwise operators, everything is same as in other languages. We'll go through them one by one very quickly, right? So you want to execute this example. So let's now go into different kinds of operators. So we have arithmetic operator, we have plus, minus, multiplication, division, and reminder, right? So reminder operator or modulus operator, you are aware of what it is, right? It is just same like what we have in other programming languages. If you do a into equal to, it only means we are doing a equal to a into 100. So these two are same, okay? And same thing you can do for plus equal to, minus equal to, division equal to, and modulus equal to, right? Pretty sure that you guys have done this in other programming languages. So then we have comparison operators, like we have less than, greater than, less than equal to, greater than equal to, plus equal. Oh, sorry. So this assignment operator, sorry. Yeah, so this assignment operator. We are doing comparison. So then we have comparison operator, which is greater than, less than, greater than equal to, lesser than equal to. Okay. So here we are using if loop and we are using the less than operator and comparing is if a is less than b, right? If it is true, then it goes inside this block and prints this particular statement. If you look here, there is a tab there. So yeah, each indentation is one tab. So for a next block, it will be two tabs, right? If you're creating another if loop, if b is greater than a, something like that, and print blah blah, and this condition doesn't make sense, it will never be executed. Yes, greater than 10, something like this. Okay. So within this if loop, you are going to create a nested if loop. So if you look at here, this is two tabs or four spaces. Each tab is two spaces, right? So totally four spaces for the new block. Okay. So on and so forth. If you keep on creating new blocks, you have to keep on giving tabs extra. You have to append tabs to the existing tab count, right? So the upper block had two tabs, the new block will have three tabs, then the inner block will have four tabs, the next inner block will have five tabs, and so on and so forth. Okay, so that is what I meant. Then we have logical operator, which is a and, or, and not, right? So as I told earlier, this operator takes two operands, and operator basis especially takes two operands, and both of them have to be true if the entire statement has to be true. Okay. For or, only one of them have to be true, the entire statement will be true. And for not, it will invert the existing boolean value of that particular operand. Okay. So anyway, so this you basically use in any conditional loop. So if is holiday and is Sunday is true, that means Sunday is a fun day. Okay. Else it's not a holiday. So if one of them is also false, it will go into the else loop. Here is holiday is false, so it will go to the else loop and print not a holiday. If I make both of them as true, and print Sunday is a fun day. Okay. I make both of them false and I make this as or, then it will still say Sunday is a fun day because one of them is true. This Sunday is already true, right? And then if I do not Sunday, that means Sunday is true, then it becomes false. So this entire condition becomes false. It will never be executed. It will say not a holiday. Now if I say not holiday, it is true. It will go inside the statement and make it Sunday is a fun day because this holiday is false. So the bitwise operator is we have bitwise or, bitwise and shift left and shift right and not operator. Okay. So and is nothing but it will convert both the operands into binary code and do the and operation. So let's say we're doing 7 or 5 and 7 and 5, right? So we do it 7 and 5 or 5 and print 7 and 5. So here what happens is 7 is 1 0 1 1 4 2 6 1, yeah, and 5 is 1 0 0 1. So when you do OR, 1 is true and 0 is false, right? So that is what the binary values are. So 1, that is true, and true is true. True or true is true, right? 1 or 1 is always 1, right? True and true. 1 or 0 is also 1 because only one of them have to be true, right? Only 0 or 0 will become 0. So that is how OR works, right? So now if we do 1 or 1, it is 1. 1. 1 or 0 is again 1 because one of them is true, right? 0 or 0 is 0. Then 1 or 1 again is 1. Okay. So the output is 7. So 7 or 5 is 7 again. 7 and 5 is 5. How? 1 0 1 1 1 0 0 1. Here true and true is true. This will be 1. True and false will be false. So this will be 0. False and false is false. So again it will be 0. And true will be 1. Right. So now the final output is 5. So that is your bitwise and OR. Now let's say I want to do shift left and shift right. So what is that operator? I'll tell you. Print 7 to 7, shift left by 2 bits. So what happens? It is 1 0 1 1. It will shift a little bit, shift by 1 bit. Okay. So it will become 1 1 1 0. Okay. So that is nothing but 4 plus 2 7. Sorry. 2 to the power 1, 2 to the power 2, 4, 2 to the power 3, right? Something you can check it out. 14, correct. So 1 1 1 0, right? 4 4 to the power 3 is, sorry, 2 to the power 3 is 8. 8 plus 4, 12. 12 plus 2 is 14. Okay. So it shifts by 1 bit. If I do 2 bit, this will become 1 1 0 0. So basically 8 plus 4 is 12. Okay. 28. How it shifted by 2 bit, right? So it becomes like this, I guess. Yeah. 1 1, it adds 2 0 again. Correct. So 2 to the power 3, 4, 2 to the power 4 is 16. 16 plus 8 is 24. 24 plus 4 is 28. Yeah, correct. So this is how it shifts. So if I do shift by 3, it will shift. Basically, it's on an 8-bit scale. It is like this 0 0 0, and 7 is 1 0 1 1, right? So now I did shift right. So shift right by 1, right? So 1 bit became 1 0. Okay. Now when I did shift by 2, this became 1 and 0 was appended at the end. Okay. The same is opposite when we do shift right. It will move to this position. Now it is 1 0 1 0 1 1. 1 will move here, so it will become 2 to the power 3 8. 4 and 3, right? So 7 itself is like this. My bad. 7 binary is this. I think everything I did wrong. Anyway, so when it shift right, it will become 0, and I think 1 it will be reduced. So it will be 3 if I'm not wrong. So let me do shift right by 1. Yeah, it will be 3. Okay. So my bad, I was giving the wrong binary for 7. This is actually 7. 5 is 101. Okay. So anyway, output 7 and 7 or 5 is same. 7 and 5 is same. Okay. Only thing is, while doing the shift right and shift left, I explained it in a wrong way. My bad. Okay, so that is what bitwise operators are. So I'll continue to the next one. So the next two operators are something original to Python: identity operator and membership operator. So as I told you, is and is not is identity operator. So what it says is whether the left hand side is identical to the right hand side. Okay. So when you say x is 10, it is trying to compare if the left hand side operand, which is x, has the value 10. Okay. If it is, then it will give you a boolean output which is true. Okay. So x equal to 10, print x is 10, will give true, print, so it will give true, or else it will give false. Okay. If it's not identical, it will give false. Okay. Then if you want to do a reverse condition, you can put not, it becomes is not, it becomes true because x is not 11, right? It is 10. So that is your identity operator. Then we have membership operator. So this operator at this point may not make sense to you, in and not in, right? But when you learn list and tuples and other data structure, you will see in being used frequently. So what in does is, so let me give you a brief. So in Python, we have something called as a list, which is similar to arrays. What you have arrays in Java and other programming languages, we have list. Okay. So let's say I have a list of fruits, apple, orange, banana, something like that, right? And then I want to check if a particular element, these are called as elements of a list, right? So I want to check if an element is a part of this particular list, right? So I can just do print and do if let's say apple is a member of list 1, then print apple is a member. It will print because apple is a member of list. So this element is a member of this particular list, right? If I do, what do you say, pomegranate, this is not a member of this list because there is no element as such, right? So it won't go into the if loop at all. So this true is basically for this, don't get confused. Okay, so it won't go into the if loop at all, so there's nothing executed. Okay, so this is the main purpose of in. It's called as a membership operator. And if you want to reverse it, you have to do it not in. So now it should go into the if loop. Apple, let's say pomegranate is not a member. Okay, so this is how your membership operator works. Hope you're clear with this. Next, we'll look into the different data types in Python, right? There are two kinds of data types. One is immutable data types and mutable data types. What do you mean by mutable? Mutable means you can change or modify the particular initial value that you have given to a particular variable, right? Whereas an immutable data type, you cannot do it. So you may say, I am using string numbers. Okay. So let's say I have assigned a string a equal to hello. Then again, I'm using a equal to world, print a, print a. When I do this, I'm not getting any error. So you will say, you're saying string is an immutable object, immutable data type, right? But then how come an error is not being generated? The reason is simple. At this point, the old a is gone to garbage collection and a new variable a exists. If you want to confirm it, you can look at the memory addresses of each of both these variables. It will be different because they are two different variables having the same name. Okay, so that's why if you look at this, it's a same different variable altogether, right? So it's a different variable but having the same name. That is the only reason why it doesn't give any error. Okay, so that is all about mutable and immutable objects, immutable data types. Okay, so strings are immutable, numbers like integer, float, all of them are immutable. Then we have a special data type that is in Python, we call it as tuple. They are immutable. Okay, so once you define them, you cannot modify the elements or contents of these particular variables. But however, in mutable we have dictionaries, list, and sets. Okay, so here you can change the elements of the particular variables. Okay, so we have numbers type. As I told you, we have within numbers we have integer, float, long and complex. Okay, so integer and float belong to number type, and String belongs to string class. Okay. So now we look at strings as well. The next data type is string. So string is, as I said, it's a continuous character, or it has continuous characters as values, right? And within string, there are a couple of functions that you can do. For example, we can split a string. It's called a string split or string indexing. You can call each character by its index number. For example, you just want to have the value of the third character within the string, then you can just give var2, then it will print out that particular character, right? So it is printing out L, right? And let's say you want to print a subset of a particular string, then you can use this kind of notation. Okay, so you have to give the starting point and the ending point. Okay, so starting, it always starts with 0, and ending will be the total length minus 1, same like how it is in other programming languages. Okay, but there are special ways to do it. You don't, if it's going to start from the beginning, right? If the substring is going to start from the beginning of a main string, so you don't have to mention 0, you can just do it like this. So this, by default, this notation means starting point is 0, ending point is 6, right? At the same time, if you don't want to mention the, you don't know the length of the string, you don't want to do the length, find out the length and then do length minus 1 and give it here, you can just do 6 and end, and it will go till the end of the string. So this would mean 0, 1, 2, 3, 4, 5, 6. So from here till the end. Okay, so that will go to the substring tutorial. Okay, whereas 0 to 6, you don't want to give 0, 6, it will print from here till here. So the last point is exclusive, it's not inclusive. Okay, so this is called a string split. Then we have a couple of functions within string, like we can find the length of a string using length function. Okay, var2, so it will give you 14. Then you can reverse a string. It gives an object. Let's put it into a string. And sequence string. Let's see if this works. String. So there's an object, but it won't print it. Okay, yeah. What are the functions?
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Yeah, find, we have, yeah, these are the important functions. We have find, we have replace, we have split and count, right? So let's say within a string, you want to find a particular sequence, we can use find. Let's say print var2 dot find, and let's say h1, right? So here it will give me the location where the h1 starts. Okay, so it will give me the index. So it starts from 3, so 0, 1, 2, 3, right? So that is what it is saying. So you want to find a substring or a pattern within a string, you can use find. Most important function is split. So what split does is it will take a string and split it. So let's say I'll create a string. Okay, this is a string, and I want a list of words instead. Then I do split, and here I give the delimiter or the character by which it has to split the string as white spaces. Okay, so now when I do this list one, it will split the entire string on the white spaces, and whatever the element or whatever the string substring came out of it, it puts it inside a list. Okay, so if you see here, each of the words became an element of a string because it has a white space between itself. Okay, so you can give any kind of characters here, it will split based on that, and it will convert it into a string, convert it into a list. Okay, here there is no comma, so this entire thing will be one big element, and it will go inside a list. Okay, you see here, there's only one big element of a list, right? Because it couldn't find anything. Hope you understood this. Then we have replace. So in replace, we can give a character to replace with another character. Okay, where to replace initial character can be H, P, and we will replace it with T. Okay, now when we do it, sorry, now if you see, P has been replaced with T. Okay, so wherever P occurs, it will replace it with T. Then if you want to get total number of characters similar to length, you can do where to dot count. Given 0 given, okay, count itself, it has to go inside. So count, sorry. We'll give the count of a particular, sorry, my bad, particular character, how many times it appears within the particular string, right? So P appears one time, okay? So then I'll move on to the next one. So next one is tuple. Okay, so this is a special data structure that is in Python. You won't see it in other languages. I'm not sure if it is available in other languages or not. Okay, so yeah, so how do I define a tuple, right? So tuple is basically like an array itself. Okay, so list, tuple, sets, they're all similar in structure. Basically, they're collection of heterogeneous elements, right? Only difference is tuple is immutable, meaning once you define a tuple like this, you cannot add elements to it. You cannot remove elements from it, right? So that is something that is only special to tuples. Whereas list and sets, you can add any element to a set, you can add any element to a list, you can remove any element from a list, you can add any, you can remove element from a set. It is available because both of them are mutable. Whereas tuple is immutable, right? Other thing is list on the other hand can have duplicate elements. So there can be one element called as A, right? There can be another element called as A as well within the same tuple or same list. Both tuple and list can have duplicate elements, whereas sets cannot have duplicate elements. If it has duplicate elements, it will remove one of the element and only keep one copy only. Okay, so that is something to do with sets, and that is the difference. So there are minor differences, but overall they are a collection of heterogeneous elements and the way it is defined. For example, tuple is defined using curve brackets. Lists are done using square brackets. Sets are done using flower brackets. Okay, so we will see all of them how it is defined. So if you see here, I created a tuple called as tuple1, right? It had these elements. Then I try to modify it. It will create a new element. Even though it is immutable, that doesn't mean these two are same tuple. They are at a different location. Okay. So if you look at that, that tuple was in this location. Then the new tuple that I changed is in this location. Sorry, this tuple is in this location and this tuple is in this location. Okay, so it is immutable. You cannot change anything. You cannot modify a particular tuple. But list and sets you can modify. You don't have any problem with that. Sets also you can modify. You don't have a problem. But tuples and list, they can have duplicate elements. Sets cannot have. I mean, even if set has a duplicate element, it will remove the duplicates on only keep one original copy. Okay. So those are all the differences. Then in list, again, same thing as tuple. Only thing is here they've given it wrong. We give square brackets instead of curved brackets. Okay, and here you can do modifications. So you have a lot of different functions. We'll see them one by one at the end, right? Okay. So the next one is dictionary, right? So what is a dictionary? So in you saw in list we have indexes, we have tuples, we also have indexes, right? For to access an element of a tuple, you just have to give the index number. Same thing goes for this also. What do you say? List as well, right? So let me create a list. That's one. Equal to A, C, tuple. So what was print tuple one? First element equals 0. Print list one. First element we give 0. Okay. We use the index numbers to access the elements, right? So yeah, so with list and tuples, we saw that we have indexes, index numbers, and through which we can access the particular element, right? But in dictionary, we have a custom index. Okay, so we call them as keys and the value is called as value. So dictionary is nothing but a key value pair. Okay, it's a key value pair data structure. Why is it called a dictionary? It is just like how it is in a dictionary. We have a word and we have a meaning for it, right? So we have a key and we have a value for that particular key. So that is why it is called as a dictionary. And dictionary is defined using flower braces. So both sets and dictionaries are flower braces. Only difference is set doesn't have a key. It has indexes just like list and tuples. Okay. So flower braces, then you have to give the name of the key and the value for that particular key. Okay. And key can be any type. It can be of integer, it can be of long, it can be string, right? Value also, it can be anything. It can be a string, it can be a list itself, right? The value can be a list, it can also be a tuple, or it can be a dictionary itself. Okay, so we can have a nested dictionary. So there's a key and the value for it is a dictionary itself. So that becomes a nested dictionary. Okay, so you can have anything as value, but for keys you can have string, integer, float, and other normal data types. You cannot have collections like tuples, list, and sets. Okay, so the key has to be within the normal data types, not the collections, what we call as collections, right? Then we have set, as I said, similar to tuples and list, very similar to list in the sense it is mutable. That means the values can, the elements within the sets can be modified. It is defined by flower braces, right? Only difference between list and sets is it cannot have duplicate values. So even if you add duplicate values, you will only be able to see one value. So let's say set1 equal to set or this. If you see, even though I added multiple fours, it only kept one four, right? So that is what set is. And one more thing I forgot to tell, you don't have to define set tuple list like this. You can also use the list function itself. List1 equal to list curve bracket 1 the print list 2 as list 2. Same goes for tuple and sets. Set2 set2 into tuple set. Why is it not coming in green? It should have. What is the difference between this and this list? And let's execute this. There's an error. I think it doesn't take an argument. Okay. It takes. Okay, it has to be in list format only, I guess. It has to be in tuple format. And this has to be in set format, I guess. Set2. Okay. So you can even define it like this. Okay. You can use the function and do it. That is one way of doing. Don't bother about them. You may be using this when you're creating an empty list or a tuple. So you can just do list equal to list. So you're creating an empty list. Right? So you can then later on append and create more list. I don't see any use for tuple that way because tuple is immutable, right? Okay. Okay, so now we'll go into flow control, right? So we have different loops. We have if else loop, nested if else loop, that is elif loop. Then we have for loop, then we have while loop, then we have break and continue statement that are used within all of these loops, right? So we'll look into each one of them. So I've already shown you how if else works. If 10 is greater than 20 and is greater else then it is lesser. Okay, so 10 is not greater than 10 is definitely not greater than 20. So this condition fails. So this if block is never executed, then it goes to the else block and prints whatever is there in the else block, right? So that is how if else loop works. In case you're not aware, it is very similar to other programming languages. Only thing, you don't have to put the flower braces and all. You have to use colon and you have to use indentation, right? So now within this if block, I can have another if block doing something else, right? 1 greater than 2, print 1 is greater, else print 1 is lesser. So this is what we call as nested if loops. Within an if loop, we are having another if loop. So it's a nested if loop. And we can also have a if loop with multiple conditions. Let's say if 10 is greater than 20 is false, right? Then I can do elif 10 is greater than 5 and 10 is greater than 5 and so forth, right? So I can have multiple elif conditions. So any one of them, it becomes true, that it will go to that particular block and execute. This elif also will fail, right? So then it will go to the next elif statement. It will say, okay, this is true. And it will go inside that particular elif block and execute whatever statements are available inside. Okay. This is all about your if else, nested if else. If the condition is true, then it will execute that particular block. If it is false, it will go to the else block. Okay. In nested if loop, if a particular condition is true and if it has more if else conditions within it, it will execute it. Or if it has an elif condition, it will go to the next elif condition. If that elif condition is false, then again it will go to the next elif condition, so on and so forth until the last else loop, right? Then we have for loop in Python. It is very similar to, in a sense, how it works, but different in terms of syntax. You wouldn't have seen the same syntax in Java or any other languages. So the syntax is like this. So we have to use a for keyword, then we have to we have to use an iterating variable, and then we have to give a sequence. Okay. So in other languages, we used to do like this, right? For example, in Java, for I equal to 0, I less than 10, I plus plus, right? So here it would start from 0 and it will increment it after every loop, and it will run till I is 9, right? After the ninth value iteration, it will become 10. This condition will become false and it will escape from that particular loop, right? So the concept is however same, but the way we define it is different. We have to create an iterator variable, okay, iterator var1, and then you have to mention the sequence, okay. So here I can use in range 1 to 100, print a, okay. So what it does is I created an iterator variable, okay, and I'm mentioning whether it is part of the sequence. As long as it is part of the sequence, keep on running this loop, okay. So the sequence is nothing but a range from 1 to 100, right? So first the iterator value will be 1, right? So it will run it. Next time it will become 2, next time it will become 3, next time it will become 4, till 100 it will run. At 101 it will escape because the condition becomes false, okay, because this membership operator no longer satisfies. Iterator value is now 101, which is not part of this sequence. Okay, so it is false, so it will move out. So this will print 100 times A. Okay. I think the last part is non-inclusive. So 99 times basically. Range start, stop, range of sequence. Start is inclusive, stop is exclusive. Yeah, sorry. So it is 1 till 99. Okay, so 99 times it would have run. Best thing is to just print the value itself. So if you see here, it will start at 1, ended at 99. Okay, so it ran the loop 99 times. You can also give a skip this one also. And there's another step. Yeah, so step is, I think third argument will take it as step if I'm not wrong. Yeah, 1357. So this will give you the number of increments, right? After each iteration, instead of incrementing by default by 1, it will now increment to 2. So iterator var, first it will be 1, next time it will be 3, next time it will be 5. So it will run 48 times, right? 48 something, right? What is the last number? I mean, number is 99, but okay, fine. I have to give an iterator 1. What is the last value? It runs 50 times. Okay. Okay, so that is how for loop works, right? There are other ways also to use a for loop. Instead of giving it as a sequence, you can use a variable that will iterate over a particular list and print out that particular element. So in this case, the iterator value is not a particular sequence number. It is in fact iterating over a list. So it will be each element in a list. So first time the value of Z will be apple. Next time it will go into the next element, that will be banana. Then next time it will be cherry. The next time it will be watermelon, right? Then afterwards it will become none and it will cease to fulfill this condition. So that's why it will move out of that particular loop. Okay, each time you see the value of Z is each element in the list, so it goes one by one by one by one, iterates over it. So this is another way of using for loop. Okay, where exactly tuple is used in real-time environment, right? Okay, so there's a question on tuple real-time environment. See, you're looking at, you have seen list, you have seen tuples. So RDD, what we saw in PySpark, is basically a list of tuples. So you may find some real-time places. Okay, let's not talk about PySpark. Let's only talk in Python world. We may see complex data types like list of tuples. So you may have some value. Okay, yeah. So let's say we are using CSV. Yeah. So CSV reader import. Put in Python, I may have a CSV file somewhere. Do we have a CSV file here? No. Import CSV, right? Unequal to CSV dot reader data final dot CSV. Data final CSV. And I think it is a list of dictionary or list of tuples. So dictionary reader, right? Okay. For item in one print item. It's a dictionary, but within a dictionary, if you see, it's a list of tuple. So it's a dictionary. Each row in the CSV file is a dictionary. Within that dictionary, it's a list. Within that list, each column value is a tuple. Right? So you may see some real-time examples like this. Otherwise, also you may put a list of tuples, or for having a complex data type. Let's say, yeah, let's say you want to put it in a you want to have cricketers information, right? Cricketers info. Okay, so here this variable has two rows and each row has three columns, and they have the number of matches that a particular player has played, the name of the player, and then number of 50s. Okay, I can use it like this: 100 Sachin. So I can have a list of tuples, or else I can also have. So what this structure brings in, this complex structure, list of tuples, it kind of gives you kind of row and like a table-like structure where the list defines the table and each tuple defines each row in that particular table, right? That kind of structure you'll always see list of tuples. Tuples, on the other hand, also has its own applications. Okay, I mean you can put anything in a tuple as long as it's not going to change. It's okay. Okay. So next is the while loop. Okay. While loop is very similar to your same what do you say, Java or Scala while loop. Okay. So you mention a condition in after while keyword, right? If it is true, it will go into the loop, and again at the same time, whatever condition or whatever variable that you have mentioned, you try to manipulate it so that it keeps on iterating, and at a certain point in time, the condition fails and you move out of the while loop, right? Same thing what you have done in Java. Syntax is also same, right? Only thing is instead of using flower braces, you are using colon, and then you are using indentation, right? So this entire part is part of this while loop. So that's how you do it. Then if I come out of it, this is outer block. This is the while loop block. Okay, so always remember, you have to look at the indentation, and based on that you have to define you need to understand where each block of code is written, right? So here it will run I equal to 1, so it will run, then I will become 3, it will still pass, it will print 3, then it will become 5, it will print 5, then it will fail and it will move out. Okay, so again it will print 5 and it will print 7 because before moving out it has already incremented it to 2. So 7 is less than 6 becomes false. So that's why it moves out of the loop and prints the value I, right? So this is outside the loop, whereas this is inside the loop. So don't get confused. Also remember, no, don't make a condition such that it can run infinitely, okay? Or else your memory will become, you will get memory issues if you create an infinite loop. For example, while true, right? So this while loop will always be true, right? This condition you have already given a boolean value true. So the entire while condition will always be true and it will keep on printing I, never come out of the loop. Okay. So you see here it will keep on printing, it's still running, and after some time it will fail. Okay. What is the error it give? I think it's some memory error. Yeah, so there's some memory error. Okay. I gave a keyboard interrupt, or else it would have not stopped. So always make sure you give a condition that you know that will end finitely. Okay. So now we come to two looping concepts. One is called as break and other is called as continue. Okay. So break within a loop, if let's say we have an inner condition and if that inner condition is meant and if you give break, it will move out of the loop altogether. It will not go into the next iteration at all. Whereas if you give continue for a particular condition, that for that condition the iteration is skipped and the next iteration it goes to the next iteration. Okay. So now here if I is 1 and initially I is 1, right, and then at the end we are incrementing it to 1, right? So first time I is 1, it will print 1 and this if loop is false, condition is false, it's not 4. So it will go and increment itself. I will become 2. 2 is less than 6, again it is true, it will print true. This condition is again false, and so it will go here, it will increment to 3. 3 is less than 6, it is true, it prints 3. 3 is less equal to 4, which is false, so it doesn't go inside the if loop. It again increments itself to 4. 4 is less than 6, it prints 4, but 4 equal to 4 is true. Now it breaks out. So after 4 it comes out of the while loop and prints broke out of the loop. Okay, here it broke out of the loop after 4. It did not go to 5 at all. Next iteration was 5, right? It did not go. If I give continue and I put the print statement here, so it printed 1, 2, 3 and directly it will print to 5. Why is it taking so much time? It ran, okay, I created an infinite loop. If you look here, every time it is, when it came this I equal to 4, it passed and I did continue, so it will go here again. I is still 4, so again it comes back to the if loop. So if you see here, it is flowing there, goes to continue, goes to while, because still it is 4. So here what I need to do is I need to give I plus 1 here as well. Now it will break out. So now continue. So it came to I equal to 1. This is false, so it did not go to this block. It printed 1 and incremented itself to 2. 2 is less than 6. This condition is again false, so it did not go inside this loop at all. Printed 2, incremented itself to 3. 3 is less than 6. This condition is false. Prints 3, increments itself to 4. 4 is less than 6. This condition is true. Increments itself to 5 and skips this iteration altogether and doesn't go to this particular part of the loop. So it goes to I equal to 5. 5 is less than 6 and comes. So if you see here, 4 is missing. So it did not come to this place at all for that particular iteration. It skipped it. It went to the next iteration. Okay. So that is continue and break. Same thing. Here I've given it for 3. There I've given it for 4. Okay. So that's all about flow control statements, which is arrays in Python. So there's no concept called as arrays in Python. We just call them as arrays because it is lists are similar to arrays. Okay, so Python does not have a inbuilt support for arrays. Okay, and list can be used instead. So that is what we do. Even though there is an external library called as arrays, you can use that as well, but that is not suggested because that is developed by someone else. It is not inbuilt by it doesn't. It's not inbuilt functions. Right? The list on the other hand is an inbuilt function, inbuilt data structure itself. So you can use list as an array. Okay? So how do you access an element? As I said, you can use square brackets and you can give the index number. And so whatever the value, whatever element exists at that particular index will be assigned to a new variable, and then you can print out or do whatever you want. Right? How do you find out the length of a particular list? You use length keyword and you print it out. You'll get the list length of the list, that is the total number of elements within a list, right? Then if you want to add elements to the end of the list, you can use append. It will add at the end. Okay, so let me. So if you see, first I created an empty list, then I appended Praveen. That means it added to the last point. In this case, it was the first element itself. Then again I added tra, appended tra. So this gets added to the end. So if you see, the last element now is pra. So every time you do append, it adds to the end. Okay. Removing an element, you can use pop function and you can give the index number. Whatever element is there in that particular index, it will pop out. Or you can use remove function and give the element name itself. So wherever that particular element exists, it will remove all the elements having the same name. Okay, so a list can have two Volvo as its elements. Both of them will go with remove. Okay, you can use loops to access each element of a particular list. I think I showed you earlier on. Not for item in list one, print item.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
So each item, each element within the list, this item variable iterates over it and goes inside that loop and does the manipulation. In this case, we are just printing the element. This makes it more element. Now it makes more sensible.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. dstream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay. 212 will be an error because the outermost list, there's only one list, right? So that is 0. If I do 212, it will give me an error. List out of index. I don't know how come it's taking this as an outer list. Okay. Yeah. So now we'll go into file handling, and file handling is not, I mean, you don't find file handling, you don't require Python in PySpark, but even then it's just giving you so that you have an idea, right? So we do f equal to open. If you see open, then you have file name, right? And then path, and then mode, buffering, encoding, errors, new line, what is the delimiter for new line, and so on and so forth. There are 100 different options. You can look it up. I'll only show you a couple of stuff: file name and mode. Okay, so I'll use this file name d data final PySpark, because PySpark has its own functions to read any file and write any file. So you don't have to do anything. Okay, so just do read for okay. So this is how you do it. You use the open function. Okay, first thing is you give the file name and the path, the entire full path to the file name. Then you give the mode. Okay, R means read only, W means write only, A means append only, R plus means read and write, W plus means read and write, A plus means read and write. Okay, append will write at the end of the file. Okay, and if you're reading, you have read lines function. Okay, so first you need to assign this particular output of a function to a variable. Okay, so f is the open variable. Okay, that means whatever the function open does, all the values go inside f, right? And then you can use read lines function within that, which will read all the files which are available in the particular file, and I'm printing it out, so it prints it out to your console. Okay, as a list. If you see here, each line, each element in the list is a line in that particular CSV. So CSV, I think it started here. That is one line. Next line is this. Go to the top. Okay, so there are too many lines. So each line is an element in that particular list. Okay, so read lines returns a list. Now if you are going to write it, write lines, and you can give a list, and I'll create a new file. I'll create it here itself. Not a CSV, I will make it as text, and I will give lines to write. Line 1 slash n. So now if you see text.csv, I have written 2 lines, right? So you can use the write lines function to write it, read lines to read it. So if you have w plus print f dot read lines. So in this case, what happens is it doesn't append, it will erase whatever is there in the first line and give it to you. Okay, so it went back to the beginning, is it? So giving empty lines. Write plus should have done it. Why this mode is not working? Okay, the reason is it is pointed at the end. After it writes these lines, the pointer is at the end. Number of lines, I think if I do 1, does it set it to the first one? No. Read lines dot seek offset is 0, and then I do, now it should run that. So if you see, it is reading it. The reason was the pointer was pointing at the end once it was writing. That's why it was coming as none. Okay, so you can put a plus, w plus, and r plus to do read and write both. Okay, so that is all about your read and write functions. So you have to open the file and then assign the value to a variable, and then that variable should call the read lines, seek, write lines function to read and write it. Okay. So if you do R, it is only read-only mode, and within that, if you want to read only first 5 lines, you can give a read and then give the number of lines that you want to read. So it will start from the beginning and end it. If you want to do it from a different point, you can use f.seek and give the line number, and from there you can do f.read. From there on, it will read it. Okay. So read line also it's similar to read. It will keep on reading line by line. But if you want to read the entire text file and put it in a list, you can do read lines. For writing, we have f dot write and write lines, same like I showed you earlier, right? And if you want to create a file, you can give the mode X. Okay, so X is for creating a file. If the file doesn't exist, it will create. If it already exists, then you'll get an error. Okay. For append, write, and read, if the file doesn't exist, it will create the file and do it. And then you can use OS library to remove a file. We have a function called as remove within OS library. So we can do os.remove and it will remove that particular file. Okay. Dot remove. Is being used by another process. Which process? Test.txt, is it being used anywhere? Or I don't have permission either one of them, but it's here only. Maybe if I had done a copy and move. Okay, I think it's not able to access it. So somewhere some other process is being working on that, but has opened that particular file, so it's not able to remove. Otherwise, it will remove it. So within string, we can use slicing. I told you we can use this notation to create substring out of it. So this notation is what we call as string slicing. Okay. So here, last time I showed you only positive numbers. Here you can also use negative numbers as well. So what do they mean? -1 would mean from the end. Okay. 0 positive numbers would be going from this side. Negative numbers would be going from this side. Okay. So you are saying from third element, that is here, till -1, which is not inclusive. So it will be till the end. So it will be hello world, hello world. Okay. So if you do -2, it will be till L. Okay. L to L, LLO world. Okay. So on and so forth. So you can also give both sides also negative. You can give, so -5 is -1, -2, -3, -4, -5. Oh, so that is your string slicing. This is one of the other function called as lower. It will convert all the characters case from, it can be upper or lower, to lower. Okay, so it can be either, it will convert it into lower. So if you see here, hello Intellipaat, here it became, all of them became lower. Same thing we have upper, that will convert all the character case to uppercase. Then I showed you replace function. It will replace a particular character with a new character, right? A sample, and that's why there's no replacement. A with H. It replaced it with H, this and here. Okay, that was string replace. Then I've showed you string concatenation. You just have to use the plus operator and you can concatenate two strings and create a new string out of that. And then we have tuples. So we'll start with tuples now. Collections are the last part. Okay, so tuple is a collection which is ordered and unchangeable, that is, it is immutable. It allows duplicate members. Okay, so tuples, whatever elements you add it in order, so it will always retain the order. Okay, list is also retaining the order, but it is mutable, so it can be changed. It allows duplicate members. Okay, dictionary is a collection which is unordered. Okay, the key value pair can go in any order, it will be displayed in any order. Okay, but it is changeable. Okay, the values can be changed, it is mutable and indexed, but does not allow duplicate members. So you cannot have duplicate keys, you can have duplicate values. Okay, duplicate keys are not allowed. Then set, it is unordered and unindexed, it does not allow duplicate members as well. Okay, so as I said, this is how you define a tuple using curve brackets, right? And then you can use the index number to access each element of a tuple, or you can use a for loop like this, for element this tuple. So in this case you don't have to give index number and all, you can just print the element. Okay, all of them, set, list, dictionary, everything you can use for loop and iterate over that particular. These are also called as iterators. Okay, meaning you have to iterate over this particular iterator, then only you will be able to get the values out of it. Okay, so they are called as iterators. So tuple, list, dictionary, sets, they're all collections and they're also called as iterators. Okay, then there are a couple of things you can use within your tuples. For example, you can use membership operator to check if a particular element exists in that particular tuple or not, right? So here we are checking if apple is an element that exists in tuple or not, which is correct, it's already there. So this particular if loop will be true and it will go inside that particular if loop and do further manipulations. Okay, yes, apple is in fruits tuple. So for tuple, we don't have those many functions because it's not mutable. But for list, we have a couple of functions. Again, how do we define it? We use square brackets. Okay, and you can create an empty list, and then out of that you can use append function. And to access it, you can use index numbers or you can use the for loop. Okay, again, you can also change elements using the indexes. For example, it was Java. I changed it to Scala by using the index number. Now finally, if you see, the final list has Scala instead of Java. Okay, so you can manipulate it like that as well. And you can use the membership operator again to check if a particular element is part of a list or not. If it is, then you can do any further manipulation. You can use for loop, and within that you can use membership operator so that it will iterate over each of the element, and for that particular element you can do any manipulations. Okay, for example, I added an add string. So for Java or Scala, everything I'm adding the add string. Okay, You can use, as I said, membership operator to check if an item exists or not. Then you can use length function to get the total count of the elements, right? Number of elements in a list. Then you can use append, that will append whatever element that you're passing to the last end of the list. Okay, but you don't want to do it, you don't want to append it, rather you want insert it in a particular position. We can do list dot insert and then give the index number. I will give 0 and then I will give language go lang. Now I will print it. So now if you see, I have added it to the 0th, the first element. Okay, if you want to. Okay, but if you don't want, you want to append it, if you want to add it at the end, you can use append function that way. Okay, okay, so I've already shown here. Then to remove an element, we can use remove. So it will remove the first occurrence of that particular element, right? You can also use pop, but instead of the element value, you have to give the index number. Okay, dot pop 0 1 2 3, right? So it removed the second element, which was Java, right? Identity operator is comparing the value, whereas is instance is comparing the type. Okay, so that is the difference between is and is type, is instance, sorry. Okay, so now let me come back to a list. So we saw how we can remove. We can use remove as well as pop. Okay, popping also I've shown. Only difference is pop will take the index number, remove will take the value or element value itself. Okay, then we have copy function that will copy all the elements of a list and put it in a new list. Okay, or we can do directly like this as well. The list name itself, we can map it to a new list. All of them, both of them will do the same thing. If you see, both of them are doing the same thing. Oh, sorry. One is what we call as shadow copy. Okay, so this copy, what it does is it is creating a new copy in the my list itself. Okay, whereas this my list and this my list one and this list, they both are this they both are pointing to the same set of values. Okay, so basically what happens in Python is we have an object name and object value. So what we call a variable, it is nothing but an object name. Okay, what the value it contains is an object value, right? So object value will be basically in some memory location in within the heap. Okay, and object name will be linked to that particular object value. So in this shadow copy, what is it is doing is it is creating a completely different object value in a different location in heap and assigning it to my list name. Okay, whereas when you use equal to operator, this list and my list one will be pointing to the same object value, that is this. So any changes to this particular list, when I did my list one dot append, even the value for this list changed. So if you see here my list one and this list, they both have A, whereas my list doesn't have, because it has a separate copy itself, whereas they had the same copy. They're pointing to the same object value. Okay, so there's one difference that you need to know. I forgot about this. You can also use list. This is basically not a shadow copy, just like how we did. This is basically a shadow copy, like how we did my list. Okay, so either you can do it this way, or you can call the list function itself. So you call the list function, within that you pass the list, and both lists will have the same values. So it's a separate copy. My list will have a separate copy. Okay, now let's go into dictionary, how to create a dictionary. As I said, it's a key value pair. So key values are defined like this. You have a key, then we have a colon, then we have the value, then we have the next key and value, right? For that, you have to separate it using comma. Okay, so this is the standard structure of a dictionary. Okay, then when you print a dictionary, you'll see it. Okay, and then let's say you want to add new key value pair to an existing dictionary. Then inside the square bracket, you have to give the dictionary name, and in list and all, you are giving the index number, right? Instead of that, you have to give the key name. So here I'm giving new key because I'm going to create a new key, right? So new key and the value for new key. Now when I print the dictionary, you will have the new key value pair there. Okay, so let's say you want to print a particular key value pair. You just have to give the name of the key, this dictionary, and name of the key is brand. So it will print the value for brand. Brand is value for brand is Ford. See here. value is 4. Okay. Suppose if you want to modify an existing key, here year was 1964. Again, you can use the same notation, dictionary name, square brackets, name of the key. It can be either new or old. If it is old, it will update. If it is new, then it will insert. Okay. So since this is an already existing key, it will do an update. So instead of 1964, it will become 2020. How do you use for loop? So either you can use k, you can use an iterable variable over the dictionary itself. Okay. So in that case, we have to use this dictionary, and k will be the key. Okay, so the iterable variable will be the key. Okay, so for that key, the value will be, for example, the first key is brand, so the value is Ford, and then the key is brand here. So sorry. Then for key model, that is the key value of k is model. So for that model, the value is Mustang, right? Then for year, when k becomes year, the value of this dictionary year is 2020. Okay, so that's how it iterates over it. You can also iterate over using the dictionary dot keys function. It's the same thing. K will have the value of keys, but if you want only values, then you can do dot values. Okay, so this will iterate only over a values. Okay, so here you just have to print k. There is no key. Okay, so forget this, I just wanted to show. So k will be the value itself. Okay, there is no key there because you're using values functions which is available within the dictionary. So these are the couple of ways that you can access it within a for loop. It's up to you. So again, you can use the membership operator to check if a particular key exists. Okay, to check if a particular value exists, as I told you, you can use if value is 4 in this dictionary dot values. Okay, print yes, value exists. Sorry, it is case sensitive. Okay, value exists. Okay, again, to print the dictionary length, meaning the number of key value pairs that exist, you can use the length function. Then again, adding items, as I said, you can add new key value pairs by giving the key name in this notation. If the particular key exists within the dictionary, it will append or update it, or else it will insert the new key value pair. To remove, we can use the pop function and give the key. It will remove the key value pair altogether. If you see, model is removed. So this is a complex data type that I was explaining in the last session. So you may see a dictionary is like this, and then within the dictionary, that dictionary is put in a list, right? So that is the complex structure that you will see. So it becomes like a table structure, wherein which the list is the table and each dictionary is the row, right? And within that, the key is the column name and the value is the column value, right? So that kind of complex structure you can see. So in that case, how do we access each element? So what do you do first time? The first for loop will iterate over each list element, meaning each row. Okay, first time item will be this row, next time item will be this row, next time item will be this row, so on and so forth, right? And then you want, from there you want to, let's say, print item name, right? So just give the key name to print it. Or if you want to print all the key value pairs, you can do print. You can put another for loop for inner item in item, because item is a dictionary now, right? Within list of dictionary, item is the dictionary. So within that dictionary, each element you are accessing by keys, right? So here inner item is the key of the dictionary. So I'll print key is inner item, and then value is inner item, sorry, sorry, item and inner item. To make it less confusing, let's call this as dictionaries. Okay, so now where is it? Oh, sorry, why is it invalid syntax? So keys name, values Praveen, and so on and so forth. You can print it. So this is how you do list of dictionaries. We can have nested dictionary. This is what I was talking about. Just like list of dictionary, we can have dictionary of dictionary. Okay. So we have a key, but the value itself is a dictionary, right? So how do we do it? How do we use for loop? First item will be the keys of the outer dictionary, right? And then next within that, the inner loop, the key will be the inner dictionary, the actual dictionary's key, name and year, right? And then we print the outer loop key and then the inner loop key. So that way you will be able to see all the values. Okay. Hope this was clear. So let me just quickly complete sets. So as I said, this is how you create a set. You give flower braces. Don't get confused with dictionary. Dictionary also starts with flower braces, but it is a key value pair. But here it's not a key value pair. It's just a value or element, we can say, right? And let's say we can use set. Where is set used mostly? When you want to convert a list having duplicates, right? So your goal may be to remove duplicates from a list and create a new list out of it, that, right? So in that case, you take the list, put it inside a set, and then convert it back into a list and assign it to a list variable. So now list 2 will have only the original elements, no duplicates, because when the original list got converted into a set, it removed the duplicate apple and only kept one apple, right? And then that set is again converted into a list and assigned to the object name list2, right? So that is the main use case for set I've seen. Okay, because set also uses in other functions like intersect, which I'll show you difference, right? So those are also used, that doesn't exist in set. So that is also a use case. People will convert list into set and then use those set functions, right? Let me go through how to access a set. You do not have indexes. That's one more thing. It's not indexed, nor does it have a key value pair. You just have to print it out like this. However, you can use the membership operator to check if a particular member is part of a set or not. Okay. If you want to add items, since this is mutable, you can use the add function. It will keep on adding it in an unordered fashion. Okay. There is no order to it. It may add at the beginning, it may add at the end, anywhere it can add. Okay. To get the length of a set, you can use the length function. And then to remove any element, you can give the remove function and give the element name. It will remove that element from that particular set. Now, why the main reason why set is used? As I said, from list it is converted into set because set gives you certain functions like difference, union, intersect, right? So let me print all of them. Print set1, union, set2. This is basically the sets concept that you have learned in your mathematics, right? Same intersect. So what is difference? A minus B, right? So whatever is there in A, removing the common element that is available in B, right? So 3 is the common element that is available in B. So you remove that and return the rest of the elements. That's why you see one. That is difference. Union, combine all the elements in both the sets, right, and create a new set out of it. Right. Intersection, get only the common elements between two sets. Right. So these are the couple of functions. So Python functions, right? Let's look into what functions are. Basically piece of code that you can reuse it every time. Okay. Let's say you want to do some, people have this knowledge. I'm going at a very low level so that everyone understands. So basically functions are a piece of code where a set of lines, okay, that is regularly used. For example, you have a calculator function, right? So what does it do? You provide inputs like two numbers and then the operation you want to add, you want to subtract, or you want to multiply, and so on and so forth. And that is used regularly by everyone, right? So it is always important that we don't have to write code every time someone is doing the same thing. For that, we use functions. Functions can be of two types. One is user defined, that is the developer writes it, and other is built in, that is something that is already there in Python. That is when you install Python, it already came with it, some set of functions. So function is a block of organized reusable set of instructions that is used to perform some related action. That's what. If you have anything that a part of logic that is constantly being used, then the best approach is to put it in a function so that you don't have to write the code again and again. For those of you who joined new, collab.research.google.com is cloud lab provided free of cost by Google, right? So in that you can upload Jupyter notebooks and you can work with your hands-on. So we will create a virtual machine, maybe 3 virtual machines, and we'll create a cluster of 3 machines where we'll install Hadoop and PySpark, and we'll do all Kafka. We'll also install Kafka Hive and Flume so that we can practice that, because module 6 and module 7 is Kafka, Flume, and PySpark streaming. So that cannot be performed using Google Colab. So till then, we'll be using Colab as our hands-on IDE or something like that. So you guys also can use Colab. You just have to go to colab.research.google.com and use your Gmail ID to log in. Once you go to that, you'll be able to log in and you'll reach this UI, right, wherein which you can upload your notebooks, right? So in your LMS, if you have access to LMS, you will see that you have Jupyter notebook, all modules, 2, 3, 4, 5 modules. For all the 5 modules, you would have seen a IPYNB file, right? So it will be like this. So you'll have a IPYNB file like this. Click on that and open, and it will open the notebook. So that's very simple. So coming back, let me show a sample example. So how do we create a function? We use the def keyword. Def is the keyword used to create the function, then the function name. There's something called as pep8. So that is a coding standard in Python, right? So there are some of the rules that you have to follow. Even though it doesn't produce any error while coding, it is not advisable. So one of them is function name should always start with a capital letter, right? Or camel case letter. So you can have something like this, small example, something like that. Okay. And there are other rules like each line should not have more than 120 characters. If so, then you have to give, you have to make sure that it's a multi-line instruction. Okay. For example, if you have a string 1 equal to something like that, right? So if there's more than 120 characters, yeah, sorry, you have to give an escape character like this and then continue. Okay. So it will take it as a one single string. Okay. And again, in Python, we use indentation. We don't use flower braces. At the 0 level, there's no indentation. But once you get into a block, the block itself is at 0 level, then 2 spaces. Within that block, again, you create another block, then 4 spaces, and so on and so forth. It keeps on increasing. For example, if I use a for loop for I in range start end, okay. And so here it is 4 blocks or 4 spaces, right? Or 2 tabs. One tab is 2 space. So that is how it goes in Python. We don't use flower braces. So let's say these are function, right? And what we are doing is we are just printing all the numbers between given 2 numbers passed by the user. Okay. So that is the function that we have created. So every time user wants to call that function, he has to give 2 arguments. One is start and the other is end. Okay. Let's say he wants to couple of stuff. So I'll give 2 and 50, 2 and 5. Now when I run it, to connect. Okay. Then
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
okay. So let's say this was my requirement. If you see here, my goal was to print given numbers. I mean all the numbers between start and end. So every time I don't need to write this code. Rather, I put it inside a function and call the function multiple times with different inputs. So that is the main functionality. I mean, that is the main concept behind functions, right? And there's nothing much complex here. You would have already seen it. Only thing is you would have been using flower braces and you would have been giving type for arguments, right? Like, so this is what we call as arguments. So, or parameters. For each of the parameter, you may give it's an integer or a float or something like that. But in Python, we don't do that. Python is not a type defined language. It's automatically understands that b is an integer or a float or something like that during the runtime. So in Python, again, in like just like in other programming languages, functions can be of two types. One is call by reference, the other is call by value. So what happens in call by value is the value of the passed argument gets copied to another variable. In this case, it gets copied to b, right? And then whatever manipulation happens on b itself. A, on the other hand, remains unchanged. Okay. So if you see here, the value of a at the initially it was 10, and even after the function has been called, it is 10. Whereas a, the value 10 got copied to b, and then b, the value of b got changed to 100, and now it is 100, right? So if you see, new value of b is 100. So this is called by value. So value gets passed in, the variables are not. Okay. Whereas in call by reference, both the parameter or the function arguments as well as the variable passed, they both point to the same location. So in that case, they both are pointing to this list, right? So any manipulation or any changes in the list will ultimately affect the past variable as well. Let's say we made changes to d, right? So we made the first element as 99 and second element as 98. So at this point, even C has changed because they both are pointing to the same location. They're just references, they're not new variables. Whereas in this case, they are new variables and each of them hold different value at some point in time. Here the value gets copied, so initially they have the same value, but later in time B, the value of B changes. So that is called by value, and here it is called by reference. One thing that you need to understand is there is no explicit mentioning of call by value or call by reference. In other programming languages, you have to make the function arguments as a pointer or something. So pointer concept doesn't exist. For it to be a call by reference, you have to make it a pointer. That doesn't exist in Python. Rather, all immutable objects are, let's say for example, int, float, numeric, they're all in float, long type, they're all mutable data types, right? So they all have to, if you're using such an argument in your function, then they are by default called by value. Okay. Immutable types like list, dictionary, and sets, they are all immutable, like we discussed last time. So if such kind of objects are being passed to the function, then it is a call by reference function by default. There is no explicit mentioning of call by reference or call by value, but we have to understand that if a particular variable is immutable, then that variable is being passed to the function, then that function is called by reference. If it's a mutable one, then it is called by value. So next comes local variable. Okay, so we have to understand that each variable has its own scope, right? So this block, whatever variable that you define inside this block, once this block ends, that variable is automatically pushed to garbage collection. So you won't have that particular variable, right? Whereas any variable you declare global, right? You can use it in your entire script anywhere you want. Okay. In this example, this f is a local variable and it is local to this block. Okay. This f, even though looks like, I mean, it is a global variable, but if you use it like this, then this f is a local variable which will override the global variable, right? In case if you want to use global variable inside this function, you can use it like this. Okay. And so you're using a global variable that was defined here outside the block, right? But let's say, no, I don't want to use the global variable. I want to use the local variable itself. So you created the local variable with the same name. So what happens is, as long as the interpreter is within this block, the f will have the value Intellipaat. As soon as interpreter moves out of it, the value of f will be what is defined at the global level, that is 100. So now if you see, the value outside the function is 100. When the function is called, it goes inside and the value is now Intellipaat, right? So again, when it comes out of the function, again it is 100 because it is pointing to the global variable, whereas here it is pointing to the local variable. So this is the concept behind global and local variable. So there is no access specifier as such. You will see that in other programming languages you have something called as public, private, and all those stuff. As I said, when they brought in OOPS concept, they try to bring in, but it is not explicitly mentioned anywhere, and the concept is not used everywhere else. Okay. So in case you are not within an, let's say you are having another block of code, and in that you are not using any local variable with the same name, you don't have to use the global keyword. Here I had used global F, right? You don't have to use it in case you are not using any manipulations to, or you're not creating any local variable, then you can directly use the variable without the global keyword. Okay, so in this case, it is global throughout. Okay, within this block also it is pointing to the global variable. This X variable scope exists throughout the script, entire script. This variable F, the scope of this variable F is the entire script, whereas this F is only limited to this block of code. So that is basically the difference between local and global variables. So now coming back, we, as I showed you how to create functions, you have to use the def keyword, and then you have to give a function name, and then the number of arguments that you want to pass, right? And then you can use any logic, and if you want to return something, you can return, or else without that also you can have a function without any return statement. When you return something, then that value has to be passed to a different outside variable. For example, let's say you are using a variable called as x equal to none, then I'm doing, let's say make it 0. Let's say I'm doing sum of variables between start and end. So that is my goal, right? Then I do return x. First equal to uh, equal to third equal to, right? So you can return, you can use a return statement that will return some value which has to be stored outside in another value. So I'm using these three variables, and I have got the output 45, 9, and 33. So for each function call, I've got three different outputs. Okay. So that, in case that is your requirement, then you can use it. Then we have built-in functions. These are the some of the examples of built-in functions. For example, you want to find an absolute value, and then you can use ABS. Then you want to return all true items from a list or a dictionary or any tuple or any iterable, right? So I told you what an iterable is. An iterable object is nothing but data structure which has multiple elements, like a list or a tuple or a dictionary or a set. So you have to iterate over each element, and then only you'll be able to access it. So such objects are called as iterable objects, and all is a function that will return all true values, right? Then any is a function that will return true item from an iterable object if any item is true, right? ASCII will convert your current character set into ASCII variables. Then binary, if you want, you can use bin. Then boolean value, if you want, you can use bool. And there are many other functions we'll see as we move on, right? I think at the end you'll see some of the standard libraries that we use, and what are the functions within that. So within the functions, we have two types. One is call by value and one is call by reference. Always, if you're passing, if the function arguments are mutable, then it is called by value. If it is immutable, it is called by reference. That's all you need to remember. Right? Variables in Python, as I said, it can be two types: local and global. Local variable has a scope within a particular block. Outside that block, that variable gets garbage collected. Global variable, on the other hand, can be accessed throughout the script. As I said, problem with functional programming was OOPS concept. As soon as Java and other OOP-based languages became famous, the Python visibility went down and the market for Python went down. So the creators and the Python community decided that they will add some of the OOPS concept, object-oriented concepts, right? So what is object-oriented concept? What is functional concepts? Functional based programming languages, right? Functional based programming languages, your entire script is in functions itself, right? For example, I have a script like this, right? I only have functions in it and I'm calling all of those functions one by one and so on and so forth, right? So this is an example of functional programming. Whereas OOPS concept comes in when you want to, realize a particular goal using objects and classes and all the other concept that comes with it, inheritance, abstraction, and all those stuff, right? So in Python, both these styles are available, right? You can either use functional programming or you can use object-oriented programming. Again, reiterating it, that is up to the client or up to you guys which one you find it easier or which one you think is better. Okay, but let me tell you what you see here in Python, the object oriented programming in Python that came up last minute. So there are a lot of concepts that are not similar to what you have learned. Let's say if you are from a Java background or you're from a Scala background or something like that, there are a lot of things that you will see is not.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
Available here. For example, access specifiers, right? That is the main thing. Object-oriented security is being brought in Java using access specifier. You can declare a class public, you can make a class private, you can make a function private, you can make a function public. All those things doesn't exist, but some conceptual they try to address that as well, but in a different way. Okay, but you need to remember that these access specifiers don't exist in Python. So that's one of the main thing that is missing in oops in Python. Okay, but for where do they use it? As I said, it depends on your client and your architecture, right? For example, you may see generally when you are let me see, right, RDD example, you may however see a hybrid way of doing it. So let's say this was one of the project, right? So I was working in one of these projects. So here what was happening was the actual code model and everything, they're all class based. I mean, oops concept, right? But whereas the main module that runs the entire PySpark job is a just a function. Okay, there are no classes or any oops concept followed here. Whereas the business logic has the oops concept within it, my environment module, and the model means your business logic. So wherever it is implemented, though there and all they have used classes, whereas the main run script they have not done it, it's a functional programming, right? So it can be a mix, right? Either you can use, it's not like if you're using functional base, if you're using functional programming you cannot use oops concept, if you're using oops concept you cannot use functional, nothing like that. Both are you can mix and match, right? And other thing is the main important thing that comes with Python is loosely coupled modules. You can build loosely coupled modules such that even if you remove one of the modules or if you plug in new module, it won't take much time for you to deliver your product, right? So that is one other thing. Functional programming and oops concepts are style of programming, whereas modular programming is the design part, right? How you design your code. You have to design your code in such a way that you have to break the big script into different reusable modules so that one thing, downstream application or some other guy who's going to build a new application but has similar functions can reuse your modules. Second thing is anytime you want to remove a module, you can remove it. Anytime you want to insert a new module, you can insert it. It is flexible. At the same time, unit testing you can do at each module level so that any bugs you don't have to search for the entire code, entire project. That is the programming approach or programming design, right? Whereas styles can be functional or it can be mixed. So I'm not going to bore you with the basic stuff of what is oops is. I'll tell you quickly what is basic principle. What is a class? Basically, it is like a blueprint, right? So for building a house, you first have to create a blueprint, which you will tell, okay, here there's going to be a window, here there's going to be a bathroom, here's going to be a bedroom, something like that. Same thing with class. So class doesn't occupy memory in the backend, okay? But within class, you define the functions which the object of the class will use, okay? So in order for the class functions to be used or the class variables, okay, you can define variables and functions within the class, right? So these variables and functions have to be used. For that, you have to create an object of a class. So this is the physical materialization of the class. Once you create an object of a class, then in the backend on the heap, the entire memory or is reserved for that particular object, and then you can do all the manipulations and stuff. And then we have a concept called as inheritance. That is, trying to inherit a particular class's function or variables to another new class, right? So that is what inheritance is. Literal term, you are inheriting your wealth from your parents or from your grandparents, so on and so forth, right? So here you are inheriting the class variables and class functions to another class. Whereas encapsulation is, putting a code inside functions or classes which is not visible to the outside world. So the guy only knows that when you call small example, you're getting a sum of all numbers that are between start and end, right? So that is encapsulation. He doesn't know the actual implementation in the backend. Polymorphism again is a concept where in which you can use the same function to do behave different. Okay, you can have a function. It can take in 2 arguments, or it can take in 3 arguments, or it can take in n arguments. So you can have such kind of dynamic functions. So you may not know the number of arguments that are coming in, right? So you can do that, and that is called as polymorphism. So together, all this constitute what we call as OOPS. So if these concepts are available, then it is called as OOPS program. Okay, let me show an example. So let me create a class. Okay, so in Python we use the class keyword and then say student. Okay, if you are inheriting from a different class, you can put it inside braces. Let me copy some function. There is no function here. Let me def init. I need to show what init is, right? Name, none, roll number, none, input, name, input, roll number. So start name equal to start roll number equal to, then I will do def print details. Current name is name, print student, roll number is format, syntax roll number. Okay, so now I create object of student class. Student1 equal to student. I'm not inheriting anything. Student2, student. How to use manual? So let me start in the beginning. So this is how you define a class. So this is your class, this is your blueprint. Okay, within this class you mention the class variables. Here I'm taking name and roll number, and then I have a function called as print details, which will print the name and roll number. Okay, then I have a special function within a class that is called as init. Okay, so this is what we call as constructor. Constructor is nothing but a function that is called implicitly when an object is created, right? So when you see a student1 object was created, I passed in certain variables, name and roll number, right? So this point, the init function automatically gets invoked or called, right? So that is what we call as a constructor. So when the constructor is invoked, I'm passing the parameter Praveen to the variable input name, argument input name 1234 to the argument input roll number, and those values are then copied to the class variables name and roll number. Here self object is nothing but the instance itself, so it is equivalent to student1.name, student1.name. Okay, and next time it will be student2.name, and so on and so forth. I can have 100 different objects for each object, when it comes here, that object dot name is being called. So that is why we use the self operator. So self operator is nothing but the calling object. That is, in this case, it is student1. Next time it will be student2, right? So it will be mapped to that particular variable, right? The input name will go to the name variable, class variable. Roll number will go to the roll number variable. Then I'm using the print details function, right? Which will do nothing but print the name and roll number that I have just assigned using the constructor. So this is a simple class example. Okay, hope this is clear. So now we'll go to what we call as inheritance, right? So why we need to use inheritance? So let's say we may have a class that is doing something and has some list of functions or list of class variables, right? And later on tomorrow you did some enhancement, you created a new class, but you know that we are going to use the same functions that we have already previously used in the old class, right? So what we will do, rather than writing that part of the code again in the new class, we will just inherit the old class. That way we will be able to access all the old class functions along with the new class function. So let's say an old class called as A, and it had a function called as swim, right? And it was doing some manipulation. Later on some enhancement came in, and I had to create class B, and this class B had to again, you had to use the swim function, right? I will inherit the class A, right? So what happens, this swim function automatically gets copied in the backend to the class B. Okay, so when I create the object of B, I can call the functions that are there within the class B as well as class A. Okay, so if you see, I'm running, I'm swimming. So this is inheritance. Why it is required? As I told you, reusability. Suppose you have an old code and the new code also has some functions similar to the old code, then you just have to inherit that particular class. All of them get copied here. So one thing, this is where the difference comes in. Earlier in Java and all, you would see some public class A, private class B, and public function A, function B, something like that, right? Here that concept doesn't exist. Everything is public. You just inherit all the functions. Okay, there is no restriction. So in that inheritance, there is some inheritance type, like if it is a private inheritance, only private functions are copied, or in a public function, if it's a public inheritance, then public functions or something there like that is there. That doesn't exist in Python. Okay, when you inherit from a parent class, all the functions, all the class variables get copied, okay, in the backend. So now again, don't get confused. In the next few slides you will see something called as a private function within Python, but that is, as I said, there is an attempt to bring in the concept of private type access specifier and public type access specifier. Okay, but that doesn't work on inheritance. Inheritance will also inherit all those kinds of functions as well when you inherit it. Okay, only thing is, to access that function, the notation is different. We will, okay, I know I've already talked about it, so let me show you the example. Yeah, so this is private method. Any private method that starts with double underscore is called, any function, normal function that starts with double underscore is considered as a private function. Okay, and you cannot directly call it using the dot operator like we used to do with public functions, right? We have to use the object of the class, then you have to use underscore, then the name of the class, then name of the function. Use of private function, I mean, see, that's what in other OOPS languages it was to, restrict other classes or on other base classes from inheriting them, or being easily accessible outside of the class, right? So in Java and all, you cannot do like this. You cannot call the private functions at all, but here you can call it the way, I mean, the reason, again, the notation, they have made it different because so that at least they know that you're not supposed to call it. That is what I can tell you, because even I don't know these things. They came up at the end, the reason was not brought in and it didn't even make sense. So most of them don't know what was the reason behind it. Okay, but the thing is, all I can tell you is the notation to call particular private function is different. But as I said, in inheritance, even this will be copied to the base class, so the purpose of it is totally not known. Okay, maybe making it difficult to access, that may be a reason, because we cannot directly use the dot operator and access it. you have to give this notation. Maybe that may be a reason. But actually the concept behind private methods is security. You don't want all the functions to be readily or easily accessible everywhere else, right? So that is the logic behind it, but in Python that logic doesn't apply. You can access it even if it is a private function. Let's go to polymorphism now. Polymorphism, we have two types. One is called as overloading and the other is called as overriding. Okay. Overloading is calling the same functions with different number of arguments. Okay. So if you see here, I'm using 4 arguments here. I'm calling this add function using 4 arguments. And here I'm calling using 3 arguments. How is this possible? Because args is a list. Okay. When you see single pointer kind of thing, this is not a pointer. It's called as a special keywords arg and quarks. Okay. So there's something called as quarks. So this is keyword argument. This is just list of arguments. Okay. So keyword argument is basically a list dictionary kind of stuff. Here it is a list kind of stuff. These are special arguments. Okay. So when I do 3, 4, 5, it all goes into this argument list. Okay. So now I have taken integer. So this will be copied to instance of, right? And 3, 4, 5 will become elements of args. And then I'm just returning the result if it is string.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. dstream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
If it is an integer, it will give you the sum. If it is a string, it will give you a concatenated string. So I have to print it. Okay. So if you see 3, 4, 5, sum as 12. If it is a string, it is hello. And I'll also print. Why is the format so wrong? It should have been here. How come? Print. It isn't the string. Okay. This was clear. Overloading is I'm calling the same function initially with 4 arguments, then I'm calling with 3 arguments, right? So the number of arguments can be n. So that is what we call as overloading. Same function is called in a different way, right? Then we have overriding. So what happens is the parent class may have a particular function. We inherited that parent class, and in the child class, we are trying to change the behavior of whatever the function already existed in the parent class, right? So that is called as overriding. We are overriding the parent class function. So now if you see here, earlier the function was printing I am in A, right? Now it will print I am in B because we overrode that particular parent class function. Okay. So now that is what we call overriding. So let's go back and see what overloading is. Calling the same function in different ways is called as overloading. Changing the behavior of a function is called as overriding. Okay. As I told you, the concept of private method is not purely what you see in other programming languages. The concept behind private method was to limit the access of external users or client from accessing the secured part of code, right? So that's why they would create such methods as private. They would declare it as private, and it would not get inherited. It would not be called outside that particular class itself. Okay, the instance of the class has no access to that particular function. Only the class members have it. I mean, class functions have it. But in Python, that is not the case. I mean, they created it just for an understanding, okay, so that people who see any functions with underscore, double underscore, they shouldn't use it outside it. Okay, maybe that may be the reason, but that doesn't mean it cannot be accessed. You can use instance of the class, then dot operator, then underscore, then name of the class, then the name of the function. Okay. So next is called as a lambda function. So lambda function is a single line expression a function that is written in a single line expression. Okay, so you don't need a def keyword, you don't need a return keyword, but the entire logic is one single line. Here if you see, this is an example of a lambda function. So if you see here, this function has only one line expression. The entire logic is written in one single line, right? So such kind of functions are called as lambda functions, and we need lambda functions. We'll see in PySpark there is a need for it, especially when we are using map functions or reduce functions or group by functions. You will see, because those functions need an internal function to be called. Okay, so at that point of time, those internal function or inner functions may be a simple logic, right? So for that, every time you don't have to go around and write def and they define the function and do it. Simple waste of time, right? This reduces the number of lines. Instead of 3 lines, you can do it in a single line, right? If you implement the same thing in a normal function, right? Def func, let me see, argument 1, and then a equal to a plus equal to 10, return a, right? So now if you see here, 3 lines, whereas one single line. Okay, so the output is the same, the behavior is the same. Only thing is the number of lines is reduced, right? Almost 1/3. Imagine there were 100 different functions, single line expressions. In your PySpark code, you may see it. You may use 100 map functions, right? So in that case, the inner function is single line function, but you have defined it without using lambda, then you are creating 300 lines, 200 lines extra. You could have done it in a single line itself, right? So that is where lambda plays an important and very crucial for PySpark. So here A is the argument, function argument, okay? And this is the return statement itself. So you have to first register this lambda function to a variable, or I mean, it's like unless you register it, you cannot use it. So I have registered to a variable called as x. Then I'm using the x variable and passing on the arguments. So here the value of A is 5, and whatever the return statement is 5 plus 10, which is 15. So that is what it is being returned here, right? So same thing is going on here as well, but it is 3 lines, 3-line code compared to 1-line code. So always remember, you create a lambda function, you have to register it to a variable. If you don't do that, your lambda function will not work. In PySpark, it is however different, but for now in Python, this is how it works. You have to register to a variable, then only you can use the lambda function, or else you cannot call the lambda function itself. So any number within this range, right, 0 to a, whatever number falls in, if it is divisible by 2, that is what divisible by 2 makes it even, right? All even numbers will go inside the list. That also you can use. Okay, so 0 to 5, right? So within that, 0, 2 and 4 are divisible by 2, so that goes inside the list. So you can use multiple you can use list comprehension that may look like multiple looping constructs being used there. So if this function has to be implemented, this will look something like this: x equal to list for item in range R1 if item divisible by 2, then only x dot append item. Okay, and then return x. What happened? Item. Sorry, my bad. Yeah, so if you see, the output is the same, but the number of lines, how many? Yeah, so we have moved from a 3-line, 1, 2, 3, 4, 5 lines, right? So all that got reduced into a single line. So this is the biggest advantage of lambda function. Okay, hope this was clear. So they are anonymous functions created using the lambda keyword, and they can have any number of arguments. There is no hard and fast rule that a lambda function should have a single argument. In this case, it can have a, b, c, d, e, f. Okay, a, b, c. I can make a to b, right? Same thing. and here I need to give 5 and 20. Okay, so I can have a number of arguments. Only thing is it's not inside a bracket. It is like same just like how we write an argument, only without the brackets. Okay, a lambda function in Python can be used wherever a function object is required, right? As long as you can define the entire logic within a single line, right? Lambda function do not require any return statement. They always return value obtained by evaluating the lambda expression. Whatever is being evaluated in this single line expression, that itself is your return statement. You don't have to explicitly mention return. Python lambda functions are widely used in some Python built-in functions of map and reduce. You'll also see this in PySpark. Okay, so that is why you need to understand what lambda functions are. If you don't understand here, then you'll get confused there. Hope everything is clear till now. So I told you that there is a design approach in a range must have two arguments, start and end. Well, if you give only single argument, start will be 0. Okay, default it will take 0. So if you want to see the range, right? So anytime you have any doubt, right, one good thing is you just have to hover over it. So if you have a question on range, so if you see here stop, okay, by default starts default to 0. Okay, function definition is always given. Any function you have any question, just hover over it. Basically it should give, okay, yeah, here let's say, yeah, time function, right? I will do it. Let's see if this comes. Let us see. What is the problem now saying? Is it primary value to unpack expected 2? I gave only 2. It's always key value paired. Okay, the input have to be key value paired. Items. Sorry, my bad. That's the other now. Built-in function is not iterable. This I forgot to mention. Okay, so this is how you give it. It is basically kind of a dictionary. Okay, not exactly a dictionary, but kind of. Is this clear? Move on to what modular approach is, right? If a particular, okay, if you're coming from different programming languages, you'll have something called as library, right? Somebody or some organization would have created a project which is doing some manipulation. Let's say you have a module called as time, which has functions that will give you EST time, IST time. Everything is already done by some third party or some organization. So they will wrap it up and publish it in the Java market, right? Some marketplace exists where that library is dumped, and from there on you download it and you import it in your code and you import their functions and everything, right? Same logic exists in Python as well. Okay, so we call them as modules, or you can also call it as library. So it can be third party library developed by someone else or some organization, or you yourself have created a library and your team or downstream applications are using it. So anything like that you can do. The purpose behind it, as I said, you do not want to write a very big script trying to do something. Rather, you want to break it into modules so that certain modules can be used by others, right? At the same time, for you, debugging it will become easier. You can individually test each and every module within your project, right? So that is basically the reason behind the modular approach. And within that, the concept of modules and libraries also come into play. You can also publish your modules to third-party marketplace where others can download it and do some manipulation. Right? For example, if you see here, so if you see here, they have broken down their entire project into different modules. So if they want to, insert use SNS functionality, they'll go to this SNS script. If they want to use SMTP, they'll go to SMTP, right? Each and every functionality that is being reused across the entire organization, they've broken down into modules, separate modules, and they have kept it. These are all plug and play modules. Anyone wants to do S3 inserts, or they want to write it in S3, or get data from S3, or remove data from S3, they can use the S3 modules, right? So this is the basic advantage here is, as I said, easy to debug. And second thing is reusability. Someone downstream also can use this because they're also doing it, or others, some other organization. You can publish this module. You can call it as Praveen.s3 and you can publish it in PyPI. Okay, so there's a marketplace called as PyPI. So PyPI. So here you will see all Python libraries and packages or modules that have been published by others, other individuals or other organization. For anything, let's say you want SharePoint, just click SharePoint, you'll get 100 different libraries or modules that gives you way to connect to SharePoint using Python. They also have good documentation, okay, and they also allow you to download the package itself here either using this, or you can use the Python pip, that is packet manager in Python. So if you do command python -m pip install, what are some library, let's say boto3, right? Python. Okay, so this will install the boto pypi. So if you see here, some will say it is connecting to your using pip version. Okay, fine, already satisfied. Okay, fine, is boto2, let's see. Okay, it's no longer available. I'll download this one only. What is the name? SharePoint. Okay, SharePoint. Requirement already satisfied. SharePlum. SharePlum is also there. Yeah, so now if you see here, it will show the marketplace where it is downloading. It basically comes to PyPI only. Okay, fine. Anyway, it's not showing here. Basically, it comes to PyPI. This is your default marketplace from where it downloads the wheel files. Okay. See SharePlum. So it downloads this wheel files and then it installs it in your machine. Okay. So that is how basically modules work, and that is what modules are: libraries or a piece of code that is being used regularly. Advantages, as I said, easy to debug, easy to test, and reusability. Right. In my code, I can have all this under single script. Right. I can have S3 write object, get object function, DB write to DB, read DB, get SQL connection, get base, all these functions, I can have it in a single big script. But what happens even if there is one line of mistake, for me debugging it will become difficult. So what I will do, I will divide my entire script into different modules. I'll separate them, I'll put it into different scripts, right? And I will use them in a common script, like here in this case it is lambda handlers. So here I may be calling all those individual modules that I just developed. So if you see here source.db, source.s3, right? I will import them. I will import all their functions and I'll do it. So here the advantage is, if there is any issue with S3, I can individually test it there, debug it there, fix it there. Any enhancement individually, I can go to S3 and do the testing. I don't have to go through each line of this big script and do it, right? Other thing is, downstream application may be using the same functionality, so they can take my S3 module that I've created, import it in their program or project, and they can get going with it. How do we create a module program in Google Colab? That you cannot do it, unfortunately. You can do it. Each cell is a different script. Okay, so one here in this case, one single script you put the S3. Okay, you create the definition S3. Yeah, you can create a class S3 there, right? Yeah, not as a file but as a class, different classes you can separate them and do it. But yeah, not exactly how we do it in normal Python, because in Jupyter Notebook that concept doesn't exist, right? We can import other notebooks. We can import from notebooks. If not file Jupyter Notebook, we cannot I mean, we cannot do it like what we do it in your normal IDE, right? We can import notebooks. I think it is run. You have to run that notebook or something like that. I have to check it. Okay, so basically these are Jupyter notebooks. Import one Jupyter notebook into another. How do I think in Databricks we use run? Okay, so yeah, see. So if you do this instead of this, so within this notebook, you define that particular class or that particular module and you can work with it. Run, basically run. Okay, percentage run and do it. Here it's in a different folder. Okay, source.s3. So you have to give the folder name and then you have to give the file name. Okay. For others, right, let's say it may be in a completely different main folder itself. Here within the project folder we have multiple folders, so this will work. Let's say that project folder itself doesn't have this, it's in a different project folder. What you can do is you can do append path. Okay, so this is what they've done here. So you have to use the Python sys library, then you have to use a path, and then this is basically a list. To that list, you have to append the other project path. So that if you append it, then you have to do import using the folder name only. Okay. Here S3 is the name of the module. This S3, S3.py, right? And then within that, this S3 is basically a class. If you're not using oops concept, you can also call in functions also. There are functions, individual functions. Let me see. Okay, everything is inside a class. So there can be a function called as def a, right? Outside the class. Okay. And it may be doing something. So that also I can call here as function. So all functions and class we can call in this way. So what it does is it will go to this particular script s3.py script, and from there it only loads these only the entire s3 class and the function a. It does not unload load all the functions within this s3.py. So if you see here, there can be 100 different functions. So all those 100 different functions do not get appended to your this script. Okay, so what import basically does is whatever functions you're calling or whatever modules you're calling, if you're calling an entire module, all the entire module functions, classes, everything will get appended to your existing script. So you don't want to do that, because in the backend then it will become slower, because interpreter has to go through thousands of lines of code. Rather you do from and then you do import, and you only import a particular component from that particular module. You can only do import like this. Okay, so what happens here, entire JSON module, this is a Python inbuilt module JSON. So this entire JSON module is appended to your Python code, this Python script. Whereas here only the database function, I think this is a class. So either the class or the function, independent class or the independent function, is loaded or appended to this particular script. Okay, so that is how it works. Installation of the cluster. The first thing is you need to go to CentOS 7, download ISO. Take the first one. From there, 4 GB is this one, right? Yeah. So this is the one that you need to download. And there's one more step, VirtualBox. Okay, so if your operating system is Windows, click on Windows. This is the first step you need to do. Sorry, my bad. You go to do this link, you'll get to this page, right? Here there'll be a couple of operating system names. So this is your host operating system, meaning the main operating system of your laptop, right? So if you have installed Windows 10, go to Windows host. If yours is a Mac operating system, click on this OS X host link. If it is Linux, then click on Linux distribution. If it is Solaris, you can go for these. Okay. So mine is Windows host. So I'll click on this. Automatically an exe file will be downloaded, right? So I don't want to download it because I've already downloaded it. So once that exe file is downloaded, double click on it and do next. You will install VirtualBox. Okay. So this is your Oracle VirtualBox that you need. Okay. So once that is done, then download the ISO file, right? So we'll go to the next step. So go to your VirtualBox, open your VirtualBox. Let me again. So VirtualBox. So when you click on VirtualBox, on your left hand side, this panel, you'll see 0 machines, right? Here in my screen, you can see master 1, slave 1 and slave 2. But for you guys, it will be empty. Hope that is the case with everyone, right? So in that case, what you need to do is click on new, right? Give a name. I'm giving master 2, but you can give it as master 1 because I already have a node with the same name, right? So I'm making it, okay, I'll create 1.2. You guys can make it as 1, okay? So you can give whatever name you want, but I would prefer that you go with the standard naming so that you don't get confused, okay? So master 1, and then machine where the virtual machine file should exist, go to others, and within your PC pick a place where you have enough space, minimum of 45 GB, okay? So here I have in my D drive, I have around 677 GB, right? So I'm clicking on that, and inside that I have a VMs folder. So within this I'll save all my virtual machines, okay? Within VM, so I'm selecting that VMs folder, right? So my machine will be saved under DVM, okay? Then type, you click on Linux. This is the operating system we are going to install on that virtual machine. That is what we are telling it, right? Then the version is Red Hat Linux 64-bit, Red Hat 64-bit, okay? CentOS is a free version of Red Hat, okay? There is nothing called as CentOS distribution within the virtual box. Basically it is Red Hat, okay? So Red Hat 64-bit, type is Linux, version is Red Hat 64-bit, machine folder, you have to pick place where at least 45 GB free space is available, right? And name, try to make it as master 1. I have made it as 1.2 because I already have a virtual machine called as master 1, okay? So this again I'm repeating, name master 1, machine folder where you have at least 45 GB free space, type is Linux, version is Red Hat 64. If this is done, click on next, right? And then memory size, for those who have 4 GB or 8 GB RAM, just go with the default option, that is 1024 MB. For people who have more than 8 GB RAM, go with 2048, okay? Then click on next. Then you'll see a create virtual hard disk now, right? Select that option, okay? Create a virtual hard disk now. Then click on create. Then within that, what is the hard disk file type? It has to be VirtualBox disk image, okay? VDI. Click that option, then click on next. How should the memory be allocated? Make it dynamically allocated, okay? Click on dynamically allocated, then click on next. Your hard disk size, by default it will show 8 GB. Instead of 8 GB, make it 15 GB, okay? That's the only change you need to make. Rest all are default options only. Then click on create, okay? So once you click on it, you will see on your left hand side master 1 is available. So if that is the case, let me first see the settings. Linux Red Hat, network is bridge adapter, Realtek, and all, okay. So now on your left hand panel, you'll see master 1, right? Right click on it and go to settings. Once you click on settings, you'll already see the general information that you already set, like what is the name, type, and version. Go to your network, right? It is attached to NAT, right? Instead of NAT, make it as bridged adapter. Okay, once you make it as bridged adapter, you'll get your name of your wireless LAN card. Okay, so this is my Realtek wireless LAN card, right? So that's why I'm getting Realtek. Whatever is your wireless LAN manufacturer, you'll see that name there. Then click on advanced, and here promiscuous mode is deny. Make it allow all. Okay, and then click on OK. And again, go back and click on settings. Check if all your changes have been accepted. Okay, my changes have been accepted. That is the case. Now go to storage. Okay, so in storage you will see controller IDE. Within that there's an empty disk, right? So in that empty disk, the option is IDE secondary master. Let that be as is. Click on this blue disk image. You'll see a disk image right next to the optical drive, right? Click on that, and choose a disk file, right? Choose a disk file, go to the place where you have say downloaded the CentOS, right? So CentOS, that file size, check it. It should be 4.6 or something like that. Click on that and click open, right? Suddenly you will see that CentOS, instead of empty, it is CentOS. Now right click and start normal start. Okay. Right click, start and normal start, and a black box should open. Here it will ask again which one you need to pick. CentOS only. Click start. Okay, it will start with the installation. So here you'll see two options: install CentOS, test this media, right? So you have to use the up and down keyboard keys, right? So the one which is white is the option that you have selected, right? So you'll be able to see three options: install CentOS 7, test this media, and troubleshooting, right? Go to the first option, install CentOS 7. How do you go up and down? You have to use the up and down key on your keyboard, okay? And the white option is the one that you have selected. Current selection will be in white color. So in this case, now it is at install CentOS 7, right? Then click enter key. So once you click on enter key, you'll see these messages. It will start and it will go to the beginning screen. Yeah. So you will come to the screen. Okay. So please do this step. So two things you need to see is installation source and software selection. You have to go make changes. Before that, there is a warning on installation destination. Click on that and just don't do anything. Go to done. There's a done button. Click on done again. That error will go. Okay. That warning is now gone. Now don't go and click on begin installation. Wait for it. Go to software selection. You see minimal install. You have to change that. Okay. From minimal install, go to infrastructure server. Okay. And then select DNS name server. Then email server is not required. FTP server, file and storage server, Java platform, network file system, MariaDB, remote management for Linux, development tools. So I'll start from the beginning. DNS name server, FTP server, file and storage server. Then you need to go a bit down. You'll see Java platform, MariaDB server, network file system client, remote management for Linux, development tool. Okay, once this is done, click on done. Now it will check and then you should get no error. Okay, there you have to click on begin install. Okay, so click on it, automatically installation will start. You will see two things: setting up the root password, user creation. Don't do anything on user creation. For root, click on that and set a root password. Root password is root itself. That when I'm doing the changes, you can follow the same stuff, right? So for me, I've made it as root. The password of root is root only. Okay. So then click on done. You have to click it twice because the password is too short. So I have to do it twice and I'll come back and my root password is set. Okay. Don't create any user. Don't click on that. Click on only root password. In the meantime, it will start installing all your software that you have mentioned. Okay. Most likely in that case, right, they will be using Scoop. They won't be using Spark. Spark is only when you want to directly read it from a particular table, particular HDFS file or something like that. Or if you directly want to hit the Oracle table and then store it inside your Hive table, then that use case it works. Okay. But here, what generally happens in migration, you directly don't do that. That's not from the architecture perspective, right? Because you want to see what data came in from the Oracle server to your Hadoop infrastructure. What they do first, they read it from Oracle table, put it in your HDFS, so that any error comes, you at least can know where it happened.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
Maybe the copying time from Oracle to Hadoop failed. That's why two records got missed. right? So you can see it in HDFS file. You can troubleshoot it. But if you're doing directly from Spark, right, there's no temporary storage. You're directly reading from Oracle server and writing it into Hive, right? In that case, how do you know whether Spark was doing the error or somewhere Oracle, due to Oracle, there was an issue, right? So that you will never come to know. So that is the reason why there will be an intermediate scoop job, maybe. Okay. See, again, that depends on the architecture perspective. But yeah, of course, I'll show you one example how to do it. But I mean, how to do it in the sense, I'll give you the syntax because I don't have an Oracle server installed, right? So you can try it out in your work environment. So guys, you'll see that if it's complete, you'll get a complete message. Then you have to reboot it. Then click on reboot. You don't have to do anything else. So it will restart. Once it restarts, you will see two options.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Go for the first one. Automatically it will choose within 15 seconds. So first option is the right one. Okay. So you will see like this. So here you have to give the root password, root username, and then it will ask for password. That is also root. Enter it. You'll get root at localhost. That means your installation is complete. Okay. So login as root, password is root. First thing you need to check is if you are able to connect to the internet. So you do ping www.google.com. 99% you won't be able to connect. It will say name of service not known, right? So you have to set up your Ethernet port, okay, your internet connecting port, actual physical port in your machine, right? But in a virtual machine, it's not there. So you have to set it up. So you have to type nmtui, that is the command. So when you click on enter after typing that command, you'll go into a blue screen where you will see edit a connection, activate a connection, and set your system host name. Activate a connection. Use your keyboard up and down arrow, same what we did in the first when we were installing it, right? So we have edit a connection, activate a connection, click on activate. You will see ENP0S3 as wired, right? And next to it, it is activate button is there. So you have to click on your right hand keyboard key. So you will go to that option. Whichever option you select, right, that will be highlighted. So earlier it was on your left hand side, then you clicked on the right hand side key. You'll go to activate button, click enter on that. Now you get an active sign. You see an asterisk mask, asterisk symbol next to ENP0S3. That means this particular port has been activated. So now that activate option is gone. So you'll see deactivate option. You don't want to do that. So now click on down arrow. You'll go to back, click enter. You'll come back here. Now edit a connection. Go click enter. You'll see ENP0S3. There, right arrow. You'll see add. Don't click on add. Go to edit, enter, and then almost everything is same. Okay, automatic except automatically connect, right? So when you come to automatically connect, you will see that there is no X mark, right? To go to automatically connect, click on space key. So when you click on space key, you will see that automatically connect becomes X. So that is what we need. That means every time system starts, please automatically use this particular Ethernet port. Okay. So now click on down key, down key, down key. Okay, it should go to OK. Then click enter. Do not click enter on cancel, or else all your settings will go away. Now again, right key, down, 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 back, enter, quit. Okay. So now clear. Now if you do the same command, you'll see that you are getting some response. Okay, not getting any response. Why? Okay, I'm getting response. Okay, so this response will keep on going until you click Control Z together. Okay, first you have to click those two keys together, then only that ping will stop, or else it's an infinite ping. Okay, so this means you are able to connect to the internet. You are able to ping google.com and do a handshake with that particular server, right? So that is what this command is for. It's an ICMP protocol. Okay, internet communication messaging something, okay, protocol. So this will ensure that you have established your connection with the internet. So that is what we need, because we have to download a lot of stuff, right? First thing is we need to download what actually, let me check. So we need to download a couple of softwares. It's not there in that link. First thing is we need to download Python 3. Okay, so yum install Python 3. By default, your Linux will be having Python 2, but for PySpark we need Python 3. So we'll do yum install Python 3. Okay, to check Python 3, you click, you will see Python 3.6.8 has been downloaded. Okay, so exit. And to confirm Java version also, Java hyphen version, I think 1.7. 0.8, right? For that, what I need to do is cd slash user slash lib slash jvm. Then I do ls. Okay, 1.8 is not installed, so I have to install 1.8. So I'll do yum install. Sorry, let me do that home. cd home. I'll do yum install java 1.8.0 open jdk devel. Yes. Every time it asks yes or no, always give it as yes. So when I run Java hyphen version, it should show me 1.8 underscore 302. So make note of the versions, because we'll be we have to put the same version in bash profile. So that is like a common place where we define environment variable. We need to mention the right version. I'll show you that particular step. For now, just remember to keep this somewhere. Right? Next step is yum install IP tables services. Yes. Okay, it's installed. Now the next command. Python is installed. Java is installed. What else do I need? IP tables is installed. Yeah. Yum install doc to Unix. Yum install DOS to Unix. Then here's my next command. Yum install DOS to Unix. Yes. So this is used, we'll be copying some files from my Windows machine to the Linux machine. So at that point of time, the format will change because it is traveling from different platform to another platform. So we need to use DOS to Unix to convert the DOS version of that file into Unix version. Okay, so that is done. What else? What else? Yeah, for now, this is what we need. Okay, so next step. Yeah, so this is a site. This is a link. And here you can click on the MSI one, right? And there will be an installer. Just open it, next. Your putty will be installed. Okay. So once putty is installed, open putty, right? And go back. First thing is go back to your virtual machine. Next thing is you need to check the IP address of your master machine, right? So the master machine has an IP address. To check IP address, the command is ifconfig. Ifconfig. So this will tell you the IP address. So now if you see at ENP0S3, there's a field called as INET, right? So next to INET, whatever is the number, that is your IP address. So 192.168.63.3, right? So this is the master one's IP address. Now go back to your putty. put the same IP address 192.168.68.3. Okay, and select SSH. Click on open, because here I can maximize it, but I don't have to, let's change 28. Oh, what happened? So go to your host name, right? Once you open Putty, give the IP address of your master machine, 68.3. Click on open. 68, 63, sorry, my bad. Okay, go to your master virtual machine, type ifconfig. Yeah. So if you see ifconfig, if you type, you will get this output. Now inside enp0s3, right, you'll see flags, and then you have inet. So inet field is your IP address. So whatever you see there, I'm saying 192.168.63.3. So this is my IP address. Okay, the same thing you have to give it in your putty. So if you look at putty, you will see here host name or IP address. Give your IP address minus 192.168.63.3, right? So this thing I'm doing it for myself. You don't have to do it big screen so that all the letters, everything is visible. It is good enough. Apply. Yes. Okay. So now once you're here, what you need to do is, first thing, you need to download Apache.organization distribution. You need to go to this link, right? And here you can search for Hadoop. We'll download all the packages one by one. Hadoop, Hadoop, to left, Hadoop. Okay, on Hadoop, then common. We're going to download 2.7, 2.7.3. We have done the same command wget, enter wget, I think. Sorry, my bad. That is wget. Wget. So it's a 204 MB file. This is the 204 MB file that you need to download. Next is Spark. Within Spark, it will be 2.4.3. Okay. Within 2.4.3, we'll be downloading 2.7.tgzip. So this is the one. Okay. Next command, wget this, and then hive 2.1.0, 2.1.0. Within that, there's this one. Hive, then Kafka. Okay. Now looking at this command, Spark. The hive is done. Kafka we need to download, right? Kafka also 2.1.0. 1.11 okay. Save. Kafka is this is Kafka. Kafka setup. Kafka setup. I think it's underscore 11 only. 2.1.0 and 11. And this is a TGZ file. You guys can download all this. You can run these commands one by one. Then I think we will stop after that. We need to go to WinSCP. So this is where FileZilla and WinSCP comes into play. So people who do not have issues with connecting to the server, I'll have to check. Otherwise, please download WinSCP for Windows user, and for Mac you can go for FileZilla. Okay. Click on this download button and install it. So I'm going to connect my file system, that is my local Windows file system, to my Linux file system. So for that I need WinSCP, right? So WinSCP and IP address is this. So this is similar to PuTTY. Only thing is that is for remote connect. This is for remote file connect. Okay. Root, and then I do login, update. So this is my Linux machine, that is after my Windows file system. So this side on your right hand side is your Linux machine's file system. On your left hand side will be your Windows file system. Okay. So if you see, we have downloaded Flume, Hive, Hadoop, Spark, and everything, right? So this is our master's file system. So within this, you'll see bash profile. So this bash profile is basically a file that starts at the beginning of your, when you boot this particular machine, when you boot master, right? So all the environment variables that you have declared within your bash profile gets loaded first, right? So here we will load a couple of environment variables. Okay, so for that I have already created a file and I have uploaded it. So if you go to Hadoop setup, no, I think it's there in your LMS. So you will have a folder called as Hadoop setup, Hive setup, Kafka setup. Please download it from your Spark setup, LMS, right? You'll also have a bash profile file. So you don't have to type in anything. You just have to copy paste it from your Windows to your Linux file system. So once it is done, if you look at it, you see I've exported so many paths, right? So many environment variables. So yours should also have the same thing. Okay. So one thing you need to do is you need to download these files. I'm selecting it, look at it carefully. These files are already there in your LMS. Download and unzip it. Okay. Flume setup. Yeah. So these are the files: Flume, Hadoop setup, Hive setup, Kafka setup, Spark setup, bash profile. Quickly can anyone check if all these files are there? Untarring itself is installation. Okay. There is nothing else to install. Okay, it will be in a zip file. You just have to unzip it. You have to put it in a place, right? We have put it in /etc/hadoop and /etc/spark. Okay, so here once you open it, bash profile, if you see Java home, this is a different version altogether. We downloaded 308, whereas this is 288, right? So we need to find out where the Java is installed. Java version, if you check, it is 302, right? Whereas in this it is 282, right? So first we need to check the link. So go till here, cd /user/lib/jvm. This is where your Java will be installed. Do an ls. You will see a folder called as this one. Yeah, so this is your 1.8 folder. Okay, copy and paste it here. So now when I do cd, copy the entire thing, and just to check if it's working or not, do this and copy paste it, check. Okay, so this is the right link. Then go back home. So I'll copy paste the command just to be sure you have installed the right Java version. Do this. If there is no error, that means you're in the right folder. Same path, you need to copy paste it under Java home inside bash profile. Okay, so once that is done, you're almost set. All the other steps are correct. Okay, you don't need to change anything. So now go back to cd $home and do cd $home, and then here you do source. Okay, so the command, next command is this. When you do this source.bash profile, all the environment variables that you have defined here gets loaded into the operating system. So now I can do cd Java home, the cd $Java home, and you see I've gone to the Java home path. If I do pwd, you'll see that I'm inside user lib jvm Java home, but just using the environment variable Java home, I was able to do that. So that is why we need, because even the Hadoop setup and Spark setup will look into these environment variables: Hadoop home, Hadoop conf directory, Hadoop mapred home, Hadoop common home, and all those stuff. And for us also, it is easy to move around within the file system. So now let me do cd $home. And again, if I want to check, if I want to go into the Hadoop setup file, and I just need to do Hadoop underscore home. Okay. So now if you see, I'm inside Hadoop home. Same thing, cd $spark home. I'm inside Spark. Okay. Now cd $home. Go out, and yeah. So now comes the important part. We have to copy paste all the Hadoop and Spark setup files. Okay. So go to /etc/Hadoop. Within that 2.7.3. Within that /etc again etc again Hadoop, right? And then here in your Windows machine, I told you to download those file folders, right? Go to Hadoop setup and copy this Hadoop course. Okay, here it's not needed. This Hadoop env.cmd is not needed. Can delete that. Unnecessary. Hadoop env.sh needed. Is needed. Okay, copy core site XML, Hadoop env.sh, HDFS site XML, mapred env.sh, mapred site XML, slaves, yarn env.sh, yarn site XML. Okay, copy and move it to this particular folder. /etc Hadoop, Hadoop 2.7.3 /etc/Hadoop. Okay, so this is your path. You have to copy paste inside this particular folder and do changed. So this way you know these files have been changed. So next step is go to /etc/Hadoop. Within that you'll see Hadoop 2.7.3. Within that you'll see etc. Within that you'll see Hadoop, and you'll see all the files. Here there's a changed column is there. Click on that. It will give all the files that have been changed on the modified date. Okay, so it will sort the files on the modified date. Okay. Then on your left hand side, open Hadoop setup folder that you have downloaded from the Google Drive. Okay. There, copy Hadoop env.sh, core site XML, HDFS site XML, mapred env.sh, mapred site.xml, slaves, yarn env.sh, yarn site XML, and copy paste it onto this side. Okay. Let me select those files so you know which all files to select. Not all files have to be copied here. So these are the files that need to be copied to the other side. Okay, so the next step, then run the command dos, one single word, dos to Unix. One by one, give all the file names that you copied. cd $hadoop underscore home slash etc/Hadoop. This is the command that you need to run first. Okay, and then you need to give dos to Unix, dos to Unix core XML. Okay, dos to Unix Hadoop env.sh, dos to Unix dos to Unix notepad env.sh, dos to Unix mapred site XML, dos to Unix slaves, dos to env.sh, dos to Unix site.xml. Okay, looks like everyone is done with this step. I'll go to the next one. The next step is within this, on your left hand side, within your Linux machine, the files that you have copied, open Hadoop env.sh. Okay, so in Hadoop env.sh at line number 25, you will see Java home again, right? So this again match with what is there in your bash profile, right? Whatever is the value for Java home in your bash profile, copy it and paste it here. If you don't do that, then starting the cluster, it will give you an error. So please do this step without fail, or else it will not work. Okay, troubleshooting it will become a difficult task. Make sure it is the same as your bash profile, the same path. Java home should have the same path in both bash profile as well as hadoop env.sh. So line number 25 you need to change and save it. So now next we'll go for Spark setup, right? So go to the URL /etc/spark. Okay. Within that, you will see Spark 2.4.3 bin Hadoop 2.7. Click on that folder. Within that, you will see conf. This is your Spark configuration URL. Let me copy paste it. Spark config URL or config path, basically, right? So now on your right hand side in your Windows machine or your Mac OS, you would have downloaded the Spark setup file. Where is it? Spark setup. From here, copy paste all the three files: hive side XML, slave, spark, env.sh, and put it to this side. Okay, all the three files. So if you are done with it, then go to your putty or your master machine, virtual machine, and do cd $spark home. Okay, then within that cd $spark home, then conf. Okay, so run this command. So once you are inside the conf folder, again same DOS to Unix for all the three files. Okay, DOS to Unix, hive XML, DOS to Unix, slave, DOS to Unix, Spark env sh. Okay, so these three DOS to Unix commands you need to run. We are copy pasting from Windows to Linux, right? The format changes, so it will be in some other format. So we need to convert it into Unix format. If it is already in a different format, if it is in the same Unix format, it don't do anything. Okay. So the next step is, now you have already copied the three files: hive side, slave, and spark env.sh, right? So on your left hand side, that is on the Linux machine where you have copied it, that is a Spark configuration folder. Open that spark env.sh. On line 73, you will see an Java home. 72, line 72, you will see Java home variable, right? Again, you have to change the path with what is there in the bash profile. So copy it from bash profile and paste it in spark env.sh. Okay. Rest all you don't need to change.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Don't touch or don't delete any other variable either in Hadoop env.sh or Spark env.sh. If you do it, then debugging will become a problem. Your cluster won't be up, and again you have to check all the files to make sure that nothing has been deleted. Okay. Before going, remember there is a slaves file in both Hadoop as well as Spark, right? So for people who may not be able to create two slaves, they may have to delete it at that point. But for now, keep it. We'll see which one. I mean, you can test whether you can create two slaves or not, a 3-node cluster or a 2-node cluster. If it's a 2-node cluster, you may have to delete slave 2 from your slaves file in both the configuration folders, meaning in Spark 2.4.3 Hadoop 2.7 conf folder, and inside Hadoop 2.7.3 /etc/Hadoop, right? So in this folder also there's a slaves file, right? Again, two slaves files in both the Hadoop configuration files as well as the Spark configuration files. So for people who cannot create a 3-node cluster, they'll have to remove this slave 2. Okay. This is again nothing but an alias. So now comes the next part where we'll be creating this alias. Okay, but before going there, we have to do one more step that we haven't done. Go to your Hadoop home, that is /etc/Hadoop/Hadoop 2.7.3, right? within that, so create this path, Hadoop store, HDFS. So we'll create it. Okay. So inside slash etc slash Hadoop, Hadoop 2.7.3, create a directory called as Hadoop store. Give full permission, read, write, execute, right? Or else you can give it in octal 0777. That means rewrite and execute permissions. Okay. So spelling is Hadoop underscore store, all in small letters. And then within that Hadoop store, you have to create a folder called as HDFS. And inside HDFS, you have to create two folders, name node 2 and data node 2. All the folders should have full permission, that is 0777. Okay. So data node 2, name node 2. Okay. So this folder, these two folders should exist inside a folder called as HDFS, which is again inside a folder called as Hadoop store. So this Hadoop store you have to create. This is not there inside the slash etc slash Hadoop dot 2.7.3 folder. Okay. So you have to create this folder and you have to give full permission. If you see here, read, write, execute, even HDFS has read, write, execute. Data node, name node has read, write, execute. Okay. So please create this folder and we'll go to the next step. Okay. So now is the main step that you need to remember once we have cloned the machine. Okay. So there is a folder in every machine, every Linux machine called as host. Okay. You will see it in slash etc slash host. So VI is the name of the editor. Okay. It's like a notepad for Linux. It's called as Vim editor. So when you run this, you will see a default mapping of hosts and aliases, right? So in the slaves file, you saw slave 1 and slave 2, right? So where does these come from? Basically, they come from the host file. And if you see at other configuration files, you will see master as well, right? So that is something I have given. So let's go to slash etc slash Hadoop. So if you see here, everywhere I mentioned master, right? So again, where is the master being picked? It is being picked from the host file. Okay. So if your IP is changing, this is the place that you need to come every time. Okay. So now you've used the Vim editor, you've opened this file, but you see there's no master, there's no slave 1 and slave 2, right? So that is something that we need to enter. Okay. So once you have done this, click on the key I key on your keyboard. So you will see insert being there, right? That means you can now edit this file. So this is the basics of Vim that you need to know even if you're not a infra guy. Basically, Vim editor is what is being used in Linux, right? So once you do that, click on enter, go to the next line. Here you give the IP address of your machine, 192.168.0.171. 192.168.0.171. Okay. So for now, we'll create three entries: master, slave 1, slave 2. Okay. The other alias is M1, S1, S2. So we can use either master alias or M1, slave 1 or S1. So this is for this entry, this is my actual entry. Whereas for slave 1 and slave 2, I have not created those two machines yet. So I don't know what their IP addresses will be, but I'm giving a dummy IP address for now. Once I clone this master into slave 1 and slave 2, I will get the IP addresses. So then again, I have to come to the host file in all the three machines and change it. Okay. So that's why this is the last step before we clone it. So make sure you have three entries in your host file. So once you're done writing, click on the escape key, the insert one disappears, then semicolon, then write and quit. Okay. W and Q. That means write and quit. So I'm repeating again, vi slash etc slash source. Once you open that, click on the I key, use insert. That means you'll be able to insert your entries. You'll be able to create. You'll be able to write into the file, right? You can write these three, make these three entries, out of which master and M1 will have the master IP address. Slave 1 and slave 2 will have a dummy IP address for now. Okay. So as I said, we have not cloned it. So we are not cloned it. Sorry. So once you're done with it, click on the escape key. So the insert disappears. What you saw, dash dash insert, that disappeared when you click on the escape. So after that, you have to give semicolon, right, and quit. W and Q, sorry. Okay, and then escape, semicolon, WQ. Okay. So when you do cat slash etc slash source, this is the next command. You should be able to see your changes. Okay. So here, if you see, my changes have been successfully applied to that file, right? So if that is done, we'll go to the next step. Okay, so this is where we'll be cloning it. So now shut down your machine. So for that, you need to give the command init -0 before that. Close your WinSCP. Close init 0. Okay, so init 0 is the command for shutting down. So you will be shutting down the machine. The master will be off, right? So once you are in this screen, right click, clone, and name it accordingly. Slave 1.1. I'm naming it as slave 1.1. You can keep it as slave 1.2 or anything. Then the next thing is the path. Go to the same path where you have stored the master one, right? So you can keep the same folder. Okay. Include only NAT adapter, network address. Let it be like this. Okay. So full clone and then clone. Wait for it. It will take some 5-6 minutes. So again, go to your master, right click, clone, and create slave 2 out of it. For me, it is slave 1.2 or 2.1. I can. This 1.2 makes sense. Okay. Then same path I'm giving. Nothing. Keep this name. Keep hardware UIDs. Don't click on any of them. Let it be the same thing. Only change is the name. And if you want to change the path, you can change the path. Otherwise, keep it as is. Okay. Then click on next. Full clone. Okay, so now 2 more steps are required. So I'll wait for people to be ready with 3 machines. Okay, because we are now going to start all the 3 machines. If everyone is done with it, then we can click on the start one. Okay, so click on start, you click on OK, and all the 3 machines will start together. Okay, select the first one when it asks for whether CentOS 7 or recovery. Okay, so click the first option. Log into all the 3 machines. So once you're logged in, first thing is do ifconfig on all 3 machines. Okay, and then note down the IP addresses. 0.171, slave 1, slave 2. How is my slave 1 address? 146. 2.168.0.146. Slave 2 is 155. Okay. 2.168.0.155. Yeah. So please note down all the machines IP address. This is my machine's IP address. Your machines will be different. So on all the 3 machines, run the ifconfig command and put it in a notepad in this format, right? Router, and there is switch, and there is a DHCP server. Okay, and then there are multiple laptops and machines, mobile phone, and this is connected to the internet. Okay, so this is your actual setup. So you will have a router and a switch. Basically, nowadays both are combined into one big router. Okay, router is also a switch. Within that, multiple devices are connected. Okay, and then your service provider will have a. So, okay, so let me put this part as ISP. So your service provider will have a DHCP server and a DNS server. DHCP. DHCP again will be inside your router itself. So DHCP server is basically the server which will decide what each machine's IP address should you go for a dynamic configuration. You can go for a static configuration where you can set the IP address of each machine and router will capture it and it will put it in a table. But if you go for a dynamic setup, dynamic IP setting, it will consult the DHCP server. DHCP server will say, okay, boss, I'm giving this particular machine this IP address and I'll give it a lease time, maybe 20 minutes or 30 minutes. After that, the IP address will be exhausted and a new IP address has to be assigned to that machine if it is still connected to the router. If it is not, if it's switched off, or if the Wi-Fi or you have switched off the network or something, then that is up to them, right? But it will only have this IP address for this particular time. So that is what is called as lease time, right? So let's say if your lease time is 20 minutes, then after 20 minutes, if you shut down, if you again switch on your laptop, your IP address will be changed. Okay. For me, my lease time is 1 year. So for my 1 year, my IP address doesn't change. Now, if the IP address today is, for me, my IP address is this, right? This will not change unless I change the network itself. My Wi-Fi network, I have a couple of Wi-Fi networks, right? So if I change it to anyone, then my lease period will go away automatically. So unless I do that, there's no point. I mean, there's no change. Okay. But for you guys, it may change, it may not change, depends upon your DHCP server setting. Either it will be in your router, in your own home site, but in foreign countries, it is all controlled by the ISP itself. So ISP has DNS as well as the DHCP server. So DNS server is your domain name service. So when you do google.com, how does it know the IP address of google.com? Google.com may be in your internet, right? Some place in let's say US, there's a Google web server, right? www.google.com.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
So how does your machine know that? It knows because DNS server captures that information. So there is a different network of DNS servers around the world. Okay, there are 14 root DNS servers. Okay, they capture all the information of all the websites and they will convert it into IP address. Okay, then from there, all the ISP's DNS server or any other private company or public company's DNS server will contact them. So when your laptop contacts this ISP's DNS server and says, boss, I need the IP address of google.com, it will check first, it will check its local registry. It will see, okay, there is no entry for google.com because no one in this ISP's network has actually queried for google.com. So I have not saved it. So let me ask the boss, which is the root DNS server. I'll go to them and I'll ask. They'll definitely have it. So it will send a query to that particular root DNS server and it will get the IP address of google.com. Then it will send it to you. Then onwards, for each IP packet, all the networking communication happens on the IP packets, right? TCP IP packets. So their destination IP address will be the Google's IP address. So every communication that happens over that. Okay. So anyway, those are all networking concepts that you don't need to know. All you need to know at this point is your DHCP server. What is the lease time it gives you? I don't know how to check it. If you can log into your router, that may be available there, right? My router doesn't give it, but the AT guys who installed it, the ISP, he said this router basically gives you 1 year of lease period. Okay. So you don't have to be bothered about all of them. If the IP address keeps changing every time you switch off and switch on, and then go to host and change the IP address. Okay. So now we'll be doing that. So go to each machine and run the command vi/etc/host. And we have already made those 3 entries, right? But for slave 1 and slave 2, we have given dummy IP address. So now give the actual IP address. Okay. Click on I key. On all 3 machines, you have to do it. Okay. So my slave 1 is 146, slave 2 is 155. Okay. Escape, right and quit. Go to slave 1, vi/etc/host, click on I key. Slave 1 is 146, slave 2 is 155. Escape key, right and quit. Go to slave 2, vi/etc/host, enter I key. slave 1 is 146, slave 2 is 155. Escape, right, and quit. Okay. In order to confirm, go to your master and do ping slave 1. Okay. You should be able to get a response. Okay. Then do ping slave 2. You should be able to get a response. Now go to your slave 1 and do ping master. You should be able to get a response. Then ping slave 2. You should be able to get a response. Then go to your slave 2, ping master, right? Then ping slave 1. Okay. So if you do this, if you're getting a response, then your setup is complete. We have one last step before we start Hadoop cluster and Spark cluster. Okay. So if you look at my master, right, root@master. So when I switch on, when you log in, right, if you see root@master, that means your alias has been captured. That means your IP address is intact. Okay. If it has become root@localhost, that means your machine's IP address has changed. Okay. So that is the biggest indication of IP address being changed. So initially slave 1, we hadn't created an alias, right? So if you look at here, root@localhost. But if you restart it, it will become root@slave 1. Okay. But if it doesn't change, if it has changed, then again it will be localhost only. Okay. So my master is .171. Slave 1 is .146, slave 2 is .155. So in any machine I can check. I can do cat /etc/host. So I'm seeing that master is .171, slave 1 is .146, slave 2 is .155, right? So that is what you need to do first thing after cloning. You need to make sure that you do a vi/etc/host, vi/etc/host, and in all three machines, and update all three machines IP if they've changed. If not, you don't have to do anything. Wait for Hive. We have not installed Hive yet. We just downloaded it so that it is there when we want it. Don't jump the gun. Just for now, keep Spark and Hadoop ready. When we do Hive, I'll tell you how to install Hive. This is the next step that once you're done with your /etc/host, just confirm in all three machines that the entries are correct. Okay. You did a vi/etc/host and you clicked on I key and you changed slave 1 and slave 2 because master you already given the correct one. Slave 1 and slave 2 you did not have it at that point of time. So you have changed it in all three machines, right? And then you have saved it using escape colon and write and quit. Okay. I need to delete that. So what I will do is rm -r. First go to cd $home, then rm -r .ssh. Okay, so rm-rf. Then we'll go to ssh slave 1, yes, which is root. Then there also I'll do the same thing, rm-rf .ssh, exit, and rm-rf .ssh. Okay. If you have done the ssh keygen, please follow this step. Do rm-rf .ssh on all three machines. Then we'll go to the next step. So we'll go back. Basically, this is the previous step itself. You guys don't do it. I just want to do it and then I'll see if it's working or not. Please don't do it. Don't do this step. I'm just doing for myself at this point. Right, DRSA, okay. cd.ssh. Copy idrsa.pub to authorize these. Okay, then SCP authorized search a1 root kdir.sh zip slave2 kdir.sh concept scp. What is the file name? Apache keys root /slave1 /root .ssh. Okay, slave2. Okay, now SS cd.home /slave1. Yeah. Okay. Okay, fine. So once this step is on slave2. So once that is done, what you need to do is you need to run this command called as ssh keygen t minus t space rsa space minus p capital P and two empty quotes, right? Nothing should be there in between. I'm copy pasting it. So run this command and you'll get an option enter file name which to save the key. Just click enter. When you do that, but it will take the default file name, that is IDRSA, right? So once that is done, do a cd dot ssh and check if you have IDRSA pub. So once that is done, you run this command within the cd dot ssh copy. Once the key is created, we did cd dot ssh in master and we did an ls command. We are able to see IDRSA pub. This is in master only. Okay. You should run the command ssh keygen in master only. SSH keygen minus T RSA minus P. This command should run only on the master. Okay. Once that is done, it will ask for a default file. I mean, it will ask for a name of the file. Click enter, right? And then you do cd.ssh, do an ls, you'll be able to see it.
So, moving on, next we can go about having a quick introduction to the PySpark Shel, guys. So, as we're already aware, PySpark Shel again it exposes our Spark programming model directly onto Python, and we can map. We can go about using Python with Spark directly, and our PySpark Shel pretty much links our entire Python API directly onto our Spark core, and it is used to initialize the Spark context as well. And as I've already kept on mentioning for a while now, majority of the experts, majority of say data scientists, analytics experts, they use Python because it has this amazing amount of huge library where you can pretty much find a library for even one of your custom requirements as well. So, at the end of the day, I'm sure people at Spark had to integrate Python with it because think about it. So Python gives you access to numerous libraries, and then if you can do all of that along with Spark, hey guys, that's a win-win, right? So integrating Python with Spark was definitely a boon. Yes, I can vouch for that. So yeah, PySpark again it requires Python to be available on the system path because Spark needs to know where Python is, and to have that unrestrained access, untainted access basically, and that is basically used to run all of the programs, guys. So to quickly give you an idea of what a Spark shell looks like, here is what it looks like on a Windows 10 machine, where you can pretty much go about installing Spark. I mean, installing Spark on Windows is it's very simple, guys. So as soon as you open up your the Spark shell and you go about typing PySpark, you can be greeted with a message which says Apache Spark with Python. And this is how some people might like working with shell and some people might not prefer. I mean, that's personal preference. But sometimes, yes, I still hold my word where I've told, working with shell is fun and you'll be learning a lot as well. So next, quickly have an overview of how we can submit a PySpark job, guys. So with in terms of PySpark or Spark in general, it's not that all of our code are independent of each other, right? So sometimes we have this native code dependencies. It can be with other projects. You can have multiple source codes from coming in from multiple directions, and then you need a way to go about packaging them with your application, and you need this code to be basically distributed to every single node on your Spark cluster as well. So for this, we usually, we go about creating an assembly jar file that contains our code and all of its dependencies. So there is a quick requirement for Java as well. And you have Maven again, which can have assembly plugins. And basically when we're creating your jars or say lists in Spark and Hadoop, So again, these are certain dependencies that we need to know, we need to work with. And again, here's a quick overview as well. So after that, we'll have the assembled jar file, which we can basically call as the bin file, or our Spark submit script, which is used to basically, as the name suggests, to submit our script while passing our jar file as well. So as soon as you hit Spark submit, so this script is basically used to launch the applications that you've just programmed and to push it on the cluster, guys. Again, quick recall, Spark is already pre-configured for Yarn. It does not require any additional configuration to run. Yarn controls all of our resource management, scheduling, and security. It is possible to run an application in any mode, right? Either cluster mode or client mode. So to be launching it in cluster or client mode, all you just have to go about using this simple piece of code. So you might be wondering all the backslashes, right? So if you're going about using shell programming, then you'll be exposed to a lot of slashes as well. So have a quick pause of the screen and try to see if you can figure out. I mean, it is not important at this point of time for you to know what this does, but then just see if you can figure something out, right? So most of your learning happens due to your perspective. So you try to figure it out and on your own, and I think that holds better in memory as well. So go about quickly pausing the screen to see if you can figure something out. And if you cannot, not to worry. Anyway, we'll be checking this out in the next couple of modules. So there, you can get familiar with this as well. So again, this is the steps which you'll be using to going about building the application. So we'll be creating a document. Let us say we'll call it PySpark job.py .py extension, because again this is a Python file. We'll be storing it on any of our local drives, local machines, and whatnot. As soon as you open the file, yes. So what we're doing here is we'll be printing hello. This is PySpark, right? So you can upload this particular file into our Cloud Labs local storage, guys. So if you're not making use of a virtual machine at this point of time, you can have this tiny hello world code to be pushed onto our Cloud Labs local storage, and you can perform this particular steps to go about working with it, guys. So basically, as I've already mentioned, to run your application you will be using Spark submit master, and we'll be using the Yarn cluster here. So we're using the Yarn deploy, and as soon as you go about using that client your file name.py, it will go about pretty much working with it. And if you can see here, if you can check out the mouse, this is where you have your application output as well. So this is how you would go about submitting a PySpark job, guys. And so how can we go about checking a PySpark job using a couple of Jupyter notebooks? Spark can pretty much go about easily running in its standalone mode that we have discussed. And consider this tiny example I have on the right for you, right? So this is again Google Colab. I'll be quickly walking you through the same. So in this particular example, we'll be importing PySpark for our usage. Firstly, we'll be installing PySpark, we'll be importing PySpark, we'll be initializing our Spark context, followed by that we'll be performing our calculation. So we'll be using the mod function. This is basically our basic, Spark job. And later we'll be using an RDD operation to perform a transformation, guys. I hope I am, again, piquing your interest on what an RDD is. So if I have to, give you a small trailer of what RDDs are at this point of time, well, RDDs actually stand for resilient or distributed data set, guys. So RDDs are the fundamental structures of Spark. And every data set in an RDD is again divided into a lot of local partitions, which is needed for each different clusters and all of that. Anyway, we'll be coming back to that. So let me quickly open up my Google Colab, so we can walk with our first PySpark job, guys. So this is Google Colab. You can basically access it by typing in collab.research.google.com. And this is basically, guys, at the end of the day, this is just a Jupyter notebook which is hosted on Google Cloud. So you can carry your code easily everywhere. So I've been using Google Colab for a couple of years now, ever since its launch, and I find it really easy. Basically, it's convenience, guys. So all you have to do is to run your code, you type in your code. So our first code is again to basically check the Java version that we require, and as soon as I go and hit the play button right next to it, done. So your code is executed, and you do not have to install Python, you don't have to install the dependencies, you don't have to go about configuring the runtime executor, nothing. So all you do is type in your code, hit play, and you're good. So that's how simple it is, guys. So basically we have Java version 11 right now, but for our Spark applications, most of the time we prefer Java 8. So I'll be installing selection 2 is basically Java 8. So I'll be going about installing Java 8 for that, and we'll be downloading Spark as well. So wget is again is used to download it from a particular server, and here's the official server link for picking up Spark 2.4.4. So as soon as I hit that, our Google Colab will go on downloading Spark and uploading in its file section as well. And this will take a minute, so we'll just continue as soon as we're done with the download. So that took about 20 seconds, guys. So that was pretty quick. And as soon as you download it, it is in a zip format, right? So it's in a TGZ format. So to go about executing this, we need to first of all unzip it, right? So we will use this command called darxf, where we are unzipping it in a format where Google Colab understands what is present inside our our Spark zip file. So after this, we have to install something called as PySpark. Can you guys quickly guess what PySpark is? Probably take a second to figure out what PySpark is. Think about it. I mean, if you can't figure it out, it's fine. So basically, to keep your Spark instance to be portable, we make use of PySpark at the end of the day, guys. So this is a very tiny module, so this should be, I'm guessing, installed under 5 seconds, and that's done. Again, you need to set up a couple of environment variables. We have to set up Java home. We need to set up the environment variable Spark home. So this is the code to go about doing that, and as soon as I hit play, that's done. So let us go about creating our first Spark session, guys. So we'll be importing PySpark, or to go about starting your Spark session using PySpark.init method, and then we'll be importing PySpark.sql. So we'll be including the SQL module from the particular Spark session, and at this we're just telling that we'll have only one local instance where you're working with it. So again, at this point of time, we're doing nothing but just creating an empty session for us. But you need to know that we have further code to check as well. So I cannot just go about executing further code because Spark session is already running right now in Colab. So let me quickly stop our session so we can pretty much rerun it again. Next up, we need to install PySpark. So we have installed Spark now. Let's quickly install PySpark. So this should take about half a minute, which is what I assume. Let's quickly import PySpark again, begin a new session. Let's go about creating our Spark context, right? So from PySpark, we're importing Spark configuration. Again, from the same module, we're importing Spark context as well. We're setting a variable, configuration is equal to Spark config. Conf.set master is local. We're telling it that this is the only local instance which will run. You can have any application name that you want, and here we just call it Spark Basics, guys. You have SE. SE is again our Spark context variable, where it's pretty much simple, guys. So you use this code, and this code is our standard, which is set to pretty much to go about creating your Spark context of your own. So let me run it again. It should take less than 10 seconds to go about running it. Here is what we were discussing in the PPT. We're defining a modular function where we're importing numpy and we're returning the modulus of that. So again, RDD is equal to sc.parallelize range of 1000, mapping it using the take function. I know that you guys are not familiar with any of these right now, but then to give you a quick example, this is how it works, guys. So basically, it is like a list of all of the elements. Again, it has a structured data type. It forms the native of Spark. And don't worry, I have lots of examples that I'll be showing you, a lot of functions, a lot of operations that I'll be walking you through when it comes to RDDs as well, which is actually the next section that we'll be checking out. I just wanted to get you familiar with Google Colab in case you chose to use another Python IDE for the previous modules, and I just wanted to show you how you're what you need to go about setting up your PySpark job, guys. So what are Spark RDDs, guys? So I've already told you Spark RDDs pretty much stand for resilient distributed data sets. But at the end of the day, how is it? Why do we need it? What a Spark? We'll be just checking it out in this particular module, guys. So this module is basically all about RDDs, and we really need to know what they are, why we need it, and all that, right? So RDDs are immutable. They are, they are separate, split, structured partitions of data. So basically, data, records, collections all mean the same. And they can be, how can they be created? Is basically, you can have a couple of functions work on it. I'll be walking you through the functions as well. We have map, we have filter, we have group by function, load, and loads of functions. So when you have all of these operations done and you have certain things which are done to your data, well, most of it is you need to save your data after you do certain operations on it, right? So to have a certain stable storage media, the media can be HDFS as well. And so after the transformations that's being done, you need a place to store it. So the transformation being worked on that particular data, guys, that is what RTDs are mainly used for. So there's a couple of things that I need to walk you. Very important things is pretty much with to start with. It is, again, the first thing is in-memory computation. RDDs support lazy evaluations, fault tolerance, very good immutability. Again, as I've mentioned, partitioning, very good persistence, and coarse-grained operations as well. So what are RDDs again? RDDs are the main logical data unit in Spark. This is the most important aspect of this module. They are, again, a distributed collection of objects which are, again, they can be stored in the memory, they can be stored in the disks, not just of one single machine, but they can be stored in the disks of multiple machines. And one single RDD can be divided into multiple logical partitions, and these partitions can be stored, these can be processed on all of the machines in a cluster as well. So again, yeah, RDDs, they can be caged, they can be used again and again, no matter how many times that you require for any of your future transformations. I mean, these are small files, so at the end of the day, you can keep caching them and reusing them. And coming to lazy evaluation, do you guys know what lazy evaluation is? If you do not, then again, as we've already been doing, take a quick guess of what lazy evaluation means, guys. So I hope you could guess it. It's basically, you have variables in your programs which are always bound to your certain data, and they'll be executing it, right? It's to have the evaluation separated from the data until the results are obtained, is basically what lazy evaluation means. To delay your evaluation. So let's say you have an expression, you'll pretty much be delaying the evaluation of it until that is required. So that is, the very simple explanation of what lazy evaluation is. And again, RDDs can support lazy evaluation, and it can support transformations and actions on these RDDs as well. So here's a quick workflow of how an RDD works. So we have RDDs, we have 1 and 2, which again club into single simple units. And then RDDs are like arrays, right? So they're pretty much structured data. So this structured data gets converted into graphs. DAG is directed acyclic graphs. And with a directed acyclic graph, what usually happens is data flows from one node to another in a structured manner, where data can jump back and forth, and each node is connected to another node which is ahead of it. So basically what I want you guys to figure out at this point of time is to know that the RDDs goes from looking like arrays and a lot of numbers, and it basically goes into a graph where our Spark unit can understand what's going on. So after our DAG scheduler finishes its work, where it assembles it, orders it, and stores it. So this is next passed on to our cluster manager. A cluster manager will figure out where to pull the data from, right? So it can be EC2, it can be via Kubernetes. You can pull the data from a lot of places. So our cluster manager again is used for this. So all of the task set from our RDD. So consider each individual RDD operation to be a task, right? So this entire task set is pretty much pushed onto our task scheduler, where the task scheduler will figure out when to execute what, and how long to allocate a resource for that particular task, and so on. And so all of this data is pushed to the executor, and our executor will go about executing and giving us the required output that we eventually require, guys.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So why would we require RDDs, guys? Think about it. So just to answer that question is the next part of this module. We need to find out what are the stop gaps in the existing methodologies that lead us there, right? So firstly, I have in-disk computation, guys. So before the existence of RDDs, what used to happen was we had again ton loads of data back in the day as well. But all these data were being processed in a hard disk, in a spinning slow hard disk. So we already know that in-memory computation can be done, which is already supported. Obviously, executing something in your RAM on your case is 100,000 times faster than what it's done on your hard disk. So with in-disk computation, again, we needed something to go about stepping up our game, and we needed in-memory computation basically. So again, with in-disk computation, you're going to be using a lot of memory to store, and at the end of the day, if that is slow, it really is a turn off, right? So next we have job execution. So basically, whatever was existing, right? So consider MapReduce basically. So MapReduce needs to store some of its data. It needs to have an intermediate storage space, which again we called it HDFS. So it needs a place to store all the intermediate data to access it to pick it up again. With the job execution, another important point is that it makes so overall computation of your jobs are really slow. So probably we can imagine and we can handle slow execution if it's one job 10 jobs, and it takes about 5-10 minutes. But if a 10-minute job was taking about 35-40 hours, then that would really slow down things, right? So again, overall, it slows down your input-output operations, serialization operations, replication operations, and so on. With parallel processing, again, when we didn't have Spark, most of the data processing were not done in parallel first of all. And even if an application supported parallel processing, it was not as efficient as that, guys. So we know how the RDDs are solving the problem for us. Well, mainly RDDs have, again, as I've mentioned, they have a huge capacity, huge capability to handle various volumes of data. So how does this do it? Well, basically it processes them all parallelly. It has multiple logical partitions where it can access work on each of the partitions and then save it later, guys. So you can go about creating an RDD whenever you want, but it's only executed whenever they are needed. So you can go on bunching up, creating tens and hundreds of RDDs that you want, and since Spark supports lazy evaluation, it'll only be picked up whenever it is needed, guys. So let's quickly check out some facts to go about explaining why RDDs are better than what's existing today. And the first important point I want you guys to note is that it supports enhanced distributed computing, guys. So distributed computing in this day in terms of big data is again a big boon, right? So again, Spark RDDs are useful for distributed computing, which involves processing lots and lots of data over lots and lots of computers with respect to lots and lots of jobs, right? So having this distributed computing capability is a big thing, guys. And secondly, partitioning. Well, RDDs again are partitions. So basically, by partition, what we mean is, in simple terms, it is basically split into a couple of logical partitions, guys. And the partition data is distributed across all the nodes that are present in the cluster as well. So that is again a very important fact of why RDDs are better. And thirdly, location stickiness, guys. So basically, RDDs can define their own preference, so they can have their own location to where they have to stick to the partitions and where they need to be present for the data requirement procedures. So again, location stickiness is again another very important reason of why RDDs are required. Next up, let's quickly jump into find out what are the features of Spark RDDs, guys. So as we already talked about this, as I already mentioned this, the first major important thing of Spark RDDs is in-memory computation, guys. So, and any RDD for that instance and all the data that are present there, it can be pretty much pushed onto your memory, and you can have it stay in that memory for as long as possible. And this is, I've put it first because this has to be the most important feature of Spark RDDs, guys. And secondly, with respect to immutability, you need to know at this point of time is that an RDD pretty much cannot be changed once it is created, guys. So that is what immutable means. And sure, you can perform certain transformations on it, and it can only be transformed, but it cannot be changed on the whole. So RDDs are immutable, guys. Lazy evaluation, again, the data, it's not available or transformed until something is executed where it triggers the requirement. So you can code in 10-15 RDDs and you can just leave it there. It will only be picked up when it is needed, right? So again, supporting lazy evaluation is again another big advantage of this. Coming to cacheability, guys, this is again another very important feature of Spark RDDs, where our cache storage, it stores all of the intermediate RDD results just in the memory. So nothing is being pushed to your hard disk or local storage. And the biggest advantage here with RDDs is that the default storage for its cache is in memory, guys. So this ensures higher efficiency, better speeds of data access, and all of that. And the next important thing is parallel data processing, guys. So to process data sequentially is surely an advantage, but to go about processing your data parallelly, side by side, is something which takes, which requires a lot of muscle. So again, we can be very happy and satisfied with RDDs, because RDDs can process the data in parallel for us. And lastly, the another important feature of Spark RDDs is that it can have types, guys. So it is a typed configuration where your RDDs can be of the type integer, it can be of the type long, it can be a float, and this again ensures better readability. It is more concise. It gives you that feeling of tailor make, where you can have your data which is in perfect condition, where as soon as you glance at it, if it's an integer coded data, if it's data with large numbers using long, or if it's a decimal number which has float and whatnot, guys. Next up on this module, we need to check out the ways the ways which is basically used to create RDDs in PySpark, guys. Again, that's the basically that's the symbol of collab that you see on the right in yellow. And we've already checked out how we can create RDDs in that simple example I showed you, right? So we'll be importing Spark configuration, we'll be importing our Spark context. Or to go on about creating a Spark context, we'll be creating a conf object, guys. So basically, this provides the entire configurations for our Spark application. You'll be setting the application name. You'll be setting the master node as well. In this, in the example that you see, it is local because there'll be only one instance in this particular example that I'll show. And yeah, so we'll be defining the app name, the master URL as well. Master URL is local in this case, and we'll be using SC. SC is nothing but an object which is derived from our Spark context, guys. So we can go about doing another quick set of operations as well. So we can create an RDD using a simple list. So we have already walked you through list in module 2. So just quickly revise the concepts of lists. So here we have a variable values, and we have 5 elements in a list, and then we're performing this operation called sc.parallelize, and we'll be passing the values. We'll be passing the values and creating the RDD using that, guys. So sc.parallelize is an unfamiliar syntax for you, right? So sc.parallelize is an unfamiliar syntax at this point of time. So the parallelize method, basically when you're applying it on a collection, right? So in our case, the list is the collection. So when you're going about doing that, a new RDD is created for us, and all of the elements that are they are copied into this particular RDD. So parallelize will pretty much go about creating a new RDD as well, and the syntax to go about doing is parallelize and passing it a collection, guys. And to print an RDD value, we usually use the take function, guys. So RDD.take of 5 will pretty much print the 5 items which are present in our collection. And moving on, there's a couple of things I'll be showing you practically as well. So to upload a file to Google Colab, we have this particular syntax from google.colab, import the files, and then we'll be pushing it into a variable uploaded is equal to files.upload. Again, that is a GUI. Again, I'll be walking you through that in a second. And we can go about initializing an RDD using a text file, guys. So if we have a particular text file where we're doing something, or we have a lot of data in the text file where you want your RDD to pick up the data in the text file, sure, you can do that as well. And we can go about printing the text from the RDD as well. So let's quickly jump into Colab, and we can check out the next set of demos, guys. So again, here's the demo that we're talking about. Values is equal to 1 2 3 4 5. It's a quick list for us. Parallelize creates our RDD, and as soon as I hit take, we'll have the output of it, guys. So uploading files to Colab, again, as soon as I run this, just see what happens. So it'll allow us, it's still running, so it's still waiting for me to put up a file. Let me quickly, jump to our desktop. We have a Spark file which is ready. It's a text file, basically nothing, nothing important. So basically I have, I have some gibberish written in there for this example, guys. So loading a text file is again pretty simple. se.text file of spark.txt. The location here we're giving spark.txt because, inside the files we already have it. So there is no other, no other path where we have to provide it. So it is just files in case of collab, guys. So as soon as I go about running this, it will pick it up. And as soon as I hit rdd.collect, which is basically used to print the RDD data, so it will say Apache Spark with Python is PySpark. So this data our RDD has picked up because of what I have put in the text file, guys. So it is as as simple and straightforward as that. Moving on, the next concept that we'll be checking out is something called as persistence and caching, guys. So to begin, we already know that RDDs are lazy, support lazy evaluation, right? So you can go about using the same RDD any number of time you want, and it'll go on recomputing it as well. So this goes on for a while. Sure, for small amount of data it won't have a major damage, but for large huge data sets which are worth terabytes, say, to recompute it every single time, I don't think it is very efficient, right? So to go on avoiding this recomputation on a single RDD multiple times, you can have your Spark to persist the data. So persist the data will pretty much store it in its partition and hold it there. So if the node that pretty much computes the RDD and pushes it to the partition, and if the node has a data, let's say if there is a node which has data persisting on it and it fails, so sure, Spark will again recompute all of the lost partitions of the data when it's required. So that is the keyword here, when it's required, right? Not all the time. So again, sure, RDD. So can you only persist? No. With RDDs, again, they come with a method which is called as unpersist. So unpersist will again let us, remove all this data manually from the cache. So let us say you do not require it, and you require your cache storage. Again, cache is again, a small amount of data, right? You cannot push everything on the cache and rather have it stagnant there. So basically you can use the unpersist method that you can go about removing all the data, RDD data, from the cache, guys. So here's a quick persistence level chart I have for you guys. So with persistence level, you need to know that you can perform this is basically to give the user flexibility, guys. So with the memory only level, you'll be pushing all your RDDs onto your cache directly. That's why the space used is high. The CPU time is low because the data is accessed faster. It is always pushed in the memory and none is on the disk. So again, it stores an RDD as a Java object basically. And so what happens if your cache is already full and it doesn't support? Most of it is saved into the cache, and the other part which is not cached will basically be recomputed when needed, guys. So again, we have memory only, sir. We have memory and disk. We have memory and disk, sir, and we have disk only, guys. So at this point of time, I would just recommend you pause this particular section to glance through the levels, guys. So there is you can have high CPU time as well, which is not efficient if you push everything on your disk only, and none of it is pushed to the cache. None of the intermediate storage is pushed to the cache, and all of your data are on the disk as well. So this again is inefficient, right? So quickly pause the screen and have a look at this persistence chart, guys. So coming to caching, guys, we already know that caching data is very important, and when your data is being accessed repeatedly, right? So again, it is very important to go on caching it. We call it a hot data set because you might require it at every single point of execution, say in an iterative algorithm and whatnot. And cache is fault tolerant, as we've already discussed. And let us quickly go back to an example, and we can check out the example where you can have a data set and you can pretty much have it caged, guys. So let me quickly jump into Google Colab, and we can work out with it. So coming to persistence, as we already have it with persist, it is going to hold it in the cache, and it is going to tell you where it is holding it, guys. So this is again a very important readability aspect of Spark as well. And coming to caching, as soon as we go ahead and hit spark.txt, again spark.txt is the file which we imported a couple of minutes ago. So with that, again text file.cache. So basically text file.cache is used to hold it there, and to basically at the end of the day, as a developer, as a programmer, to know that your data is fault tolerant and it will be there if something messes up is something important, guys. So now that we're done with that, let's quickly jump into operations that we can perform on RDDs, guys. There's a lot of operations that you can eventually perform, but then there's two main important types of operations that you can perform. So the first one is called as a transformation. Think about it, right? So RDDs are immutable, as we already discussed. So to work around this, we need something called as a transformation. So the transformation will basically return a new RDD, guys. So a lot of emphasis on the word new, guys. Since it's immutable, then creating a new RDD is, it's inexplicable. So creating a new RDD is a great requirement, guys. Again, what an action will do is basically it will return one singular value to us, and that will make our lives a lot simple, guys. So you will basically figure it out when you're getting your hands dirty with a lot of code. And without further ado, let's quickly check out RDD transformations, guys. So again, transformations, as the rest of RDD concepts, are all lazy operations that are basically performed on one RDD unit, and doing this will eventually lead to a transformation, will lead to creating one or more new RDDs as well. And how will it work? Well, here it is. RDD transformation, pretty much, it will return a single pointer which is created to the new RDD. So our application needs to know where the new data is going, right? So basically, pointer is used to memory map that. So our transformation will basically return a pointer to the new RDD, and it will allow us to create the dependency which is required in between each of these RDDs. Because let's say you have a couple of RDDs and each has a function to do something. It each has a unique function to it, and then to go about letting the RDDs talk to each other, calculating the data, having it stored in one common place, and all of that, right? So it's usually a parent RDD, and under the parent RDD we have what we call pointer dependency towards the child RDDs, and we work on with it. But at this point of time, let me not bombard you with a lot of in-depth details. All you have to know at this point of time is pretty much there is the dependency which exists in between each RDD, guys. Again, Spark is lazy, right? So by lazy, what we mean is lazy evaluation.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
So nothing will get executed unless you actually go about making some transformation or having an action that will actually create a trigger. So the trigger is basically what starts the operations here. So you can have job creation and execution there as well. So RDD transformation is transformation is basically not a set of data. You might be wondering if it's a set of data at this point of time. Well, it is not. It is a step in a particular program. It can be the only step, or it can be one among many steps. And so how the transformation works is it basically tells Spark how to get the data and what to do with it, guys. So couple of transformations that you can that we'll be walking you through with is basically map. We'll be checking out flat map. We can check out filter. We can check out map partitions with index. We can check out samples, union, intersection, all of these, guys. So without further ado, let's quickly check out each of these operations, guys. So the first transformation we'll be looking at is the map, guys. So what map in simple terms does is basically it passes every single element through a function. So think of mapping in literal terms, right? So let's quickly jump into code where it will be better to understand with code, guys. So again, we have a list. This is basically all strings: Spark, RDD, example, sample, another example, say. So as soon as we use x.map and we pass a lambda function through it, so what basically happens is it lets us map it into key value pairs that you can go about seeing here. So Spark is mapped with 1, and RDD is mapped with 1, sample 1, example 1, and all of that. So our lambda function is pretty much used to perform the mapping here. So again, this is the code that we just walked you through. So you can pretty much map the key value pairs to be anything that you want, and this is the it is used to add a little more structure to our data, guys. So next we have flat map, guys. So flat map, what I want you guys to know at this point of time, it is pretty much exactly like mapped, but then you can have your values to be mapped from from 0 to any number of output items that you want. Why would you do this? Because let's say you have a function that should return multiple number of outputs, right? So we already know that majority of our functions will only return one output. But let's say we require a function which requires more than one output. So let's say you require a sequence. So in that in that particular case, we will require the flat map, guys. So again, we have sc.parallelize. We're basically creating three elements, 2, 3, and 4. And we are passing it on to our rdd.flatmap. Lambda function range is 1 to x. Dot collect again is added instead of doing separately. So basically here we have separated out y dot collect, and here you can go about adding it there as well. So this again is pretty much creating instances and copying the values for us. So as you can check out 1 1 1 2 2 and 3, guys. So flat mapping, again, you wouldn't use it directly, but then you can go on a mapping to multiple elements that you want. You'll not be using it practically, but then hey, it's good enough. It's good to know, right? And next up we have filter, guys. So filter again, it returns a collection of elements which is you're filtering based on something, right? So think about filter in general as well. So you're filtering something based on name, based on ID, based on your roll number or whatever, right? So again, filtering here works the same way as well. So you have a collection. In our case, most of it is lists, and we'll provide a condition to it saying if this condition is valid, just collect all those elements for us. So coming to filter again, we have 1, 2, 3, 4, 5. If any of these individual elements, when you perform the modulo operation 2, if the reminder is basically 0, then we go about collecting it, guys. So we're going to divide 1 by 2. You will get a reminder, so that's not picked. You divide 2 by 2, reminder is 0. Yes, pick that. You divide 3 by 2, you will not get, you will have a reminder of 1, right? So that will not get picked. 4 divides 2 with a reminder of 0. Yes, 5 doesn't. So go about doing it. You'll get 2, 4. If you can, put in a 6 here, then you will pretty much get 2, 4, 6 as well. So it's as simple as that, guys. Next up, we have the sample operation. So sample, pretty much the process of sampling is where we small amount of data which either requires replacement or which doesn't require replacement, right? So having a sample doesn't have to have any ordered values, right? So you can have any random number generator to give you certain random data as well. So with the sample operation, we can have 3 parameters, guys. So this method supports 3 main parameters. The first one is with replacement. So with replacement is basically say sampling a certain element multiple number of times, right? So when you're sampling it out every single time, then you can have it replaced as well. The next up is the fraction. Basically with fraction, you go about making the size of your sample so as a tiny snippet or as a fraction of what your RDD's entire size is. And you can do this without replacement of data as well. And next we have seed. With the parameter seed, what we basically do is, it acts as a seed for our random number generator. Where we'll have a number being generated for us. So again, we're creating a number of range to 9, and it will pretty much go about generating a sample data for us, and you can work with that as well, guys. So to check out another example out here, we can check out another different range of data, but at this point of time, just quickly pause the screen, take a look at the code, and we'll be jumping to Google Colab, guys. So we're in Google Colab, and I just executed the second piece of code. So we're just creating sample data, which is from 0 to 8, and at the end of the day, we're collecting the simple sample data as well. And the next important operation that we should look at is the union operation, guys. So basically, union of two RDDs is basically concatenating and mixing all those elements. And yes, union does support repeated elements from most of our RDDs, guys. So let's quickly jump into Colab and execute it. So we have 1 to 9 on our first parallel, and then we have another variable called as par. We're creating an object of it from 5 to 15. So as soon as you perform the union operation on this and collect it, it is going to pretty much merge everything into one collection, and that is basically the output that you're greeted with, guys. So the next operation is intersection. Again, similar to union, but then it is the literal intersection, right? So whatever is in common in between both of these RDDs is what we'll be getting out of it. So quickly executing this piece of code from range of 1 to 9 and 5 to 15 in the numbers being generated here. 5, 6, 7, 8 are what is common between 1 to 9 and 5 to 15, right? So that's exactly what's printed. So the intersection is pretty much the common elements in both the data sets, and it's as simple as that, guys. Next we have distinct. Well, with distinct, basically we are transforming, creating a new RDD with all the distinct elements, right? So as I've already mentioned, it supports repeated elements, but let's say we do not require the repeat elements, right? So sometimes we require this hard coding where we require only distinct elements from it. So to go about doing it, basically all we do is it is exactly the same as our old operation, but again here we're doing a union operation. We'll just be adding the dot distinct method, guys. So dot distinct will eventually tell the interpreter to just give us distinct output and to filter out all of the repeated elements, guys. So another important thing that you can do with RDDs is basically to sort it using something, guys. So you can go on mapping something to another key that we've already seen, but what if you have to go about sorting this with respect to any of your personal any requirements, right? So here we have a sort by function, and this pretty much supports sorting in the ascending order, guys. So we have random numbers out here, 5 7 1 3 2 1. As you can already see, they are not ordered in any fashion, but as soon as I go ahead and run this, you can check out that it's ordered, right? So it's 1 1 2 3 5 7. So if we go about adding 10 here, 10 will remain in that last slot because it is the highest number. So again, after it's mapped, can we go on sorting it as we've already seen in the slides? Yes, we can. So this will be mapped again in the ascending order. So whatever is mapped for 1, Z comes first. Whatever is mapped for L comes next. Then H comes because it is the next 10, and lastly we'll get A, which is 26. So sort by is pretty much as simple as that, guys. So let's quickly check out the next one. The next is something what we call as map partitions. And map partition is a simple alternative when you have to use map and for each, guys. So map partitions are pretty much called only once for every partition. But in the case, if you remember, in the case of map, where what used to happen is we used to, basically it was an iteration, right? So we used to call it every single time for every single element of every single collection. So to pretty much bring up our efficiency, what we do with map partition is we call it only once. So we've defined our function f, and we have a variable called iterator, and we have something called as yield sum iterator here, guys. So what happens here is you just pick it up once, you pick up the data once, you iterate through it once, rather than just picking out single data for every single RDD. And but then that particular instance, what we saw, it was not indexed, so you do not know how you can go about pulling the data and what the data actually does. So to get a quick idea of how you can pull up the data with indexing it, we have map partitions with index, guys. So it's basically a single term, but then I've just split it out in the title to just get better readability. So what map partitions with index does is it returns a brand new RDD for us by applying a function on each partition of the RDD while tracking the index of the original partition. So we need to find out what the original partition's index is, and then we will go on keeping a track of it, guys. So we have 1 2 3 4 and 4. As soon as instead of just throwing in our iterator variable, we have something called a split index that we'll be pushing onto our function. And as you can see, instead of just using rdd.map partitions and collecting it later, we're pretty much going about map partitions with index, and then we're yielding the sum operation of it, guys. Again, you will not be using all of these operations on transformations on your day-to-day basis, but then it's really good to know that you have access to all of these and you can go on using it, guys. So next up we have group by, guys. So if you guys are familiar with SQL programming, the group by here pretty much works the same way as well. So what we basically do is we return a brand new RDD as we've been doing with all the transformations. We do this by grouping objects in the already existing RDD, and we'll be using a grouping key to know what we are grouping it by. So let's quickly jump into the code where we can check out group by, guys. So again, we have a collection 1 1 2 2 3 5 8. So rdd.group by is what we'll be using. So we're gonna group by the values if it performs and validates the module of 2, and we'll be collecting that, guys. and later we're sorting it as well. So as soon as we go about executing this, we get 0 2,8, that's valid. We get 1,135 as well. So basically you're grouping it with respect to an order, you're getting a key value out of it, and then you're sorting the key, guys. It is really simple. So the next thing is something called as key by. So what a key by does is basically it changes the key of the RDD element that we have been working on for a while now, and it does this using our given key object, guys. So with the key objects, what you can, I mean, you can already check out the code. So we are basically doing an exponential operation, x multiplied with x, and we're basically having a value from the range of 0 to 5 with us, and we're performing the list operation on it with y. And lastly, again, we don't know yet what the zip operations means, which is exactly what we'll be checking out next. But what you need to know is basically we'll have a key, and you can have your individual collection items of the data arranged with respect to the key, guys. So what is zip? So the zip operation, it is used to join the two RDDs by combining a certain part of each other, right? So think of it as a literal zip locking with each other, right? So you have one part of one thing, one part of the module talking to another one. So it is pretty much something like that here as well. So basically what we do is we return an RDD formed from this list, and we create another collection by combining all of these elements that we have obtained in pairs. So we obtain a pair from one RDD, we obtain a pair from another RDD called Y, and you can check out the iterative example on the screen as well. So we'll be picking out say A from RDDX with the data values 1 and 2. We'll be merging it with the data values of Y, which has the values of 4 and 1, right? It's pretty much as simple as that. So this will work when we have both of the RDDs of the same size, right? So what if one of the collections has a bigger size? So then what will happen, it'll map all our common elements, but whatever is in excess, that is pretty much ignored, guys. So let's quickly check out our zip function. So we have the range 0 to 5, 1000 to 1005. We'll be zipping our y with respect to x, and we're going to be collecting. So 0, 1000, 1, 1000, 1, 2002, 3003, 4004. Perfect. So next again, we'll be checking out our zip with index, guys. Again, it's a single word, zip with index, but for readability I just pushed it out separately. So what we do here is pretty much we'll create a new RDD. Again, we'll be pairing all of our elements that are in our list already. So whatever lists are present for us, we'll be checking out all the elements that are present there, and we'll be pairing it with their index as well. So you need to know that with Python, again with Spark as well, with PySpark, all the indices start with 0, guys. So since we're just adding an index for it, all you can do is pretty much A, B, C, D. The output we should give it is 0, 1, 2, 3, guys. So A will be mapped to 0, B will be mapped to 1, C will be mapped to 2, and the index of D is mapped to 3. Pretty simple, right? So next we have the repartition transformation. So repartition, if you've ever played around with installing Windows, Linux or something, then you would have been familiar with what repartitioning a storage medium means. So basically you'll be changing the number of partitions, guys. So it is either it is used to increase or decrease the number of partitions in an RDD. In our case. So how does it work in the backend? Well, all it does is pretty much it does an entire shuffle of all of the data, and it creates new partitions where our data can sit in a fashion manner, and all these data, all the partitions are distributed evenly as well, guys. So let's quickly jump into Google Colab and let's analyze. So the data we have is 1, 2, 3, 4, 5, 6, 7, and the second data set is 4. We're sorting it. We're using rdd.glom to pretty much go about with our repartitioning. So the output we should expect is 1, second element to be 2, 3, third element to be 4, 5, and the fourth element to be 6, 7. Perfect, guys. So to find out the length of this, again coming back to my presentation, again, to find out the length of this, you can pretty much use the repartition.glom. So repartition of 2.glom.collect is again giving our outputs. As soon as I go ahead and run this, it is going to tell us we're basically working with two RDDs, and two partitions have been created where the data is being stored uniformly, guys. So it's pretty simple. Next we have coalesce. With coalesce, the practical part of coalesce is, think about it, right? So you will have thousands of partitions when you're working with a huge data set. Coalesce is again used to combine, it is used to unite a couple of partitions where the data might be similar, or the data is not similar, you just want to bring it under one RDD. Then coalesce is pretty much your friend, guys. So we have two data sets here, 1 2 3 4 5 and 3. So as soon as we pretty much use.glom.connect with coalesce, as you can already check out, we have one single entity which is giving us the data, and the data is being merged and united into one, guys. Here is another example of how coalesce works. With coalesce, again, you can already check it out that we've split up the second element as we've used in glom in the first example, and in the second example we've pretty much gone about coalescing it and bringing it into one single unity, guys. One single entity, sorry. So next, so what does repartition, what is glom with respect to repartition, what does coalesce have in difference to each other? With coalesce, you need to know that we'll be using the existing partitions which are already present, guys. So this is basically used to, it is used to keep the data which is being shuffled into a certain minimum extent. But with repartitions, it always does a full shuffle of all your data, and it creates brand new partitions for every single collection of every single RDD, right? Again, with coalesce, results basically in every single partitions, they are stored with different amount of data, right? So not every single data element is of the same size. With repartition, again, repartition tries to pretty much partition your data in such a way where each of the data partitions are pretty much almost equal sized. Coming to the speed of execution, coalesce is pretty much a lot faster because the first of all the shuffle is minimized, and second, it has data of its own different dimensions. So whenever data needs to be picked, honing in and hunting in on the data is really faster with respect to coalesce than repartition, guys. So repartition is a little slower when you compare it to coalesce, guys. So all these while we were checking out transformations with respect to RDDs, right? So next we can go about starting checking out the actions we can perform on the RDDs, guys. So we're already aware, like unlike transformations, RDDs, they pretty much create another brand new collection for us. But here, with respect to actions, what we actually do is we create a new value which is given back to our Spark driver program, guys. But then to start an action, it needs a trigger. So actions have to be triggered with either a previously constructed RDD or another data entry point, guys. So with respect to the RDD functions, there is a couple of functions that we'll be checking out, and there's the reduced functions. There's first, there's take order, take count, collect for each min max functions, standard deviation functions, sum, mean, variance, and all these operations, guys. So let's quickly start out with reduce, guys. So with reduce, what it basically does is it brings everything, all the collections of a data set, and it we basically run all of these through a function of our choice. So as soon as we go ahead and let me quickly jump into Colab where we can go on checking reduced. So with it, the syntax is again pretty simple, guys. So for every method, every action, every transformation, we have a dot method which pretty much corresponds to it, and we'll be following the function that it needs to be passed through is basically the parameter that is supposed to have for the reduce function. So as soon as we run this, it is going to add all of the elements that are present in our function, guys. So just passing it through a simple function is what we're doing out here.
Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here is another simple example that we'll be pulling for all the values of in the range from 2 to 10, and so all these value here as well are being added together, and we're being given the output, and we're running a lambda function as well, like we've been doing for a while now. So if you guys are having some quick time running remembering lambda functions, I suggest you quickly jump into our previous module to get a quick rundown of what the actual lambda function does, guys. So The next action that we will be checking out is the first, guys. So first, again, if you can guess it, pretty much gives us the first element in our collection, right? So as soon as I go ahead and hit this, I get 2 3 4. The first element has to be printed. So if I do it 1 2 3 4 and run dot first on it, it is going to give us 1. So it is as simple as that, guys. So parallelize will be inputting our collection and we'll be running the dot first method on it. The next action is take ordered, guys. So basically what we do here is we'll be returning an array with a certain set of ordered values for the RDD, guys. So consider the example on your screen. We pretty much have input 1539402, and we'll be taking elements in the ordered value of, we need 5. So basically what we're trying to tell here is we need 5 values and we'll be taking it in the ordered sense, guys. So the first 5 values in the ordered sense will be 0, 1, 2, 3, 4 again. So again, as you can check it out, we have 0, 1, 2, 3, 4 because these are the first 5 ordered elements that we are outputting from the RDD that is present, guys. So next we have take. Take again, it pretty much picks up your value, but it does it without an order. So whatever order your RDD has been input in, or the collection that you've input in, is what it is exactly considering here, guys. So we have 1539, 402, etc. So this here will be picking up the first 5 elements in the order of their occurrence. So as you can check out, 15394 is being picked up, but here we are picking it up in the ordered way. So that's the difference between take, ordered, and take, guys. So next we have count. Count, I guess you can already guess, right? So it pretty much tells us the number of elements that are presented that are present in an RDD. So as soon as we go ahead and hit count, let's count manually, right? First, 1 2 3 4 5 6 7. So we have 7 elements. As soon as we run dot count on this, it should pretty much tell us that there are 7 elements present. Let's go ahead and add another one just for the sake of it, and it says 8. So the dot count method pretty much gives us the number of elements which are present in that particular RDD, guys. And next we have the collect action. So with collect action, what we're basically trying to do is we're trying to get all of our elements as an array, guys. So at this point of time, with certain transformations, we were creating brand new RDDs, but with actions, we're not doing that, right? So with actions, let's say if our driver program requires an array, it requires an entire structured data input. Collect pretty much does that, which we've been using and seeing for a while, right? So with collect, I mean, we're using collect for a while here right now. So pretty much I'm sure you guys could have guessed it. So the collect action pretty much just pulls it out and gives us the array output that we've been seeing from our first section. And again, here is another example as well. So it's pretty much just another different just a different collection of elements out here that we're pulling it out. But what we're doing with respect to the second one and the first one is, if you guys can see clearly that we have the distinct the distinct method which is being present here. So we have gnu, cat, rat, dog, gnu. So gnu was repeated twice, rat was repeated twice, right? So that is pretty much being avoided just because we're we're making use of the distinct method, guys. So collect is very simple. And next we have save as text file. So basically, let us say you want all the data which is stored in your RDD and you want to push it as a text file. So you pretty much if you want to pull it as a text file. So if the RDD's data set has to be presented as a text file to you and it has to be stored somewhere in your local file system or your HDFS, then pretty much you'll be going about doing this, guys. So with the save as text file, so pretty much we'll have a sample data which is generated for us. And as soon as I hit this, so if you're using a Linux or a virtual machine, this is usually how the data goes about with the path. So /user/bin/my-data A1 is the text file where the random data is stored, guys. So again, we can have instead of random data, we can just pretty much go about giving our own data and then pretty much having it save as a sample file for us as well. So since we're doing this on a Google Colab on a Jupyter Notebook, the files which are pretty much output are saved online. But if you're doing this on a local machine, then you'll have to give the full path of the file that you need to put. So let's say you want it in your desktop, you just cannot save desktop. You have to just go about doing C drive users, your username, and then desktop and the file name, right? So one important thing that you need to know is with Windows or with Linux, the extension is very important, guys. So I have had a couple of learners come to me with an error. So the file doesn't pretty much open because your native operating system such as Windows or Linux, it does not understand the the type of file which is being processed. So that is again another important thing which I pretty much wanted to tell you guys about. And jumping back to the slides, we have the next one is for each, guys. So with for each, again, the practical literal use of for each is where we are passing every single element into a function of our choice, right? So here we have defined a function called it f, where the variable is x. So what the function has to do for us is all it has to do is print. So we have defined the function, we're printing it, and then all we're running is this. We're running this RDD, and we're using the for each method to go on printing that out, guys. So let's quickly check it out. Basically, we're just printing each element and we're running it across the for each loop, guys. So next we have something called as the for each partition. Well, with respect to the for each partition, what we're trying to do is we're executing every single function for every single partition. So the access to all of our data elements that are contained in every single partition is, how can we go about moving with respect to every single element is basically we'll be using as an iterator as an argument, guys. So we'll be pushing an iterator to tell us how we can step across each single element and how we can go about printing it, guys. So for each partition is very simple. So we have a function which does the operation where we're running through each of the instances and we're printing x, and we have 1 2 3 4 5, which is our data elements. As soon as we go ahead and collect all the partitional elements here, so pretty much we'll be greeted with the same output of 1 2 3 4 5 as well. And now coming to a little bit of mathematical operations, we'll check out what min, max, sum, mean, variance, and standard deviation all mean. So Spark RDDs again support actions like min, max, sum, max, variance, and all the standard deviation operations as well. So I think it's better to move to collab and show you. So let's say we have numbers, a variable where we're generating an RDD for values from the range 1 to 100. And as soon as you go ahead and sum the values from 1 to 100, the value of 1 plus 2 plus 3 so on until 100 is pretty much 4950. And running numbers.min is going to tell us what the minimum number is here. In our case, the minimum number is 1. Next we have variance. So variance is pretty much calculated by finding out the mean of it. So mean is usually the middle element in an ordered set of elements. By ordered, I mean either in ascending or the descending order, and the variance is how much each individual value varies with respect to the mean, guys. So here in our particular case, for the values from 1 to 100, our variance is what we get is of 816, and variance usually remains constant for that particular data set, guys. So numbers.max, what is the max element that are present? So basically our range starts from 1 and goes all the way up till 100 and not 100 included, right? So the maximum number in our particular case is 99, guys. So from 0 to 99, if you have to check out the mean, then the middle element that you'll be considering is 50, right? So that is exactly what we're doing here, guys. So number.mean will pretty much give us the mean element, guys. And standard deviation is how each single element deviates with respect to the mean. So we've calculated the mean, then we need to find out how much each of the single element moves away from the mean, guys. And in this particular case, it is around 28.5. It is pretty much as simple as that, guys. So next up, we'll quickly check out a couple of RDD functions, guys. So we already walked through a couple of functions here, right? So we've seen what caching does. So caching pretty much stores an RDD without computing it again. With collect, we'll be returning all of the single elements. Collect count by value will pretty much return us a map with the number of time that each value occurs. Then we have distinct. It pretty much returns an RDD which contains only distinct elements and no repeated elements. In terms of filter pretty much returns the RDD containing only the elements which map to that particular filtered function. And for each, basically we'll be applying one single function. In our case is f. So we'll be applying one single F to all of the individual elements of the RDDs that are being worked on, guys. And with persist, again, as you already checked out, since the storage level, if it is memory only, then all of the data, intermediate data, the caching data is just stored in memory all the time. But then we can force it to bring it to our hard disk as well. That is with the persistence level table that you need to check out, guys. So storage levels are available, and basically depending on there's a lot of things that you need to check out before using the persist operation, because at the end of the day you might require one module a lot of times, but then it's not specific to get it very quickly. So then you can have it stored on your hard disk and you wouldn't mind that extra stretch, right? So something like that. And we have another couple of functions that you already checked. We have the unpersist function, where we'll be forcing it to remove the persistent blocks from our memory. We have checked out union, we have checked out intersection. Count will pretty much generate the number of elements that are present in an RDD, and sample pretty much returns the RDD of that particular fraction, guys. So next we can check out count by value. So count by value, let me quickly jump into my collab where we can check it out. So we have 1 2 3 4 5 6 7 8, again 2 4. So we have a couple of values here for our list, right? So as soon as I go ahead and run this, so if we are counting it by value, then it is going to tell us it is an integer type which is being counted, and it tries to map our values of the RDDs for us, guys. So it is pretty simple as that. And next we have to debug string. So with our to debug string, if we have to find out where the RDD is cached or where the RDD's value are being stored, if we have to check it in the backend, we'll be pretty much using .debug string, guys. So we have a range from again 1 to 19 or 1 to 13, and we're pretty much subtracting and storing it into the RDDC. So as soon as we hit debug, so wherever these individual values are stored, let's say if we have to map it for something else, or we have to use it for some other operation in the future, or to check where it is natively stored, we'll be pretty much requiring the mapped addresses, guys. So pretty much to debug string is literally used to to debug and let us know more about it. Let us check out how we can go about working with key value pairs, guys. So what you need to know at this point of time is there are a number of ways that you can get paired RDDs in Spark, right? So pretty much that's what we've been checking out for a while now. And there are many formats that can pretty much directly return all of these paired RDDs with all of their key value data as well. But with all the regular cases that we have checked, we need to convert these regular RDDs, and then we have to turn it into our paired RDDs, right? So here it is being done natively. So how can we do this? We've already checked it out. Basically, we can run the map function where a key is mapped to value. So creating a pair, which we've already checked out, guys. So rdd.map is pretty much going to assign a key value pair for all of our singular elements, and it'll create pair RDDs for us, guys. So basically here you can check it out: A1, B1, C1, D1, E1, A2, B2, C2, D2, and E2. So this is pretty much two different entities, and you can see a key element from A1 being mapped to the rest of the elements here, a key element from A2 being mapped to the rest of the elements there. And so again, here's another quick recap where we've checked out all the transformations that we've done. So reduce by key, again, it combines all the values with the same key. The syntax that you go about doing it is RDD reduce by key, and you pretty much send the function to it, which is add. And then group by key, group by works exactly how it works in SQL, as I've mentioned. It grows group bys with respect to one single key. With the map values function, it basically applies one single function to all of the values in a paired RDDs, and it does this without changing the key. With flat map values, basically we're applying one single function that returns an iterator to each of the values, right? So for each element that is being returned, all we are trying to do is we are trying to produce a key value entry. This is being done with respect to the old key, guys. So we use this with the process what we called as tokenization, but then we'll be looking at it in the next couple of modules as well. So you can you can check it out then. And next we have the keys function, where we basically just return an RDD with the presence of the keys in it. Sort by key, where you can pretty much go about sorting all these keys and then having an RDD give you these sorted transformations as well. So subtract by key will pretty much remove all the elements with the key that is present in the other RDD, guys. So if the same key is present in the second RDD, then it pretty much removes all those elements when it is clubbing it and transforming it into the next RDD. RDD. With the join function, basically what it performs is it performs an inner join. So inner join again is another SQL concept here. So it performs an inner join between both of the RDDs, guys. With the right outer join, again it performs a join between two of the RDDs where the key must be present in our first RDD in case of the right outer join. With the left outer join, again it performs a join where the key must be present in the right RDD or the second RDD that is being joined, guys. So with the right outer join, it must be present in the first one, the key must be present in the first one. With the left outer join, the key must be present in the second RDD, guys. And co-group, again, co-group is pretty much, it is used to group all the data from both of the RDDs where they share the same key. And next up, we'll check out something called as RDD lineage, guys. What is RDD lineage? So RDD lineage is basically a graph with all of the parent RDDs which were given before transformations, guys. So as soon as you apply a transformation, we're already familiar that another duplicate RDD is created and that RDDs are immutable and so on. So lineage pretty much graphs us out, it gives us a graph of, it gives us a DAG, directed acyclic graph of the parent RDDs of that particular transformed RDD, guys. So it creates this path, it creates a logical execution path starting from the parent RDD and going to all of the transformations which have been done, guys. So it's pretty simple. You will require this to, we've already checked it out. It's pretty much debug string to print our lineage, and it tells you the map where the memory slots are given. But then you'll only require this if you're going about debugging your application or if something is wrong with that. To further talk about this, so basically, let's say we have an RDD graph, which is basically the result of all of the transformations that we have done. And, we have an RDD lineage graph, which is generated on that. So since we have done some transformations on it, they will actually be executed in particular order, guys. So here is to explain more about the debug string method. So basically we have been doing rdd.toDebug from all this while. So with all of these functions that have been, let's say you've used the Cartesian method, you've used the map method, you've zipped it, you've used the union method, then you've pretty much gone using keyby, you've used another union on all of these, right? So to give you the path of execution, to give you a route that you have taken, pretty much you'll be using that again, guys. Let us check out word count using RDD concept, guys. So what is a word count program? A word count program will pretty much return the frequency of every single word that occurs in the particular file. So let's say we have an RDD that is created which basically stores a text file data, and later we have we'll perform a couple of RDD operations which will eventually give us the word count output of this, guys. So pretty much how we can go about creating an RDD using a text file, as we've already checked out. So in this particular case, we'll be uploading the file to Google Colab, and we let Google Colab take care of our file, and we'll be filtering it using our Lambda function, and we'll be checking out with the length of corresponding elements to be greater than 0. We'll be splitting all the words separately, and we'll be having a flat map for us at the end of it, where we'll be splitting it based on an empty character. And lastly, we'll be using the reduce by key and sort by key, where we'll be counting the frequency of occurrence of each single word, guys. So let's quickly jump into Google Colab and let's do that. So instead of PySpark.text, let me quickly go about doing spark.text, because which we already have, right? So we have spark.text. So as soon as I go ahead and create our RDD, we're picking it up, we're adding a filter to it, we are making it a flat map where we're splitting all of the individual elements, and we are actually counting the word, right? So now as soon as I go ahead and run this, pretty much all of these words have been put only once. So we have Apache Spark with Python is PySpark. So all these are occurring once, right? So let's quickly change that. Let's have Spark here. I'm gonna give another PySpark. Probably let's do it a couple of times here. S is caps. Sorry about that. PySpark. So let me quickly save it. Come back to our Google Colab. Let's go to the part where we actually uploaded it. Or there's another simple way where you can upload files, guys. So to basically to upload files, all you have to do is open this tiny tab. You have to hit upload. You can actually go on deleting this right now. Go to desktop, go to Spark, upload this. So yes, so whenever you've uploaded files, it will get deleted as soon as the runtime is recycled, guys. So now PySpark is one, but let's create another RDD because we're picking it up from a new file. Let's filter it out again. Let's add flat map to split all the elements. Let us perform the word count and sort the words. So as soon as I go do this, it says PySpark appears 3 times. Pretty much simple, right? And then you can pretty much save this entire flat mapped output into a text file, and you can have it in under the folder called as word count. So if you're using this in your local machine, you need to give the location of the folder where you'll be pretty much wanting to store the data, guys. So the next simple concept that we'll be quickly checking out is called RDD partitioning and achieving parallelism, guys. We've been talking about partitions a lot, right? So partition is nothing but a logical chunk of data, which is basically large amounts of data. And Spark manages to pretty much use all of the partitions, and it helps parallelize all of the distributed data that we have, and it has to do this with minimal network sending, right? So you need to send the data and the receive data between executors as well. So if half of your time is wasted with just sending and pulling data, then it really doesn't make sense. So Spark has to do this efficiently as well, and it does. Well, how? Well, by default, pretty much Spark tries to read the data into an RDD from the nodes that are right next to it. So it will pretty much figure out what the access time of data from each node is. And this will basically tell it how close the node is from the RDD, right? So then it pretty much does the data pulling and pushing, and now we have the criteria where it really does minimal network trafficking, right? So here consider we have a couple of items. We have about 25 items on the screen, and the RDD here is split into 5 partitions of 5 each. So item 1 to 5 is partition 1, 6 to 10 is partition 2, 11 to 15 is partition 3, 16 to 20 partition 4, and respectively 21 to 25 is the 5th partition. So again here, as you can check out, if we are mapping it, we can cross map it to something else where we are pretty much using it as efficiently as possible, guys. And since Spark usually accesses distributed partition data, and to optimize all of the transformations, it creates the partitions that can hold a lot of data. So every partition is pretty much being created where it knows that it can hold a huge chunk of data, guys. So do we have to program how we partition the data? Well, absolutely not, because RDDs get partitioned automatically without a single intervention from the programmer, guys. But Spark pretty much gives us the functionality where we can go on adjusting the size, the number of partitions, or how the data has to be partitioned based on our particular application, guys. So this can be done using the def get partitions and array of partition method, where we'll be pretty much this is basically functioning on an RDD, and this will get to know the number of partitions that are present in the particular array, guys. So coming to the types of partitioning, we have 2 types of partitioning. One is hash partitioning and one is range partitioning, guys. So again, this is another step taken by the developers at Spark, where they're giving you the customization to partition it based on your particular needs. But there is a very important thing that you need to know is customizing partitions is only possible when you're using paired RDDs. So you cannot go about using this on single RDDs, guys. And but then so this might feel like a disadvantage at this point of time, right? But it is not. So again, another basic advantage here is that pretty much you will have data which is very similar, right? So you will have multiple cases of similar data which is located at the same place. Then shuffling the data pretty much in by transforming it by using group by key, reduce by key will again make it an efficient way to pretty much know that you have an index where you can pull your data from. You can arrange it, you can sort it based on that particular index element, and this is again an advantage of having paired RDDs as well. So coming to the hash partition technique.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
The hash partitioning again is pretty much the technique where one single key, we call it the hash key. So the hash key is basically used to distribute all the elements across the partition, guys. So one thing, I mean, you will not be using this practically, but I just found this to be an important concept that I want to teach you guys. So with hash partitioning, basically you need to know that we have something called as the hash key, guys. So the hash key is at the end of the day our go-to person, where we'll be using it to distribute our, basically we'll be using it to track, to create and to distribute all of the values in terms of different partitions, guys. So again, we have one single RDD on the top. We have a couple of elements in that particular RDD, and pretty much we'll be hashing it. We call it the hash key. So we'll be using the hash key to pretty much tell where where the particular key and where the element of that key has to sit and in which partition basically. So all you need to know at this point of time is that the hash key denotes where an element has to go into which partition, guys. Coming to range partitioner, well, we already know that RDDs, they have keys, and sometimes these key will have a particular order, say ascending order or descending order. And to go about doing this in a fashioned manner, instead of using a hash key, we'll be pretty much going about using range partitioning, guys. So range partitioning will work when you have something in ordered. So how do we go about doing it is basically, we'll have tuple here. Our tuple will have keys which are, in the same range as our native RDD. And keys in this particular range partitioners are actually partitions based on all of the sorted range of keys, guys. So you need to, the keyword that we are trying to highlight here is pretty much sorted. So the keys which are present here are partitions which are based on the sorted range of keys and the native ordering of the keys as well. So how do we go about doing range partitioners? Well, it's simple, guys. So first we need to compute a reasonable range boundary to our data, right? So we cannot have huge set of boundaries and work on it. Basically, it will take more time. Followed by this, we'll be constructing a partitioner, giving the partitioner that particular range boundary that we're using it, and telling it to partition our index and work with it from there. And lastly, we'll be shuffling our RDD values against this particular range values, guys. So we have a couple of tray numbers out here to give you as an example. We have the complete tray number and from where it moves. So central station, northeastern station, Bayview, and all of that. So you can pretty much observe that a value from the southern train has been put into another RDD out here, and a value from our first central RDD has been put here as well. So as soon as the new RDD is being created after using our range partitioner, it is being done in a certain order. But then you need to know that the values are being shuffled after the values are being changed, guys. Coming to the last concept of this particular module, we'll be checking out how we can pass functions to Spark, guys. So basically, most of Spark's transformation and some of its actions, it basically depends on passing the functions that we have already seen, right? So we usually pass functions by adding it, we're sorting it, and we can use functions there as well. So each of the languages that we'll be working on, Python, Java, and Scala, they each have a different mechanism to allow the operation of passing a function. And in Python, we can pretty much pass one function inside another function, and you can have it under an anonymous setting as well, which is the Lambda function that we'll be using, and a couple of other functional APIs provided by Python as well. But some other considerations that come into play here are the name of the functions that we pass, the data that we reference in that function, and if the data needs to be ordered, and if they need to be serialized, guys.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. dstream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So Spark's API, again, the most important point on this slide for you guys is that it relies heavily on passing functions in our driver program, so it knows what can be done and what should be done when it pretty much runs on the cluster, guys. So two recommended ways to go about doing this. First one is to pretty much go about defining an anonymous function. Basically, it is a method which is used for any short snippets of code. But then what if you have a longer program or a longer set of code that you need to go about doing it? Well, sure, you can pretty much use an anonymous function as well, but then it is impractical to go about using typing it out in a single line. So we can use something called a static methods, where we'll be using a global singleton object to go about doing this, guys. So coming to the first anonymous function, so basically it's a method where we'll be using it for short pieces of code that I've mentioned. So one quick example for a short piece of anonymous function that we've already discussed is the lambda function, guys. So lambda x, this function basically returns nothing but a sum of 2 to the input variable. So whatever is on the left of the colon is again the list of parameters that you need to pass, and on the right is the expression that which is required to involve all of the parameters and to perform operations on that. and you can name the functions as well. So as we already seen, 1 2 3 4 5 values and RDD is being created. We are creating the map function, and then we are having the lambda give us the +2 output of whatever is the input, guys. So functions take in multiple parameters, or the functions can take no parameters as well. So there's pretty much no compulsion that you have to compulsorily push in values to a function, guys. So as you can pretty much check this out, we are adding 2 to each of the elements here. So 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, and so on, right? So it is pretty much simple, guys. So with the anonymous status of this function, so as soon as you pretty much find it's basically saying is that it needs to init our main function and then get the value of x. So you can have the lambda function return the x plus 2. It doesn't have to be as simple as x plus 2 what we've shown here, but then you can pretty much go about doing it in more complex ways, again depending on your application as well, guys. So coming to static methods, let's say we have the quick example where we are defining an object. Let's call the object as my functions, and let's pass a function to it calling it as func1. So instead of just passing values to our function, what we can go about doing is pretty much we can do the call by reference as well. So if you have to revise call by reference quickly, then you can go about checking out the older module. But to tell you what call by reference means is basically the value gets copied into the formal parameter, and changes done inside the function pretty much reflect outside the function as well. So instead of having just one singleton object where you'll have to create another duplicate object and work on it, with respect to static methods, it basically requires nothing but just sending one single object, and it contains it basically that single object that you send will pretty much pull in and bring all of the class data mentioned along with it as well. So here's what a simple class looks like. Class name of it is my class. We have function 1. We have another function, it's called do stuff, and basically here what we're trying to do is we're creating an instance of the class, and we'll be calling the function of it, guys. So the do stuff method of it. So the map inside the reference is pretty much it's the func1 method, and the whole object. So as I showed you in the previous slide, the entire object has to be sent into this class, guys. So to give you a quick example with respect to mapping, it is exactly as similar as writing rdd.map, where we are mapping the same reference, this dot func1 of x, guys. So again, Spark is pretty much giving you the highest efficiency possible when you have to define an object like this, and when you have to pass the entire object towards the class, and you can pretty much go about mapping it using one single line, guys.
So Spark for big data, let us understand how Spark works with big data. So originally, what we used to do for big data, now big data is any data source that is outputting data at a very high rate, like petabytes per second or terabytes per second. And big data is also considered any data that is basically above the size of terabytes or petabytes is called big data, because it is of an extremely high size, right? So earlier, we used to use this framework called Hadoop MapReduce to process big data, right? So what Hadoop MapReduce used to do was basically, if you had a bunch of computers together, if you had a bunch of servers all connected together, you will basically divide the data that you have to process across all of those computers or servers in equal parts. Once you've divided the data, all of those servers or computers will execute their part of the big data analytics query on the part of the data that they have received in parallel. So that reduces the time that it would have taken to process that big data if we were doing it in a sequence only on one system. So Hadoop MapReduce was the first framework that helped us achieve big data computing with parallel programming, basically. So each node executed their own job, and after all of the jobs were executed, the output was aggregated, it was combined together, and at the end of it, we got the output at a much faster rate, right? So you can see the original framework, big data is here. We pass the data through Hadoop MapReduce framework, right? And we get our desired output. So the problem with Hadoop MapReduce is that it's a primitive technology. It was used in the earlier days when random access memory, or RAM, or physical memory, as we like to call it, was really expensive. So you must remember a time, if you're familiar with computer hardware, you must remember a time when RAM was extremely expensive. Now it's not that expensive. We have it in plenty amount in almost all mobile phones that we use today. So RAM has gotten a lot cheaper ever since the early days. Earlier, when we used to process big data, every temporary file that we used to create in between our jobs, every temporary output that we used to create in between our jobs was written to the disk. It wasn't, we didn't depend on the RAM. We wrote that output on the disk, the hard drive, right? And then when we needed that intermediate output once again, we basically read that from the disk again and put it back into the RAM. So that is how it used to work, because we didn't have a lot of RAM. So we didn't store anything on the RAM for a really long amount of time. We stored it on the hard drive, right? So after we read it, and then we got our desired outputs. But the problem with this essentially was that there were input-output delays, right? Because every time you're putting the data back into your hard drive and reading it back into your physical memory, there is some lag. There is some input-output delay. So this input-output delay, when you're dealing with extremely large amounts of data, this input output delay can add up to a lot, right? It can increase the time taken by your job by a lot. So we needed a solution for that. So when RAM or random access memory started getting cheaper, when physical memory started getting cheaper, another alternative was developed to cheap. We store the intermediate hard output on the RAM itself. We store it on the physical memory of the node itself, because we have the ability to, because we have RAM in plenty. So because of this, there is significantly less input output delay, because we don't have to write anything much to hard drives anymore. We can simply read our data once from the hard drive, put it into the RAM, process all we have to, and get our output directly. Now, for smaller files, the difference between Hadoop MapReduce and Apache Spark is not at all visible. But when we are talking about files in the terabytes and petabytes, we can almost certainly see that Apache Spark is about 100 times faster in the output that it gives us as compared to MapReduce. Let us look at how normal data is processed. So if you're coming from a data analytics or a data science background, not from a big data background, if you've done something with data analytics or data science, so you must have used these particular technologies like Python and R. These are the most popular technologies for data related subjects, essentially. So data analytics and data science with Python and R. So you have your normal size data. Say if you have a data like 5 MBs, or if you have a data like something like 500 KBs, right? Very small amount of data. So this is generally the size of the data set that you must be familiar with when you were using Python or R. This is the normal size of data, very small nominal sort of data set, but you plot your charts and whatever you have to do. So that is normal data, right? So you pass it through Python and R or Java or Scala, and you can use the libraries that they have to process this amount of data, and you can get your desired output. So this is for normal data. But what if you have big data and you want to use the same languages, right? You don't want to use any exclusive language for big data or anything. Not that anything like that exists, but if you don't want to use anything, if you don't want to learn anything new, you want to simply integrate big data in what you know as it is in your data science or your data analytics. So Spark provides you with exactly that. Spark provides APIs, application programming interfaces, for all well-known data analytics languages like Java, like Python, like R, and like Scala, for seamless and easy integration, eliminating the need for training for newcomers, right? So basically, you'll use the same logic. You'll use the same logic as you were using with Python, and you'll use the same logic as you were using with R. You will simply import a bunch of libraries for Spark. If your system has Spark configured onto it, you'll just import a bunch of libraries for Apache Spark. And then you can simply pass big data sets as well in your query. If you pass big data sets in your Python and R, normal vanilla Python and R, they would have given an error, or they would have taken a lot of time to execute that output, because they were running on single node systems. When you use these libraries with these Spark libraries with these languages, you can essentially take advantage of the multi-node Hadoop cluster or multi-node big data cluster that you have. So you write your normal Python script, you import a bunch of libraries, you run that Python script, you run the Python commands, and you'll get that output at a much faster rate, similar to what Spark can provide you. So that is the advantage of using the Spark APIs with these languages like Java, Scala, Python, and R. So I hope that makes it clear for that particular doubt. Okay. Do Spark, vanilla languages, and Hadoop do the same work with different speeds? Yes, exactly. So if we are lucky and the vanilla code does not give any errors, so say if we have like a 1 TB file, 1 TB CSV file, right? And we simply pass it in Python using pandas. We create a data frame out of it, 1 TB file, right? We pass it in pandas without using anything else, right? We create a data frame out of it. Either it will simply give us an error because we don't have as much RAM on our system, right? Or if there is some sort of workaround to that, it will execute really slowly because your CPU is not capable of basically handling that big amount of data. It will basically take a lot of time to execute and give you the output. Even a simple +1 on all of the column values will take a lot of time when you're dealing with vanilla scripts, essentially. So, and Hadoop MapReduce obviously can do it a lot faster, but it'll still take a lot more time when compared to Apache Spark, right? So yeah, there is a speed difference essentially at a fundamental level between vanilla scripts and Hadoop MapReduce and Apache Spark. So I think this is clear why we use Spark API libraries with big data and why we use vanilla scripts with normal data. So this is what Spark helps us with. So let us understand the workflow of Spark, how to query data files. How do you actually query data files with Spark? So it's a very simple Java-based model. So a data frame is something that you need to familiarize yourself with when we're talking about, particularly when you're talking about Spark. A data frame is a data set organized into named columns, right? It is conceptually equivalent to a table in a relational database or a data frame in R/Python, but with richer optimizations under the hood. So one thing that you need to note specifically is that when you are creating a data frame with pandas as opposed to when you're creating a data frame with Apache Spark, there is a difference. So when you're creating a data frame using the Apache Spark libraries or API, what happens is the data frame is optimized for big data. So the data could be spread across multiple nodes. The data frame will pick all of the data up. It will pick the data up from all of the 6 nodes and give you a combined view of that data. A normal pandas data frame cannot do that. So you can essentially use that data frame like a relational database. You can run SQL queries on it like we are going to be doing today. We are simply going to be importing that data frame, importing that data set using PySpark, and we're going to be running SQL queries on it using PySpark essentially. And yeah, so it is conceptually the same, but there's a fundamental difference that is there are richer optimizations provided when we're dealing with big data when we're using Spark APIs. So the workflow is as follows. You have your raw data. Now, this raw data can be semi-structured or unstructured or even somewhat structured as well. So that is a different case entirely. We're going to be talking about semi-structured or unstructured today. So example of semi-structured would be CSV files or JSON files, where you don't exactly have SQL tables available to you, but you have files in a particular format. Like in CSV files, which is an abbreviation for comma-separated values. All of the files entries all of the files data points are separated by commas. So the comma is a delimiting value that separates all of the data present in your text file. So that is semi-structured because it at least has some structure to it. In unstructured, you can basically write up a random sentence, and that would be your unstructured data because it does not have any order associated to it. It's just a combination of words put in a random order. So that is unstructured because it does not have any structure to it. Say if you have a raw data, unstructured or semi-structured, you use something like Python or you use something like Scala with these Spark APIs. What will happen is when you import it, it will create JVM objects, right? This is the Java virtual machine objects because Spark runs on top of Java. But the libraries are available for Python, R, Java, and Spark. But Spark at a fundamental level is coded in Java, right? So it will create JVM objects. Now, these JVM objects can be treated as RDDs. So these are resilient data sets. And then you can specifically pass a function called the 2df function, and you can convert them into a structured data format. So now this structured data format is in the form of an SQL table, and these are called Spark data frames. And then you can simply run, as you can see over here, you can run Spark SQL queries on these Spark data frames, and it will function in the exact way as an SQL table would, and you'll get your query results. The advantage, why are we not using MySQL? Why are you using Spark? We are using Spark because it is very well optimized for big data, while your MySQL is not at all optimized for big data. So this is the entire reason we are using Spark data frames, that we're not using Python data frames and we are not using MySQL data tables, essentially. So Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So what we are going to be using today, we're going to be using the Spark SQL context with our PySpark libraries, right, today, to analyze the data today. So let's continue. So we're heading on to the demo, but a few quick things before the demo. When we use Spark libraries with Python, the combination is termed as PySpark. There is no such language as PySpark. Basically, you're using Python, but you're using the functions available in the Spark libraries. So that is casually termed as PySpark, but it's simply Python with Spark. And we're going to be using the PySpark in action with the help of Jupyter Notebook, right? So we're going to be executing it. So if you have done Python before, you know what a Jupyter Notebook is in all probability. We're going to be doing just that. So we're going to take us there in R. So one question is being asked, where are the data frames stored? The data frames are stored in the RAM. The data frames are stored in the physical memory temporarily. As long as your Spark job is running, the data frames will be stored in the physical memory, basically. What we are going to be using today for our Jupyter Notebook implementation is Google Colab. So if you know, Google Colab is something like this. You can simply go on to this website and you can start coding in your Jupyter Notebook. You don't need to install anything new. If you're doing some minor things, if you're doing more complex things like big data analytics projects and stuff, then this Google Colab is not recommended in that case. Then in that case, you would use your own system, or you would use something like a cloud system, right? Like your AWS or your Microsoft Azure Databricks or something like that. So since our data set today is going to be small, because we're going to be just demonstrating how Spark works with data sets in general, we're going to be using Google Colab. You can do the exact same thing with Google Colab as well. Right. You can take a screenshot and you can essentially enter it, all of it over here. So the first thing, I have written down some statements beforehand. So these are statements that help us set up our PySpark session. So since writing all of this by hand would have taken a lot of unnecessary time, we have simply written it down beforehand. So the first thing that we obviously have to do, you need to have Java installed onto your system. So the first thing that we did was install Java, open JDK 8. JDK 8 is the version that is compatible with Hadoop, and it is the version that is compatible with Apache Spark as well. So make sure you have JDK 8 installed onto your system. And then we have simply provided the link to the library of Spark that we are going to be using, which is the Spark 2.4.7, which is compatible with Hadoop 2.7. So this is what we're using. Although this is not the latest version of Spark, the latest version of Spark is Spark 3, but we're using 2.4.7 because in my opinion, it is the most stable version of Spark, right? And then we've extracted it, and then we've simply installed Find Spark. Now, Find Spark is a tool that helps Python find out that a Spark framework exists on the system. So when you install Find Spark, it will basically initiate a session with the Spark libraries. So we're going to be using that as well. The next thing that I have done, first I'll play this so that this actually executes first. So it will take some time to actually happen. There's a question, do we need any Java knowledge for this operation? No, not at all. You do not need any Java knowledge. You can get started with R, you can get started with Python, you can get started with Scala. Without having any developmental knowledge, you can simply write these simple statements that are used for data analytics. You don't need to actually develop an application or anything. All of those things happen. You can simply execute your big data queries. Even if you're coming from a normal MySQL background, your normal SQL background, essentially, you can still get into PySpark because PySpark helps you with the SQL context, which we are going to be using today. So aside from some commands in PySpark, you do not need to learn anything new. So you can use SQL context with PySpark, and you simply write SQL commands and it will still execute what you want it to execute. So this takes some time because we're downloading a lot of things. Once the download has been completed, this will simply stop rotating over here, this buffering sign that we're getting. SQL, yes, SQL is necessary. So if you're getting into data analytics, right, you need to have clear understanding of SQL. Even if you're doing normal data science with Python, a SQL knowledge will always help and it is one of the most universally known languages, SQL. So even if there is a language barrier, somebody uses R, somebody uses Python, but it is a general trend in the data analytics slash data science community to know SQL. So that is a common place for every data scientist and data analytics expert. SQL is something that I would recommend you all to understand very, very carefully and very nicely. On top of other language. So for somebody who's somebody who's specifically dealing with machine learning, right? Then I think SQL is not as important, but still SQL is very easy to learn. I think everybody should learn it because sometimes the use case for SQL will always pop up. In a professional environment, in a personal environment, if you're doing a personal project, there might be some use of SQL that will always pop up. So it's always handy to know. You don't need to learn it. You can simply Google it and search for the material online as to what you have to do. But you need to be comfortable with it. You shouldn't ignore it, essentially, is what I'm saying. Okay, this has executed. Now we will set the paths. So setting the paths in my temporary Google Colab. So I've set the paths, right? And then I'll simply start my Spark session. So I have imported find Spark similar to the manner you will import it in Python. And then I've simply initiated the location and the name of what I'm actually going to be using. The Spark home has been configured, and I'm going to be using find Spark init to initialize that. And then after the find Spark has been initialized, we have our PySpark available to us. And from PySpark.sql, we're going to be importing the Spark session, and we're going to be starting our Spark session. The variable will be Spark. These are very complicated terms. So do not confuse yourself with all of this. If you decide to get on with the course, if you decide to get into the course, all of this will be very clear to you. But for now, we're only looking at how to data analyze, right? So let us just generate the session. So once we play that, it will take some time, but it will start up our session, right? So I'm getting a lot of, some people are from a machine learning background and some people are coming from their data science background. So they're asking as in what sort of knowledge base do they need to have in big data when they're basically going on with their machine learning and deep learning and whatever. So it is a general, if you're from a data analytics background, right? So if you're implementing something like machine learning or deep learning or artificial intelligence or data science, you all must be familiar with the fact that data sets really matter. The data should be really good. And the more data that you have, the more clean data that you have, the better will be your machine learning model, the better will be your artificially intelligent system, and the better will be your insight that you get from your data science project. Right? So it depends on the quantity and quality of data. So big data as a technology that if you learn big data, if you understand how big data works, you can integrate it with machine learning. Right? Once you integrate it with machine learning, you can create even more accurate, like pinpoint accurate machine learning models. So the big data knowledge in the machine learning environment and the data science environment is extremely helpful. So I will recommend everybody who is in the machine learning and deep learning environment to enhance your skills by understanding how to use big data sets. We see Hadoop in the code, any info on that. So if you're seeing Hadoop in this code, so that is simply the file name. We're not actually using any Hadoop particular statements. We're not using Hadoop libraries. We're using Spark libraries. Spark essentially runs on top of a Hadoop framework. So, but we are using Spark. We're not using Hadoop library. Okay. So the next thing I would do is show you how data frames work. So I'll simply use the Spark session to create a data frame. It will create a data frame essentially where we're only seeing the top 3 rows of a data frame that has the column name hello, and all of the values corresponding to that column name are world, up to a range of 1,000, right? So we're only seeing the top 3 rows. But if we simply remove this and put it into 100, we'll see world, up until 100 records, essentially. So let us continue now. So the next thing that I'm going to do is actually I'm going to be importing a file that I have personally on my system, and I'm going to be analyzing that. So the topic for today is analyzing data from different sources. So I'll tell you how to especially access those different sources. So I'm going to be accessing something from my own file system, and I'm going to be putting it on the Google Drive file system, and then we are going to be analyzing. So first thing, Google Colab helps you with this library where you can import files when you're using their platform. So I'll simply play this and it will simply pop up a screen. I'll get a screen and I can choose a file that I want to upload. So I have this data set called sudo facebook.csv, right? So we're going to be using that. So once I click that, the file will be uploaded. We'll see when it's uploaded 100%. Now, right now it's a 2% upload. So once it has been uploaded 100%, we can carry on with our next statement. So it takes some time to actually download, upload. It's a file that is 7,000 bytes. So that is about 5 megabytes. So yeah, it has been uploaded 100%. The file is there, and this will start executing in a minute. Once the stops executing, we'll execute our SQL statements with PySpark. So yeah, our statement has finished executing. We have successfully put our file onto our Google file system, and now we'll simply create a code block and start with our programming or data analysis. Not programming, essentially data analysis. The first thing that I'm going to do is create a data frame. So I'll call this df again and equate it to spark.read.format. The first thing that I need to specify is the format. So format of the file is CSV option. So I'm going to be adding a few options. Firstly, I want to include the headers because the CSV file has headers. So the column names essentially are headers. So I'm going to put that value to true, that yes, my file does have headers. Use the headers. So these are more technical aspects, particularly related to if we are actually accessing this entire data set as a schema. So yes, I want to do that. So I'm putting that value as true. And then we're going to put a data mode, which is going to be fail fast. So in case of any data loss, the data is going to be replicated and recovered. So put that into fail fast mode and load, and then we have to provide the location. So the location is the present working directory. Since we've already uploaded the file, we simply need to write the file name. So that does that. I think we should be good to go. Yeah. So we can play this and it will create our data frame out of the file present in the Google file directory. Yes, it has played successfully. And if we simply write something like df.show and put in something like 3, we get our output. So we can see how the data frame looks like. So the first column name is the user ID, which is the unique identification number of each individual on Facebook. We have the age of that individual. We have 14, which is the age. 13, I think, is the minimum minimum age limit for Facebook. So we have ages 14. We have the date of birth of that individual. We have the gender. We have the number of days the person has been on Facebook. We have friends count, right? We have the friendships that person has initiated. So the friend requests that the person has sent. We have the amount of likes that the person has made. We have the amount of likes that have been received by that person. And all of this data has been divided into 4 more columns, which is how many of these likes are on mobile devices and how many of these likes are on web browsers. So we have a very definitive data set for Facebook, and we can perform a whole lot of analytics, like real case analytics with this data. So I'm going to show you just that. So one of the questions that I'm getting is, what are the other file formats except CSV? Okay. So you can use JSON as well. You can use other things as well. Say you have packet files. Essentially, you can use packet files. Essentially, Spark with Spark, even if there is not a preset file format that is available to you, like when you write spark.read.format CSV, and whatever file format that you may personally have does not exist in the Spark libraries, there's not an issue for that as well. You can also use surds. With surds, you can also import your custom file formats as well into your data frames. So that is pretty flexible with Spark. If you do a little bit research or you're guided in the correct direction, you can implement that pretty easily. So it's not limited to CSV. All right, so let me continue. Okay, so a lot of things we can do with this data. First thing that I want to do before I actually start executing SQL statements, right, is I want to create a temporary view for this particular data frame, so that I can access that name with my SQL queries. So the first thing that you have to do is register this data frame. So create or replace temp view, and whatever name I put in here within these double quotes, this would be the name that I would refer to it when I'm using the Spark SQL context, right? So the name that I'm going to call it is Facebook data, and then I'm going to simply play this. So yes, we've successfully created our temporary view. So what are we going to do now? Now it gets really simple, especially for people who are coming from an SQL background. This can get really simple now. See, the only part of PySpark that you needed to know, especially in the case of SQL context when using with PySpark, is up until now. From now on, it is a simple Spark.SQL, and whatever query you put in these double quotes using the table name Facebook data, it will execute and give you that exact output. So this could be 5 MBs of data, this could be 5 GBs of data, and this could be 5 terabytes of data. The exact same procedure will be followed for all of those. So now you can see how Python is advantageous when we're using big data with Python, right? Because you are not essentially learning any new languages, right? You're not essentially learning Scala. You know Python, and you can simply execute all of this with Python as well, right? So Spark SQL, put in something like select, and say I want to count the number of rows, the number of people who've registered on Facebook. I want to count the number, right? So I can write simple count, put in an asterisk over there, right? So this will count all of the rows, right? And I want to get in the table name, which is Facebook data. So once I've done that, if I simply put in a dot show and bracket open, bracket close, right? So this particular function will execute this query and give me the output. So we can see now that we are getting our output, which is 99,003. These are the number of records available in this data set. And that is exactly what we're getting, right? So you can see how advantageous this gets. If the number of records was 1 million or 2 million or 3 million, and you have a big data cluster available to you, you have PySpark.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is a module for structured data processing? A. GraphX, B. mlib, C. Spark SQL, D. Spark R. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Installed on that big data cluster, right? And you can simply call in the Spark API and do this with Python itself. This normally you couldn't have done with a Pandas data frame. You can do it with a Spark data frame using Python. So this is the advantage of using Spark SQL or PySpark, essentially. Not Spark SQL, but PySpark. All right. So let me do something now. Let me find out the average age of male users and the average age of female users, similar to what you would get as your employer would ask you to find this out for a marketing campaign or something, right? So select SQL, and then what we will do is use our SQL knowledge to it. So we will find out average age. I think age is the correct column name, which is age over here, right? Yeah, that's correct. Average age, and then we will put in gender. So because we're going to grouping it by gender, right? So once we grouping it, once we put in the from Facebook data over here, we put in that, and then the next thing that we can do is group it by gender, so that we get the average age for the male gender, the average age for the female gender, and the average age for the non-disclosed gender as well. So dot show, put in a double bracket and play this, and this will execute what it needs to execute. So we can see. So in the averages, we can see that the gender, okay, that is pretty high age. Did not expect that, but okay. The average age for the people who have not disclosed their ages is 74 years. The average age for the female Facebook user is 39 years, and the average age for the male user is 35. So yeah, that was not the answer that I was expecting, but that is the case with data analytics. You run these use cases on it and you get that appropriate output. So we generally know that people in the mid ages are generally more active on Facebook, create more accounts on Facebook. So it has lost sort of that earlier on when, say, we were dealing with the entry times of Facebook, right? Essentially, where younger people were generally more on Facebook. Now we have transitioned from Facebook. Younger people have transitioned from Facebook to Instagram. Right now, people in their 30s to their 40s and 50s are generally creating more accounts on Facebook. So it gives us a lot of insight which relates to gender dynamics and age dynamics when we're talking over these particular things. So let me do something else. What if I do something like spark.sql? So we'll find out the average number of friends per gender as well. So let us see which gender at an average has the most amount of friends when we're talking about Facebook accounts in general. So average, we'll see over here, which is the friend underscore count. So friend underscore count, right? Just a moment, we don't have to put a double quotes over there. Yeah, so friend underscore count, and then we put in a gender over here and from Facebook data and group it by gender as well and show, and we play that up and we can see the average friend count for each of these genders. So we can see at an average, the people from a non-disclosed gender have 184, females have 241, and males have 165 friends at an average on Facebook. So let me look at some of the queries. All right. Sanjeev is asking, can we run a function or stored procedure? Absolutely. So that is the advantage that you get with Python. Since Python is a developmental language, definitely you can do a lot of things that you cannot do with SQL when you're using Python. So you get the advantages of Python, you get the advantages of big data technologies, and you get the advantages of SQL. The simplicity of SQL, the reusability factor of Python, and essentially the big data optimizations for your Spark. So you get all of those things in one package itself. So that is the advantage of PySpark. You can write all of this in a function and it'll execute it. You can pass the data frame in a function attribute and it'll execute it in the same way. So you can see how easy it gets. These are all essentially objects. You're passing objects and functions, and objects are treated as objects as such. So no issues with that. Let me look at some other. So one question is, what will happen if we read this data with pandas? So first of all, this data, particularly with pandas, you can absolutely execute because this is only 5 megabytes of data, right? It's not a large amount of data. But say if you have data which is upwards of 1 terabyte, right? You don't have enough RAM on your system to be executing your particular query. If it does not give an error for some reason due to some optimization that you may have put in, it will certainly take a lot of time to execute. So you cannot do this with pandas for big data sets. That is certainly not recommended. Spark SQL, yes. So one question is Spark SQL also useful with Scala? Yes. You can use Spark SQL with Scala just as well as you can use it with R, or as you can use it with Python. So it's pretty easy to use with all of that. You can also use particular things that are exclusive to these languages. Scala might have some exclusive attributes and Python might have some exclusive attributes. So you can combine the abilities of matplotlib, so to speak. So if you have something like matplotlib in Python, you can combine the usability from matplotlib with your PySpark code, and you can essentially chart your data sets as well. So that is another advantage that you get with when we're talking about PySpark.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.
Right, so yeah, you get that advantage with R as well, and with Scala not as much. So you have to assess essentially what your use case is. You have to assess that, and you can do it accordingly. So there are also machine learning libraries available with PySpark. So Spark mlib, you can simply use your Python, which you are very familiar with when you're dealing with machine learning, and you can implement the combination of Spark's mlib with Python, and you can create your machine learning models as well. So that is pretty easy as well. do not need to learn anything new, just new functions, nothing else. Let's look at some other doubts. So one question is being asked, what engine is the SQL context using? So yeah, a common misconception might occur, which says that we using an SQL server over here, or are we using simple Spark? So we are not using an SQL server here. What the SQL context that we are using, this particular aspect that I just imported over here, you can see the PySpark.sql that I'm using, right? It's simply an extension of Spark. It's not at all related to any sort of relational databases. So we are mimicking how SQL runs like. We are mimicking it. We are not actually using any SQL databases, or we're not using any SQL libraries. We're mimicking the functionality of SQL. So Spark basically helps people to use simple SQL commands with Spark. We are using the Spark engine to execute all of this. We're not using any SQL related, actual SQL, we're not using any of that. All right. So we can see that, and let us continue now. So all of this minded that whenever I close this particular tab, right? Whenever I close this tab, all of this data will be lost, right? In SQL, it wouldn't have been lost. It would have remained there in the relational database. But in this particular case, the data will be lost because it's a temporary. It's stored in the RAM. It's stored in the RAM of this particular Google Colab instance. And once I close this, the data will be lost. Right. So say let us do something else other than that. Right. Spark.sql, and let us find out at an average what can we find out. Let me look at it over here. So let us find the amount of users on Facebook. Do they use mobile phones more, or do they use computer devices more, right? Do they use desktops more or laptops more to access Facebook? So this is something that is also possible. The logic for that is I can simply see the mobile likes, and I can simply see the www likes, and compare both of these, and we can simply evaluate from that whether a person is using mobile phones more, or whether a person is using their browsers more, like their computer browsers more. So how do we go about that? Select mobile like, and that's that. Mobile likes. Okay, mobile likes. Select www underscore likes. Okay, and we can simply put an average over here as well. So do that, and from Facebook data, forgot to put in a double quote over here. That is important. Because you're essentially passing an SQL command, right? That is what you're doing. That is why you need to pass it as a string instead of something that is inbuilt in, say, PySpark. And we can also add a few more things to it. Let me think what we can do over here. So let us put some age demographic onto it. So let us find out this particular thing where age is greater than equals to 13 and age is less than equals to 35, right? And we can do that, and that is how SQL functions. And we close that up, put in a dot show over there, bracket open, bracket close, and we clear that up. So we get this particular data from this particular age demographic, which is 13 to 35, right? So in the people who are 13 to 35, we can see that at an average, there are 113 likes per account, and at an average for the web browser, for the computer web browser, there are 45 likes per account, right? So this basically shows that people use mobile phones more than how much they use web browsers, because obviously mobile phones are more handy, right? But let me see if as we get to a higher age demographic, does it change? Right. So I think it's not going to change, because I think people from all age demographics tend to use mobile phones more today. But let me confirm that. That is what data analytics is all about. And given a age demographic that is above 35, and we put a play over there, so we can see that it's the same, except obviously the activity is a lot less, but it's the same. 94 likes per mobile device, not mobile device, per account. On the mobile, and 57 likes per account on the web browser. So we can see that. So one question is regarding if we have Hive HBase, then why Spark SQL? Because we run Spark on top of Hadoop. So Hive and HBase are generally run on top of Hadoop as well. In fact, Hive absolutely needs Hadoop to run. Hive uses MapReduce to execute. It does not execute without using MapReduce. So whenever you run a query that is complicated, that is not simple select query, right? If you're actually analyzing the data, if you're actually performing some sort of evaluation or querying in that actual statement, then you have to use MapReduce to execute that. Hive functions on MapReduce, even edge-based. So that is why Spark SQL is faster than Spark is essentially faster than MapReduce. That is why we're using Spark SQL instead of using Hive. So generally, that is the practice. It depends on how much RAM you have. If you don't have much RAM, you'll use Hive. If you have RAM, you'll use SQL. Not SQL, Spark. All right. So one question again, I'm being asked. It's a how do we read the data with pandas? So yes, you can read the data with pandas. It will most probably give you an error. So, I think I made it clear. If the data is of a larger size, a very large data size, that is greater than your RAM, much greater than your RAM, your computer will not be able to deal with it. It will most probably throw an error. If it does not, it will take forever to do it. So yeah, all right. So we've done that, and similar to that, we can perform other queries as well. So we do something else. We've taken out averages a lot. What else can we do with this data? Just a moment, guys. Short. Let us just simply find out the trend of age and friends count as well before our course advisor joins us. Okay, so let's continue with that. Sorry for the delay. Just a moment. Do I need to do I need to code every time I lose the session, right? So you don't need to do that. So with that is the thing with about using these frameworks, like you have your Google Colab over there, or you're using some sort of an offline Jupyter notebook, or if you're using scripts, like you're writing some script in Sublime Text or Atom or Visual Studio Code, you write that script, right? What I mean by runtime over here is that during the execution of the statements, right? That is the runtime. And if I simply end the session right now, the data that is being stored in the RAM of this particular instance will be lost. These statements will not be lost. I'll have to simply play them once again. So say if I close this particular session right now, if I click on the close button, if I come back and I simply don't play all of this, if I don't play this, if I don't play this, if I don't play this in sequence, and if I simply directly go over here and play this, right, it will not run. I'll have to play this in a sequence for this to actually get into an active session and have the data in the RAM. We have our data frame initiated over here, and we have our temporary view created over here. We need to do all of this before we can actually run this particular statement. Is what I mean by not losing this. Is what I mean by losing the data when I lose the session. Because in Spark, the data is stored in the RAM. It is not stored in the hard drive. So make sure if you're using something like Google Colab that you don't end your session if you still have some queries to go with. Otherwise, you'll have to go through the hassle of running it all over again. So yeah, all right. So what else can we do with the data? So let us see. I think we pretty much understand the gist of it. I think we've pretty much gone through the gist of how all of this functions, right? You can run anything in a normal SQL format. There are a lot of functions that you can run, not just the average function, something like Spark.SQL. So if you're familiar with SQL, you know all of these. So select, how do we go about it? What if we do something like friend underscore count, and we simply do something like user, I think, ID. So user ID, yes, underscore count user ID from Facebook data, order by, and we put something like friend count, right? We do that and we put a show over here. I think this should run. This will put it in ascending order of friend count and user ID. I think if we put a DESC over here, I don't know if it's before the friend count or after the friend count, but I'll play this just to see. So if we put it in DESC, so we can see that the maximum friends that a person has, at least in this data set, is 4,923. And that is of this particular user ID. So we can also do that. We can sort the data as well. And you can understand how long it would take to sort this data if we are simply dealing with vanilla scripts vanilla systems. And when you're using Spark, you essentially have your data divided into multiple, multiple nodes, multiple blocks. All of those nodes will execute their respective blocks, and the data will be sorted in a much faster manner, right? Because you're essentially doing a form of parallel sorting, and then all of the data is combined at the end and aggregated, and then you get your sorted data. So you can imagine sorting is a very expensive task, and how long it would have taken to do this for a terabyte worth of data if we were simply using pandas for that. So we can see how it functions. Let me see something else. We can also use something like sum. So I simply put it over here and put in Spark.sql and select some friend count from Facebook data. So put that over there and show it, and we play it. We can see that the sum of the friend count is 194, 39317. So we calculated that pretty much instantly. So firstly, let us understand the initial solution that was created to deal with the big data problem. So obviously, if you're dealing with terabytes to petabytes of data, even the best of computers and laptops today, the inbuilt storage size is like maximum that you get is 1 terabyte in laptops, and then if you have a computer or a desktop, you can upgrade it to 2 terabytes. But for a general consumer, that is all you get. Like 500 gigabytes to 1 terabyte is the general trend that you get for today, right? So that is what there is. So definitely you cannot take this 1 terabyte of data and put it entirely on your computer and then hope to analyze it in a reasonable amount of time. So that is where Hadoop came in. Hadoop is a framework that was developed in Java to deal with the big data issue. So how Hadoop solves this problem is quite interesting, actually. What Hadoop does is it takes a computer network, and there are a lot of computers that are attached together in a computer network, right? So there's a server and there are LAN wires, and all of those computers are connected to LAN wires, and essentially you're creating a network. So what Hadoop did was it found a way to coordinate all of those computers together to deal with the big data problem. So that means a certain area, a certain portion of the hard drive of each of those computers was reserved, and when it was reserved, uh, it basically accounted for the HDFS, which is the Hadoop distributed file system. So all of these computers act together to store this data. So whenever data comes in to the HDFS or the Hadoop server, it gets divided automatically and is stored across all of these computers in an equal distribution to be able to deal with the size issue. So 1 terabyte of data gets divided into, say, blocks of 50 gigabytes of data, and 150 gigabyte block is sent into one computer, and so on to the next, and so on to the next. So that is how you solve the storage issue, by dividing that data. So very large files in this context means the files that are of hundreds of gigabytes, terabytes, petabytes in size. Streaming data access, each analysis of the dataset involves a large portion of the dataset. So the time to read the whole dataset is more important. Latency that is required to deal with the first record. So that essentially means that you need a solution that minimizes the input-output delay while analyzing the data. So if the data is coming in, you need to be analyzing it at a really high pace to be able to deal with such a large amount of data. And then commodity hardware. Hadoop is designed to run on clusters of commodity hardware. Now, commodity hardware means that you have two options to run Hadoop. Earlier, hardware was really expensive. So buying expensive server rooms and server farms to store inside your office and run your Hadoop server on would have been really expensive. What they came up with is that you can simply use the computers that you use in your office as contributors towards your HDFS server. So that is what commodity hardware means. Without buying anything new, you're essentially using the workstations that are present in your own office space to be able to contribute to your HDFS server by dedicating a certain amount of hard drive space and processing power to your HDFS and Hadoop server. So let me look at some doubts related to Hadoop in general. So firstly, I'm getting is the first doubt that I'm getting is what is MapReduce? So we're going to be actually understanding what MapReduce is briefly, because that is not the point of today's video. We're going to be understanding Spark, but I'll just tell you what MapReduce is briefly. Firstly, this is what the HDFS is. HDFS is the solution of Hadoop for storing data. Now, this is not for processing data. This is for storing data, right? You store using the division method by dividing the file into blocks and storing it across various nodes in your computer network. That is also called a Hadoop cluster, by the way, or a big data cluster. Secondly, we have the second component of Hadoop, which was developed for processing. Now you have all of this data stored in your Hadoop or big data cluster. How do you process it? So for that also, Hadoop had a second component, the processing component or the processing framework called MapReduce, right? So Hadoop is capable of running MapReduce programs with various languages, as you can see, Java, Ruby, Python, C++. So for Java, you get Hadoop libraries. If Hadoop is already installed onto your computer or the server that is required to run it, the libraries are already there present, and you can simply import those libraries in your Java code and implement it accordingly. And you can basically create a program that uses all of the nodes that are present or some of the nodes that are present in your big data cluster, run in synchronicity, run in parallel to be able to execute all of those blocks parallelly, whatever job you are performing on that data. So instead of having that data run in a sequential manner where it will take days to maybe months to analyze that huge amount of data, you're simply analyzing each block of data on that respective node in parallel, reducing the time exponentially. So that is the advantage of MapReduce that you get, the processing element. So let us look at the architecture of the HDFS and how MapReduce would actually operate on it, right? So the architecture is quite simple. So imagine generally the big data clusters in big organizations have hundreds to thousands of nodes attached together. Here we're only talking about 4 nodes, just so you guys can understand what I'm actually talking about here. So firstly, there is the name node. Now, the name nodes could be multiple, the data nodes could be multiple. There's no limitation that the name node should only be one node. It could be multiple nodes, right? So what happens is you'll take the computer that has the most, that is the weakest essentially, and you'll make it the name node. And you'll take 3 average performance computers as data nodes, right? So whenever you're coming in as a client to that particular HDFS or big data cluster, you'll start to upload a file, say it's a terabyte file, right? And you're starting to upload it. So what will happen is you'll first contact the name node. The name node will then see which data nodes have the space. So it will check which particular hard drives in the data node have the space to store that data. So firstly, it will determine which data nodes you're going to be storing your data on. Then it will basically communicate the block size. So the data will automatically be divided into the blocks of that size, whatever block size you've set, and then it will get started to store on the data nodes one by one. So the first block, say the green block, as you can see, they are colorized as well. The first block, let us say the green block, goes on the first data node, and then the orange sort of block goes on the second data node, right? And the third, the red block goes on the third data node. So imagine that, right? There are also 2 other colored blocks. I'm going to be explaining what that means in a second. So imagine you've divided into green, and orange went over here and red went over here, right? So whenever MapReduce programs run on the Hadoop cluster, the green block will be executed in data node 1, the orange block will be executed in data node 2, and the red block will be executed in data node 3, minimizing the time by 3. So it will basically divide the time by 3. So, and the next thing that HDFS helps you implement, now this is not that prominent as we're only using 3 data nodes, right? If there were 100, then it would make sense. Say you set the replication factor to 2, right? So the replication factor essentially is a solution that helps you deal with data loss. So say data node 1 fails, it goes bad or some hardware failure occurs. So you don't want to completely lose the green block, right? You don't want to lose the green block because that is just a part of the data that you don't want to lose. So HDFS, depending on the replication factor that you've set in your HDFS, if it's 2, the green block will be replicated 2 times. So it will be replicated on data node 2 and it will be replicated on data node 3 as well. And if there are replication factors 3, if there is another data node, it will be replicated on that data node as well, right? So even if data node 1 fails, you still have access to data node, the particular block that's green. So similarly, data is also replicated, whatever blocks are put on the data node. So say then you uploaded the file on the data nodes, the client comes in to read the file. right? He wants to access that file that you've just uploaded, the other client that wants to read it. So what will happen is he'll be automatically connected. Once he contacts the name node, he'll be automatically connected to the data node that is the closest to him. So minimize latency essentially. So if data node if this is in say for example Los Angeles, and this data node is in say New York, they are all connected together for some reason if they are not closely located for that matter. So if this person is in New York, he'll be getting access to this data node because that is the closest to him, right? If all of the data nodes are present in one location, so in that case, it doesn't really matter in that manner. So the name node is storing where the data begins and where the data blocks end. The name node is storing that information, the data of the data, the metadata. So it will store where the green block is, how many times it has been replicated, and where the replicated blocks are, right? So that is what the name node will store. So in that manner, the HDFS essentially runs in a very conjunctive sort of way where everything is organized and stuff. Can we integrate Hadoop with Azure, or it needs Linux system? You can easily integrate with Azure. Azure has a service altogether for that particular aspect. So firstly, Azure, you can use Databricks with Azure. Azure is a Microsoft cloud service for those of you who don't know. You can use Databricks with Azure. And it has all of the cluster computing elements already built in without you having to install anything. Okay, MapReduce runs on the same Hadoop cluster that stores the data using the nodes to process in parallel. Yes, it does that. So the server, what is this? The next question that I have. Using MapReduce for storing huge data, so that using server is reduced or not. So see, in today's day and age, server technology is really cheap. So when Hadoop was developed originally, servers were really expensive. So servers are really cheap now. They're not as expensive as they used to be. So earlier when this was made, servers were really expensive, but now we can use servers as well, server rooms as well to use Hadoop with, right? So it's not an issue. It's up to you. It's up to the financial status that your organization has and how much usage you have for that particular technology that determines whether you will buy a server or not for Hadoop. All right. So let us continue now.
Test your knowledge of Spark by answering this question. Which of the following is a basic abstraction of Spark streaming? A. Shared variable. B. RDD. C. DStream. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We're going to be analyzing a Facebook data set, right? It's not that big of a data set because I'm not going to be uploading a terabyte data set on the Google servers or the Google Colab, right? But when you're dealing with this at an industry level, it is almost the same procedure. You only have to deal with the providing the link to that data, and Hadoop manages everything. The HDFS manages everything on its own. So you don't have to really deal with all of the blocks of data. It all happens seamlessly. So let us go to the Chrome tab that I have open. So I currently have my Chrome tab open over here, right? So I've already written some things down. So this is what is required to actually start up this particular process, right? So if you sign up for the course or something that we have, you'll get access to this particular code, but it's easily available as well online in this particular regard. So the first thing that you will obviously need is Java 8, right? So Java 8 is something that is a prerequisite for Hadoop. So if you're having HDFS on your system, you need this particular implementation. And if you're running Spark on your system as well, you also need Java 8 because Spark essentially uses JVM objects, right? So you need Java installed. So that is why I've installed Java. And then I've installed my Spark, right? My Spark and Hadoop combination over here. So that is a link that keeps changing from time to time depending on the repository. And then I've extracted it, and then I've installed PySpark, which helps us integrate Python with Spark, right? I've set up some environments for my Java and my Spark so that I'm able to access it. And then I have started with my Python code. So firstly, I've imported PySpark. So we've connected our Python with our Spark by initializing the PySpark module. And then I have imported one module that we're going to be needing for our session today, which is the PySpark.sql module, where we're going to be writing some SQL code within the vicinity of PySpark. So the first thing that I would do is initialize my Spark session, right? So we need to initialize Spark sessions before we actually use the Spark variable, right? So I'll be uploading my data set with the Google Colab implementation. So firstly, I'll play this. Actually, I have to play this from the start. So I'll be playing that firstly. So it takes some time because it connects to the Google servers, and then we are able to do that. So the website is collab.research.google.com. If you go there and type anything, you'll be able to do it. You'll be able to create your own Jupyter notebook. So this is essentially an implementation of the Jupyter notebook that we have. So it takes some time for it to download. Let's wait for that. One question that I'm getting, a pretty interesting question. Where are you running this? Is this on a Hadoop cluster? So Spark does not need a HDFS storage system to run, but it works. It is compatible with an HDFS storage system. The advantage that you get with Spark, you can use Amazon S3 as storage as well. You can use your own file system as storage as well. But if you have HDFS installed onto your system, right, which we do have when we're dealing with big data clusters, you can also use HDFS with it. So I'll tell you where the difference happens. It's not that much. Depending on the link that you have of the file, it will automatically pick up that file from that location. Whether it's in the HDFS or the actual file system that you have or a Amazon S3 cloud link, it does not matter. Let me run. It actually takes some time. So sorry to keep you guys waiting. I'll just pause this one for the time being. All right, so I'll play this firstly. The problem that you have with Google Colab in specific is that every time you start the notebook again, you have to run the commands again. So it's not like you are getting access to an already built Linux system. So every time you start Google Colab, you're actually initiating a Linux sort of cloud, right? So you have to install all these things again. It's good for practice, I would say, but it's not good for actual development purposes. Yeah, so we've successfully run the first block. Now we will set up the environment. This will take no time, and we'll initiate the Spark session, right? That will also not take any time. So firstly, I'll upload the file. So it asks me an option to, when I type files.upload, it asks me an option to select the file that I want. So I want this Facebook data set. So I click on that. And once I've clicked on that, Google will automatically put it into the drive, and then I'll get the access to it. So 12% done. So here you can see the percentage. So is this building a Spark cluster for you? No, it's not actually. There's not a cluster involved. It's a single node cluster, if you may speak. So if you, it's basically like you're installing Spark on one system and it's emulating a cluster. Because I'm not actually dealing with actual big data where we have terabytes to petabytes of data, so it's not actually going to cause us any performance issues. But we're dealing with a single node Spark cluster. If we had multiple nodes and we had Spark installed on multiple nodes together with the HDFS underlying storage system, we could have used it with multiple systems as well. So 59% done. It takes some time. Let us finish with that. So meanwhile, I can write some other code as well on the bottom. So we'll just go ahead and do that just a moment. Yeah. So firstly, while this is uploading, let me type in some code, right? Meanwhile, any doubts if you guys have, you guys can ask regarding this technology or what we're doing right now. So generally what you get with big data is if you're dealing with organizations, right? Organizations obviously want to boost their businesses and the way to boost their businesses is through marketing. So the marketing is the number one thing that actually is the success key for businesses, right? So a lot of these organizations are online, like Amazon, like Google, and they have large user bases, like enormous user bases. And all of these users have data sets. They are generating data almost on a day-to-day basis. So if you go on Amazon, Amazon knows what you like. Amazon has idea about how many stars you've given to its products. So all of that data Amazon has. So what Amazon will do is give that data to the big data analyst, and the big data analyst will basically answer some questions, find some information out of that data, give that visualize that data, or basically summarize or document that data and give it to the marketing team. And then the marketing team or the sales team can make their pitch based on it, or make their marketing strategy based on it to maximize profits, right? If you're dealing with a data science team, you can forward that information to the data science team. The data science team and the machine learning team can implement models based on that data to be able to create recommendation engines and properly recommend the customer, know what the customer likes, right? So that is how all of that works. So firstly, we'll create the data frame out of this data set. So df is what we'll call the data frame, and it's like a Python variable. Df will be like a Python object. Df equals to spark.read.format. So we'll specify the format that we actually want our file to be. So currently what we're importing is a CSV file, which is a comma separated value file. As you can see, facebook.csv, right? And we want to include the headers because the data set that we are dealing with has headers. So the first row of the data set is the header name, and we'll put it to true. So the header status is true. Yes, we want to include the headers. Option infer schema. So infer schema, and when we put it to true, what it will do is it will automatically detect the data types of the values. So it will create columns based on those data types. So if it's a numeric 1, 2, 3, 4 column, then it will assign an integer to it. And if it's a name-based columns, then it will assign string to it. So the next thing that we'll do is mode will be fail fast. So if there are any exceptions, it will automatically be detected. And then load. Then finally, this is the part what I was telling earlier on, that no matter where you have your data, you'll simply put in the location here. So if you have data present in the HDFS, you'll do something like this, and given the location. If you have data present in the directory, the present working directory, then you're simply given the file name. So I'll copy the file name, put it over here. So, and then I'll click on play. So when that play starts executing, we'll have our data in our location, right? So just to confirm, first thing that I'll do is actually create a temporary view out of this data and put this data frame in the Spark SQL context, right? So first thing that I'll do over here is type in, what was it? Create or replace temp view, right? So the other advantage that you get with using Python is also get this auto recommendation thing, right? You can get all of the details of that particular function that you're using. That is not the case that is possible when you're using Scala sort of the command line libraries, right? If you're doing this from the command line, it will be a lot difficult for you if there is any error or anything. I'll assign the name. Let us call this FB because FB is short for Facebook, and we'll click on pay. So what will essentially happen now, this FB name is what we are going to be referring to DF in the Spark SQL context. So Spark will create a virtual SQL environment, right? Virtual SQL environment means that there's not an actual database that we have installed. We don't have a MySQL database, but Spark will mimic an SQL environment. It has created a virtual environment in which this data frame is going to be considered as an SQL table. So that is what we are calling this virtual table as, like FB. So code, let us see how this looks. Spark.sql. You simply have to type that and type in the normal SQL statements. Select asterisk from the table name that we've just assigned it, FB, and put it in a dot show, bracket open, bracket close, and then we click on play. It'll actually give us the data set as we can see, right? So keep in mind that this is something really convenient if you're coming from a database management background, right? You can see these are the only new commands that you essentially have to deal with a little bit of Python. And after you've done the steps until here, if you're using simply Spark SQL, if you're not using any sort of complex Python code, right? This is how easily you can get started with big data. So if you're coming from an RDBMS background and if you want to deal with data that is of enormous size, right, and your SQL skills are really good, you can get ahead and basically create your career out of this, right? You can create a career in big data analysis as well. And then you can expand upon it with other knowledge as well as you move ahead with Python, with Scala, or any other technology you've chosen to start your Spark SQL career with, right? So we've done that, and we can see that there's user ID, so the unique primary key number, the age of the Facebook user, the date of birth, the gender, how many days the person has been on Facebook, the friends count that the person has, the friendships that the person has initiated, that means the number of friend requests that the person has sent, the number of likes that the person has, the person has given to other people, the number of likes that the person has received, and this particular number of likes has been divided into mobile likes. So the number of that has been done with mobile phone applications, and the number of that has been done with web browser applications like Google Chrome or Mozilla Firefox, right? So that is also accounted for, right? So let us do some analysis with this data now that we know what the column names are. So it's quite simple to do that as well. Firstly, let us evaluate the average age of a person on Facebook, right? So what you'll do for that is, or we could just, the first thing that we could do definitely is type in spark.sql and open up an inverted comma and pass our SQL query, select count and given an asterisk over there. So this asterisk means we're using all columns, and FB. So when we do that and we type in .show and we click on play, so it will give us all of the count of the columns, count of the rows that are there. So there are about 99,003 records in this particular database, right? So this particular advantage that you get with this is you can simply write .show as a Python function and you'll get your answer, right? There are other things that you can do with this as well. If we go with spark.sql and given another query like select average, and we can give a column name. So for instance, if we want to go with age, we want to find out the average age of a person on Facebook, we'll type an age over there in the average section. And from FB, we put in that and we close this up and type in .show. We do that and we click on play. So it gives us the average age is about 37. So the current average age for an individual on FB based on this limited data set that we have is about 37. So I think it gives us a right rough estimate, right? So say for instance, the marketing team wanted that question out of you. Now they have it. So the advantage of running this with Spark is that no matter the size of the data set, whether it's in terabytes and there are billions and billions of records, you can do it pretty easily, very easily. For this matter, it can happen really fast. If the cluster is big and the processing is happening in parallel on different nodes, this will happen in almost the same time as it happened for me over here. So go on another and we can do some creative things with it. We can also find out the count of males and females and basically do this average age thing as sort of a male female thing. So let us try that. Spark.sql select average age. So once we've selected average age, we also want something that we are going to group this column on. So we want to group this by gender, right? So once we include that column name and we type in from FB. So this is basic SQL, by the way, and type in group by gender. When we do that and type in .show over here, click on play. So it will categorize the average ages by gender, right? So for the gender that is non-disclosed, we have 74. For female, we have 39, and for male, we have 35. So it's double value. It's a double value, by the way, right now. But that is because it's actually calculating average, and average by default is calculated in double. So that is there. So the next thing that we can do something more creative with it. By the way, you guys can ask some doubts, any doubts that you guys have, then I can continue. So I'll wait for like 10 seconds and then continue. If you guys have any doubts, write it in the questions box. All right, so there is one doubt. So the doubt that I'm getting is how does Spark operate in parallel? So Spark actually operates quite simply in parallel. Similar to MapReduce, you're actually installing Spark on all of the devices that are present in your big data cluster, similar to how you would install Hadoop. So say, for instance, you have HDFS already installed on all of the devices. So it's already Hadoop, the Hadoop cluster has already been created. Now your administrating team will come in and they will install Spark on each of these systems, right? So when you go ahead and like over here, when I created this particular data frame, right, and I specified an HDFS address, right? So whenever I specify the HDFS address, it will automatically take all of the blocks that are present across all of the nodes. It will give me a combined view over here, right? So we don't need to concern ourselves with block 1, block 2, block 3, block 4, so on. When we give in the file name, right, it will automatically go to the name node, understand where all of the parts of the files exist. It will import that file in the data frame we don't have to deal with any of the complications. We just have to store the file on the HDFS and we have to import the file using Spark. So that is how easy it is. Will any changes made through Spark be reflected in the original database? No. So this is the advantage with Spark SQL. You're essentially housing this entire data set in your RAM, right? So this is a temporary view of that data set. So here you can make changes, but you can create a new file with it, right? Or you can overwrite the existing file that you have, right? But it's not necessary that any changes that you would create, any data frame changes that you would create will be reflected on the original data frame. In fact, these things, these particular data frames that you create, this DF, is immutable in nature. So immutable means anything that you want to change to this data frame as well, even in the RAM, right? You'll have to create a new data frame out of it. So say if I wanted to alter the value of 106 to something else, you would have to create a sort of new data frame for it, right? If you wanted to add a new column to it or remove one column from it, you have to create something like df2, right? So the way we manage that in Spark, if you want to create new columns in it, is firstly we'll create a new column out of the existing column, and then we'll use garbage collection to remove this column so that we are not actually over our RAM limit, or we're not actually over using our memory, right? So let's continue with that. What else was I talking about? Yeah. So now let's see how this can be integrated with Python pretty easily. So say right here we had the average value like 37, right? What if we didn't want to see this like in a table format? What if we wanted to store it in a Python variable? That is quite easy as well. So say our variable name is X, right? And we want to basically have this data stored in that variable so that we can do further Python operations with it, right? So we do that. We remove the show because we don't actually want to show it over here. The thing that we'll do is type in .collect, right? We type in .collect, and then since this is a table value, right? So this comes automatically in the form of an array, right? So we cannot actually collect it in a single sort of X and expect to see the value as a singular value. So we'll treat it as a two-dimensional array. So anything, any SQL table that you will have in life is sort of a two-dimensional array. So the first would be 0 and the second would be 0 as well. So you're essentially taking the first value, the 0, 0 position value, right? And that when you do that and you click on play, it executes without any issue. And when we click on print, say for instance, X plus 2, right? So when we do that and click on play, so instead of getting 37 and this, you get 39. So I hope that is pretty clear as well. So this is similar to Pandas DF. So one question that I'm getting is this similar to Pandas DF? Yes, this is similar, quite similar to actually Pandas DF. There's not a difference between that. And Pandas DFs are also immutable data frames. They cannot be updated as well. So whenever you're updating a Pandas DF, you're actually also creating a new DF. So yeah, it's in here when you're dealing with Spark SQL, you're actually this particular thing is considered as a Python object, and you can do anything with it. So here we reference it as an array, and we collected the value, and we can do anything else with it as well. So this comes in handy. The collect function comes in handy when we are trying to integrate different Python modules with it, so that we can take that data from Spark SQL and actually implement something with it. So let us do something else with this as well. All right, we'll now continue. So the next thing that we can do is say, for instance, we can find the likes received at an average for a female and a male, right? So that is something that is quite interesting as just curiosity point at an average. What gender receives the most likes on Facebook? So these are the sort of interesting questions that you can answer for your marketing team or your sales team. So average likes underscore received. I think we're correct with the spelling. EI. Always make sure I don't mess that up. And average likes received. And then we copy gender over there and from FP. And what we can do now is something like, I can provide an alias to this. So I can call it average like, right? So I can refer to it as average like instead of something like average age. And then we can do a group by gender and an order by average like, right? So what this will do is it'll also grouping. It'll do the grouping and it'll also do the sorting. So it'll be sorted in ascending order. I'll click on play. So firstly, we have the minimum average like. So that is 67. That is for male. For non-disclosed genders, we have 157. For female, we have the average like of 251. So gives us some demographical data, right? So we get that data out of this. We understand how gender dynamics work on Facebook, what sort of the behavioral personalities of people are on Facebook. We can understand from this these data sets. That is how easy it makes it. And then remember, you'll always have this data in extremely long formats to give you an accurate viewpoint, right? So if you have 10 records of data, it wouldn't actually give you anything specific to go by. But when you have millions and millions of data records, you have a sort of an accurate answer as to how these things work, right? And something else we can do with it, let us do something with age demographics, right? So let us understand how many friends people have between the ages of 13 to say 25 and from 25 to 35. So let us go with average number of friend underscore count. And we go by from FB. Now we can use a where clause for this, right? Age could be greater than equals to 13 and age is less than equals to 25. We do that and we click on dot show. We click on that and we click on play. Oh, actually, I think just a moment. What did I do wrong over here? Just a moment. So is the age correct? Okay. Just a moment. Yeah. So actually, I got confused for a second there and implemented the Java equivalent over here. So I shouldn't have done that. The and percent symbol doesn't actually work with SQL. So for the people with the SQL background immediately notice that. So I forgot about that. Yeah. So when we use the and, it actually works with that. Sorry. So thank you, Deepak, for correcting me. Yeah. So yeah, I use the and percent symbol there by mistake. So when you use the and, we get the average friend count, 268. So that is the average friend count of a person that is on Facebook between the ages of 13 to 25. And when we change this to something like 26 to say 50, so let us see how that works out. So that is significantly less. That is 113. That also tells us about age demographics. If we want to find out the usage of individuals on Facebook. So there are two data columns that are available. That is the mobile likes received and the www likes received, right? Not www likes and the mobile likes. So these might seem like normal sort of columns that are there. We can also determine the usage of individuals, like at an average. People say between the age of SQL and just a moment, spark.sql select average, and we say if we want to find out the mobile likes, we copy that column name and we put it away, and we take average the website likes, so Facebook from browser and Facebook from mobile applications, from FB where age is greater than equals to 13 and age is smaller than equals to 25, and we type in a dot show over there. We do that and we click on play. So we can see that the average mobile likes is about 223. So this gives us an idea essentially that the web browser usage is quite low these days because everybody has portable devices, right? The usage of computers for accessing social media websites is quite low anyway. So we can see that this from this particular data that we have, right? And if we change the age as well to see if there is any difference between older people and younger people, so we can type to 20 greater than equals to 26 and 50 like the previous. And when we do that and we click on play, so we can see that it's less, but the ratio almost remains the same. So it's mobile likes higher and average web browser likes are low, right? So these are sort of the things that you can do with it. You can also perform some complex mathematics with it as well. So these are sort of the things that you would have to do if you want to find out any relations between the data. So this will tell you about this before the course advisor actually joins us, right? Just a moment. So instead of using the Spark SQL context, right, you can do some other things as well. So data frames are not just limited to Spark SQL. There are other ways you can refer to them. So for instance, if you want to use something other than Spark SQL, right, if you're coming from a development sort of background and you want to do some complex modeling with your data, right, in that case, you'll use the group by like directly on the DF instead of using the FB, which is the virtual name for that in these SQL context. You'll use group by. And for instance, if I want to refer to a column name in group by, right, so I can simply type in, for instance, age. For instance, age. Let's use age. Let us group all of the data by age, right? And then once we've done that, and we want to do something else, for instance, we want to calculate the average. And for average, I mean, say we want to find out the tenure of the person on Facebook, right? So let us use the tenure column name. So once we've done that, then we will type in order by. So we will sort this data by the, let's say, age. We want to sort this data by age, right? From lower to higher, we want to sort it like that. And then if you want to sort it by lower to higher, we can simply go ahead and given the ascending value as true. If you keep it, if you don't actually add this, it's by default considered to be true, right? If you want to actually arrange it in descending order, right, it'll actually give you the data in descending order. So firstly, we'll do it in descending order, then we'll do it in ascending order, right? And we type in dot show. So once I do that, and hopefully if there are no mistakes, it should run. So there's an issue with that. Tenure is not a numeric column. All right, so this particular column is not entirely numeric, I believe. So there's some problem with the data set in that regard. So I'll not use tenure. Let us use something else. Let us use friend count. Yeah. So there must be some string values as well. So it's not entirely a numeric column, in my opinion, then. And there are string values in that as well. So we'll change this to friend count and click on play. So that is something that we have. So we can see that there are people who've given wrong ages as well, or maybe impossible ages as well. There are as high of ages as 113 that are there on Facebook. So that is there, and the average friend count, which I believe for the person that is of 113 age on Facebook, is about 334. There's 112 and so on and so forth. If you want to see a lot of these to us, so if you type in 113 over there, we'll see 113 records. We click on that, and it starts from 113. It goes all the way down to I think it will go down to 1. And it'll actually not go down to 1. I think the minimum Facebook age limit is 13. It will go down to 13. So it goes down to 13. And from 13 up, we have this. And if I simply remove this and click on this particular button, the play button, we get the data in ascending order as well. So it starts from 13 with the average friend count is about 164.75. And we go down, we get the average friend count statistics for every age. So this is how easy it makes this particular job to be, right? So hold on tight. I'll be contacting my course advisor now to guide you guys with the career opportunities that PySpark has, the career opportunities that Big Data has in general, to guide you with any of the questions that you have career-wise. So I'll resolve some technical doubts before I actually do that. How do we integrate Spark with machine learning? So Spark also comes in with libraries called mlib. Like Spark has a library called mlib. Spark mlib deals with the cluster-based machine learning computation. So basically, creating machine learning models is a very daunting task when you're dealing with big data, right? So you're not going to be actually dealing with machine learning in a linear sort of format on one system. You're going to be dealing with creating machine learning models using the processing power of multiple systems. So for that case, Spark also provides the mlib libraries, which you can use for machine learning purposes. Okay, for data science roles, how much PySpark is required? Okay, so this is quite an interesting question. For data science at a base level, you don't need PySpark at all, right? If you're dealing with data analytics, right? Data analytics on its own is not that well of a paid sort of a profession, right? Data analytics is the entry level profession in data, right? It's the basic level profession. When you get into big data, you get quite a high bump in your career resume, so to speak, because you now know how to handle data at a very grand scale, which is the case with a lot of big companies today, right? So once you understand how big data analytics work, like data analytics when you're dealing with big data, right? Then using that knowledge, you can integrate that pretty easily with your Python knowledge, say for instance, in data science, right? Or your R knowledge in data science. So instead of doing your data analytics, data science jobs on small data sets like you were doing earlier, now you're doing that same job on big data. And that is what is required in today's industry. Somebody who knows big data and is implementing data science with big data, using data visualization with big data, using cloud services with big data, and then implementing machine learning and artificial intelligence with big data, because your machine learning algorithms and your artificial intelligence algorithms will be extremely accurate if you're creating them with big data, because it takes a lot of data together to create it.
Just a quick info, guys. Intellipaat provides online PySpark training mentored by industry experts, the course link of which is given in the description below.